This meeting is now being live streamed. Do you wish to leave before you are spotted on YouTube? No, I guess we'll stay.
I'll stick around just for the fun of it anyway.
All right. Now, Liam, I don't have host privileges on YouTube. You do. So
yeah, I'm just waiting for it to come up.
This meeting is now being live streamed.
You're live streamed.
All right. Cool. All right. We are.
I'm going to use this for the chat. So if anybody would like to ask questions, if you're on the Zoom meeting with us, you are free to ask questions at any time. If you're not on the Zoom meeting with us, then you can also ask questions by typing it in the chat. And for those of you who are out there, welcome to this year's 2021 Astronomy at the Beach. It's virtual this year. Actually, I just realized my camera wasn't on. So let's start again. And now you turn off your camera. Okay.
Oh, I turned off my camera. Yes, I did. Yeah.
All right. So welcome everyone to Astronomy at the Beach 2021. It's virtual again this year. It is not by choice. We really want to do it in person, but with the situation that's out there at the moment in the globe, it's just not possible. It's not unsafe because a lot of kids come to Astronomy at the Beach and they can't be vaccinated. So we want to make sure everyone is safe. So we're going to do it virtual again this year. Let's pray and hope that this time next year, we can actually do this in person, where we'll actually have telescopes. You can go and put your eye to the eyepiece and observe the night sky with us. So
kidnap your friends and your family, drag them down to the local drugstore and tell them you are getting vaccinated, whether you like it or not, because I want to look through a telescope next year.
Yes, you can do that too. So, hey, Brooke, how are you? Brooke saying hi. Remember Brooke from last year?
Oh, yeah.
Saying hi in Brooke Davies is saying hi from on chat.
Oh, yeah.
So as I said, then what we're going to have here is the events from the Ford Astronomy Club on this channel. We have an array of different events. We have some solar observing, which we're about to start in a moment. We have a talk from someone who is brand new to astronomy to talk about his experiences, what he liked, what he disliked, what he learned, the mistakes he made, and so on. So that's coming up.
He's not on yet. He's not on yet. So when he gets on, ask him what a full moon is.
No, ask him what a bright star is as well.
In the astronomy club, we have fun. I mean, we are constantly like nipping at each other. So
yeah, part of the joys of it, right?
He left opening and we took it.
And then we will also have some nice sky observing as well later on this evening. But we have some good content. Please feel free to ask questions. We don't bite much, so ask all the questions you want, and we're happy. We'll do our best to answer. We don't always have the answers, and that's okay. It's okay to say I do not know, and we honestly believe there's no such thing as a stupid question. There is stupid answers, and you might even get some of those from us too. So it should be a fun evening. But make it interactive. Come ask questions. Come on screen with us. Don't be scared. We're happy to work with you and help you out and answer questions for you. So let's start off, Tim. So you're going to start doing some solar observing. Yes. Do you want to show the setup that you have there first with your camera, with your laptop?
Oh, gosh.
Can you do that?
Boy, can I do that?
Can you turn the laptop and tilt it upwards? Tilt the screen upwards?
Yeah, let me try this. What if I do this? What if I try and...
Oh, yeah, dial in with your phone. Okay. So we're going to get a tour. This observatory where Tim is the HJR, or Hector J. Robinson Observatory, which is based in...
Lincoln Park.
Thank you. In Lincoln Park. I was drawing a blank for a moment. He's in Lincoln Park by the high school. This observatory was built by the high school a long time ago and fell into some disarray. And Timothy Day, if you see the three icons, you have the guy who's talking, Tim Campbell on here, Tim Day, the guy who's waving on the other side, he actually noticed this and started working with the school to raise funds. And we've revamped it with modern technology, modern equipment, modern telescopes, and now it has fantastic setup. So we're actually going to do some live streaming out of this observatory, and we're going to do what's called white light solar observing. So there is a filter on the telescope that eliminates 99.9999% of the light, so it won't damage your eyes, it won't damage the telescope. And as part of that, we'll be able to show you the views of the scope. There are some sunspots which we can show you, and we'll talk a little bit about the sun and answer any questions you have about the sun. So how's your connectivity going with your cell phone, Tim? Oh, someone's giving feedback. Who's got YouTube on?
It might be me. Hold on. Oh, it's him.
Hey, close on your YouTube.
Shut that off.
Okay.
Is that better? Sounds better.
Sounds better, yeah.
All right.
So Brooke, Brooke
Start the video.
is chiming in from Kansas. Hey, Brooke. So Tim, let me take your screen and let's full screen you. 1 second.
Oh, hang on a second.
I'm going to spotlight you. I've done it. You gave me
Okay.
privilege, so I'm spotlighting you. You're already up.
All right. There we go. Hang on a second. Make co-host. Okay, I did that. Okay, can you see it now?
Yeah.
All right.
Oh wait, no, I spotlighted the wrong one. Sorry, my mistake. Let me do this. Spotlight. Replace spotlight. There we go.
Okay. That's a good shot. So this is the telescope. Let me back out just a little bit so you can see the. Actually, let me just back out of the building. So there's the building, and you can see the big ash dome, 14-foot ash dome, with the shutter there on the back side, and then you can see the opening at the front side, staring at the sun. And then we'll walk around and go inside the door.
Oh, your phone just lost signal.
Oh, that's because
you walked away from the Wi-Fi.
John McGill is trying to call, so I have to call him back. John McGill is supposed to be on right now, so he's probably calling, trying to find out how to get on. So here's the big telescope. There is Dr. Tim Day. And this big telescope here is a Celestron C14, focal length of about 3,900 millimeters. It's a Schmidt-Cassegrain telescope, f11. So we use that when we want to see tiny things, planets and stuff like that. Up above, which is the telescope that's hooked up right now, this is a Meade 80 millimeter apochromatic refractor. I've got a white light. I've got a camera on here. This is called a Herschel wedge. This is actually safe for solar observing in small, less than 100 millimeter scopes. You can use it. You can't use it in anything bigger or you'll melt the telescope. But it is safe to use on this. And that's my camera. Up top is a Lunt 40 millimeter. That's a hydrogen alpha solar telescope. I didn't do hydrogen alpha because if you tuned in at 3 o'clock, you saw Ani doing hydrogen alpha solar observing. So we're going to do white light. I'll turn that camera on. But this is the telescope. And then around 9 o'clock, we'll be looking at planets and the moon and whatever else we can see. And the gentleman trying to reach me right now on the phone, I have to call him back, is a guy named John McGill. He's another NASA JPL solar system ambassador, and he's got a 16-inch SET, and he's going to be doing some observing tonight, as well as some solar white light stuff. He's probably trying to figure out how to join the meeting right now. So that's the equipment. I'm going to go ahead and drop off of this if there are no questions.
John the link. Let me send John the link.
Okay. I'm going to press the leave button on my cell phone if nobody else is, unless anybody else questions about it. And
no, I don't have any. Book Davey says it's a nice building. It's a nice block setup, and that's an old building. It's an old building. It's been there a long time. So I'll drop that to John. Send it to him. You're muted, Tim.
There we go. All right.
Which Tim?
Me. And then I'm going to fire up fire capture. And then I can tell the telescope to hopefully start. The sun is getting low in the sky, so but there we go. It is working. And so now all I have to do is go back to Zoom, share, and I'll say, I'll try optimize for video. I don't know if that's going to work, but we'll see what that does.
It looks okay. Yeah.
Not quite centered there. Okay, there we go. And so now you can see the sun. Let's try and zoom in just a little bit, and we'll hunt around for sunspots.
You got a bit of a window over.
Yeah, and you can see actually this is upside down, and you need to do a flip Y, and probably need to do a flip X. And then I need to zoom back out again because I have no idea. Okay, there's my sun. I went to the wrong corner. And let's just repoint the telescope to get it back in. And now this is more of a north up orientation of what you would see. If I can get that to go away. Zoom in.
Brooks Davies is saying no questions, nice scopes.
Yeah, and so there is actually a story about the telescopes here that Tim Day can tell. It's really his story to tell. But this is the sun in white light, and I'll have Tim explain the story of the observatory in a minute. So you're not looking through the big giant scope, you're looking through the 80 millimeter refractor on top of it. The special device, normally when you use a telescope and you want to look at the sun, you have to put some sort of a safe filter on the telescope. And so there are filters that look like this. Grab one. Okay, so this is one here. Oh, kind of looks like a mirror. And actually, if I were to look through this with my eyeball, I would see absolutely nothing. The only thing bright enough to shine through this is sunlight. So even if there was, like, say, a street light or something, and I was looking at it, you really wouldn't see a thing. It looks like it's completely opaque, other than it's shiny like a mirror. Some of these have a film, a little bit wrinkly. This one happens to be coated glass. Sometimes they're black instead of silver. But in any case, what they have to do is they have to block 99.996% of all the photons that come through. But generally they block 99.999, which is one photon in 1,000 makes it through this thing. If they don't block at least 99.996, then extended use will damage your eye, or has a good potential of damaging your eye. So you don't want to do that. But at 99.999, you can stare at the sun through this as long as you want, and you're fine, because so few photons are making it through. That would normally go in front of the telescope, but this time I'm letting all the light go through the telescope, and then there is a device at the back of the telescope called a Herschel solar wedge. You could Google that if you wanted to. That's not a brand, by the way. That's the type of gadget that it is. Lots of different companies will make these solar wedges, but that's who it's named for. So the Herschel solar wedge is essentially, think of it as a piece of glass instead of a mirror. And it's silvered so that only a tiny percentage of light will bounce off the 45-degree angle, because it's like a 45-degree diagonal, and all the rest of it shoots straight through. And when it shoots straight through, it hits just a metal heat sink that gets hot. But the small amount of energy that gets bounced up and into either the eyepiece or into a camera, in my case, is what we use to project the image. If the telescope is bigger than about 4 inches in diameter, what happens is it gets overloaded. So too much sun energy comes down the optical tube, gets concentrated, and it's kind of like taking a magnifying glass and, you know, catching leaves on fire and stuff like that. You would burn the telescope and damage it. But at this size, it's not dangerous, so you can get away with that. This is the sun's photosphere. So we're seeing all the wavelengths of sunlight, and dimming them so much, it looks like a bird flew in front of the telescope, dimming them so much that it's safe. When we use a hydrogen alpha telescope, that telescope blocks all of the wavelengths, save the hydrogen alpha wavelength, what is it, 656.28 nanometers, if I'm not mistaken. So that one wavelength gets to come through, everything else is blocked. When you do that, when you block all the wavelengths except for one, then you can see the sun's chromosphere, which is where you see all the cool activity. That's what Ani was doing at 3 o'clock. Weather permitting, he'll be doing it at 3 o'clock tomorrow. Actually, he'll be doing something at 3 o'clock tomorrow, whether he's showing you live images or showing you images that he captured on a previous day. But this is the sun in white light. You can do this with any telescope. All you have to do is go get one of these gadgets here that just caps over the front of your telescope to filter it down so that it's safe. And they make these in all sizes, and it literally just caps over the front of the telescope. So you measure the diameter, find a company that sells them, measure the diameter, and by the right diameter, it just caps on the front.
Yeah, Book, you just asked a question saying something about like a quark. I'm not sure what you mean. Can you expound on your question a bit, please?
Yeah, I know what a quark is.
I know what a quark is, but he said something like a quark question mark. So I'm not sure what the content.
No, this is not at all like a quark. So DASAR makes this thing called the quark, which
Oh, okay.
you put a quark behind the telescope, and typically you have to have this thing called an energy rejection filter on the front of the telescope, which is basically something like this. You're trying to cut down on the sun's energy so that only a reasonable amount flows through the instrument. And then the quark tunes it down to the hydrogen alpha and lets you basically convert any telescope into a hydrogen alpha telescope.
Right.
But those are expensive. Doing just white light, what you see me doing here, this is actually very inexpensive. These filters are, I don't know, Liam, how much would you say they are?
You can buy them for, depending on the size of your scope. Like I make my own because I buy the Bader film and make my own for my scope. But you can buy them for about $100, but it'll vary per scope and the size of the aperture you need to cover. Now there is a limit on how big a scope you should use for white light, because if you even if your scope is really, really large, let's say 16-inch, and you put a Bader film only over that, you're kind of teetering on the edge of still allowing too many photons in. So you actually need to stop down your aperture to make it smaller, and then put a Bader film over the smaller aperture. So if you had a 16-inch scope, you'd put a filter over that would drop it down to maybe 8 or 10-inch. Yeah, that's like a cover, but a hole in the cover.
But imagine if you cut a hole, not in the middle, because if you've got any type of reflector telescope, you've got a secondary mirror in the middle. So typically the hole is cut offset on one side.
Yeah.
And you just cut a hole there, and there's a filter over that hole. And that basically turns your gigantic, 8, 10, 14-inch, whatever telescope into something that's more like a 4 or 5-inch telescope.
Yeah. So, but as I said, I make my own. But if you're using one of those caps in your scope to drop down the aperture, they're obviously going to be a lot cheaper because they're smaller. But they're not very expensive to make your telescope safe. Now, you have to make sure it fits tight, and you have to make sure it's secured on and doesn't move after the fact, because if it does, while you're looking through the eyepiece and that falls off or the wind blows it off, it'll be like a laser. It's like getting LASIK on your eye, but the only difference is it's not medical and it will destroy your eyesight. So you make sure whatever you put on fits tight and it's actually secured on so it doesn't fall off while in use.
And on that note, I have to impose upon Tim Day to tell us a story. Tim will regale us of when he and another club member, Greg, were using his telescope, one of his large Meade SETs, to do solar observing. And all was well with the main telescope, but all was not well with the finder. So Tim, go ahead and tell us that story.
Can you guys even see me? I'm not sure if I'm visible or not.
We can, let me do this. I'm gonna spotlight you.
All right, I'm muted.
Oh, you have two things open.
There we go. Okay, try it now.
Okay. Yeah, the story is a pretty funny one, and one I'll not soon forget, or apparently anybody else in my club. I was with my friend Greg Connectland, and we were making these Bader film solar filters, and we would take almost like a round hoop, like bamboo or something, and we would put an appropriate amount of Bader film, and just with that little offset circle, as Tim Campbell was describing, because you don't want to let all the light through. And we were getting close to being ready to done. And what I did was I had a cap in front of my finder scope and a cap behind my finder scope. And when we were close to the sun, I took the cap off the front of the finder scope, never intending to look through it. And I forgot that little tiny plastic cap at the back of the finder scope. We slowly moved the telescope until we were looking through the Bader filter, looked through the eyepiece, it's safe. Oh, glorious sunspots, prominences, all sorts of stuff. And then right to my left, I feel this funny smelling, burning plasticky type thing. And I pull away and I see that the sun going through the front of the finder scope where I had taken the cover off was now burning a neat pinhole through the cover scope on the back of the finder. And it also burned the crosshairs embedded in the glass on the front of the fiber so that they curled away.
And they're metal.
So I took that to show and tell next time we had a meeting, and I passed it around, and There was a lot of good humor directed at my direction. And that story has never gone away, nor, in my opinion, should it.
Yeah, but those crossers are made of metal.
Hands-on demonstration. Don't point things at the sun.
And we've shown this to students and say, now imagine this was your eye.
Right. You know, you get away with glancing at the sun for 1/1000, and then you see purple spots for the next couple of minutes. That's a warning sign. That means your eyeball has used up all of the pigment that it had available to tell you that you were looking at something bright. And basically, it's busy trying to replenish itself. If you look too long, it's unable to replenish itself. It never comes back again. And as Tim Campbell was saying, sometimes you don't notice that the same day. Sometimes you wake up the next morning and you go, hey, I'm blind in one eye. And that would be a sunburn on the back of your retina. So take it seriously. That said, it is possible to look at the sun and to see amazing detail, things that just aren't visible any other way. So be careful. The first few times you do it, have a partner, have somebody who's done it before you, and let them sort of hold your hand through the process. And then once you've done it several times on your own with that partner, then you might consider doing a solo flight from there on. Yeah. But there are definitely some rules to preserve your vision. It's not a game for beginners.
Yeah, Brian said better the finder than your eyesight, and we agree.
My voice is going. Okay, all right. I'm sorry, because I
all right.
I actually take my finder right off.
Yeah, a lot of people would take the finder off and they'll put on a solar finder, which is basically a pinhole with a dot in the back, and you align one to the other.
Which is what we have on our solar scope here at the observatory.
Feedback again. Okay. I think Tim unmutes, and then when you speak, we get the loop. Tim Campbell. So yeah, so actually let me spotlight you there, Doug, so you can show that. 1 second. Let me
turn off my.
There you go.
Yeah, let me turn off my background because it's
Oh, because of the black surface.
Yeah. Hang on a second. Let me just turn this off.
Are you about to share screen?
Yeah, he's just going to show his solar finder.
Oh, okay.
I'll connect. Advanced. Okay. Well, anyways, let's see if this works.
Yeah.
Oh, that's good.
If you put your hand behind it, hold it like this, that way. No, the other side. Yeah.
So it basically, the pinhole's on this side and it goes against this little white dot there, so you can line it up that way.
Yeah.
But that's a simple solar finder. There's a little stand that goes on the mount or on the scope. You can just drop that on there.
Yeah, and a lot of cases it goes into where your it slots into where your finder is. You take your finder off, you put that on for solar observing to find the line of the sun.
And you're safe because you never look at the sun itself.
Right.
Yeah.
So my point is, I take my finder off my 6-inch. So the only thing it's looking at the sun is the 6-inch. It's got a solar filter on the front. And luckily, like this morning when I put the 6-inch on there, I did a warm start on the mount and said, go to the sun, and it was in the field of view. So I didn't even have to use the finder.
Cool. Well, yours is on a pier.
Yeah. Yes.
That makes life way easier.
Mm-hmm.
Yeah. Doug has his own own observatory at home, so it makes life way easier.
So warm start is in Losmandy parlance means my telescope was previously aligned and nobody has moved it since the last time I used it. So there's no reason to realign it the next time. It's lets you jump start.
Yeah.
Actually, there's two modes. There's the warm restart, which can start from wherever you parked it. The warm start starts with counterweight down. as opposed to the cold start, which I've actually normally started with the cold start and just plate solves as the first object, and then I'm synced anyways.
For night sky observing, yeah.
Yes, yes. But what was nice is the warm start. I took the refractor off, put the 6-inch on, put the filter on, booted up the computer or the scope and said warm start, and it says go to the sun, and it was in the field of view. So it, I even swapped telescopes, and it still was in the field of view.
Yeah, but it's the scope it's the mount that gets you there, not the scope. So
right.
So if anyone has any questions, feel free to ask questions. Put them into chat if you don't want. You're going to put them in chat if you're on the Zoom meeting with us. You can type them in chat here. There is a chat function. It's at the bottom of your screen. If you're on YouTube, type into the chat on YouTube, and we'll try to address your questions. And so please don't be shy. Tim, are you going to share out the scope again, please?
Yeah. So let me.
It is.
Okay. So, Ms. Campbell, if you can share out your screen
Okay.
again to the scope.
Yeah, I was getting some echo, and I was having Tim mute.
Well, the echo was coming out of Mr. Day's machine, so I just muted him.
All right.
Because
Okay,
when you're
great.
both on in the same room, you're getting the feedback. That's
Yeah.
what's happening.
No, I'm with you. So Tim is actually sneaking off. He's got a previous engagement, which will steal him away from us for a few minutes, and then he'll be back.
He's getting out while the going's good.
No, I'm coming back for the good stuff.
I know.
Jupiter, Saturn. Ooh la la.
Oh yeah, the planets tonight would be nice later on.
Now, so while I'm sharing this, John McGill finally joined, and John also has his telescope set up. John, did you set up for white light?
Is he muted? Are you muted, John?
It doesn't show he's muted, but I'm seeing white where normally I would see him.
Yeah, I don't think he connected properly. You may need to reconnect again, John. It looks like you're having issues. So we'll wait for John to get back to us. Unless that's the view of the sun from his scope.
I am not. That's yeah, true. That's the magnified view.
Maybe. So, so Tim, explain to everybody what a sunspot is, because that's what we're looking at right now.
Sure.
Oh, I'm sorry.
The sun, yeah, and I'm actually eating. You can get a bite, but let's talk about the sun. The sun is not solid; it's a ball of gas. So it turns out, unlike a rocky planet, where the planet spins as a solid piece, the sun does not. Actually spins a little bit faster at the equator than it does at the poles. This twisting and rubbing of the gases builds up charged fields. And so instead of having a really neat north and south magnetic pole like the Earth does, although the sun does have a north and south magnetic pole, it starts to get these very strong magnetic lines. It's kind of like tying rubber bands into knots. And they just go in every possible direction. Here, let me undo my camera so that you can, where's my, there we go. So they're kind of tied into a bunch of knots. And so these magnetic lines come out of the sun at one point, often loop into the sun at another point. So for example, down here, I don't know if you can see my mouse moving around. You can see some sunspots down here and one over here. Wouldn't surprise me if something is actually coming out of the sun, looping over and going back into the sun there. I don't know if that's what's happening. I'd have to look at the sun in a hydrogen alpha wavelength to know that. But that sort of thing happens. And so this magnetic field is sort of pushes some of the surface granulation of the sun aside. And the temperature of the sunspot is actually a little bit cooler than the temperature of the rest of the surface. So this is the photosphere of the sun. And the sunspots are these black things. Now they're not actually black in real life, but the camera is tuned to the brightness of the entire disk. These are just a little dimmer. So by the time I dim the disk of the sun so that it looks nice, these look practically black. And they're actually a little tiny bit cooler than the rest of the surface by about 5,000 Celsius.
Yeah. So, So as Tim was saying about the knots, so they and from these sunspots around them are loops of magnetism, and then if you were looking at the sun in hydrogen alpha wavelength, you would actually see two things. You'd see it create around the sunspots what's created as prominences or filaments. Now, prominence and filaments are the same thing. You cannot see them in white light. You're only visible in hydrogen alpha wavelength. But what they are is a prominence and a filament are basically the same thing. The only difference is the way we look at it. So when you look at it from above and it looks like a streaky line on the surface of the sun in hydrogen alpha, that's called a filament. But if you're looking at it around the edge of the limb of the sun, so you can actually see, oh, you want to share your screen?
No, that's fine. I was going to show something else.
Oh, okay. Oh, you're going to get up an image of it? Okay. So when you're on the limb of the sun, you see the shape of that plasma being pulled up through the magnetic field lines that are coming above the sun's surface. That's called which is the same as a filament. We call it a prominence because we can see its shape on the limb of the sun. So what are you going to share with us, Tim?
I'm just gonna, I'll just share I'll share this in the chair. So there you go. This is the sun in hydrogen alpha. Now this has been processed, but if you look through a hydrogen alpha solar telescope, this is actually roughly what you do see with your eyeball. Actually, this is, you don't need special cameras and processing. If you want to capture a picture of it, yeah, now you need special cameras and processing. So if you were on during Ani's talk, he captures a few thousand frames, finds the best looking ones, stacks them, resamples them, sharpens them. The camera that I'm using actually only captures in monochrome. It's not actually a color camera because you're only letting one wavelength of light through the telescope. So basically it's monochrome anyway. So if you used a color camera, the green and the blue pixels on the camera would never pick up anything, only the red ones would. So just use a monochrome one. I convert it into a color image later. But this is the stuff Liam was talking about. If you look way down here, we call these prominences around the edge. These are these things that are sticking out of the sun. But if you look at these little snaky lines on the surface here, there's one there and one there. Those are what we refer to as filaments. They are not laying flat on the surface of the sun. They're actually, if you could imagine, three-dimensionally risen up off the surface. So if you could imagine rotating the sun around to the side, you would actually see this thing arcing out and back in.
Yeah.
Just like a horseshoe.
Yeah. So, and sometimes they're like a cyclone. They twist and they rise up from the surface of the sun, and then they eventually collapse and fall back down. They vary in shape and size. Some of them will look like pillars. Some will look like big arcs across the sun, across the limb. They vary in sizes. So if you look in this image that Tim has, on the very bottom there, directly at 6 o'clock, you have a large prominence, right? But if you look to either side of it, there's really small ones on either side. Yeah, scroll down. See, there's much smaller ones on each side of it. And they may not, in most cases, they're not linked to each other. Some may be, some may not. You see more small ones there on top. So they vary an awful lot in size and shape. But they're generally an arc leaping from one sunspot to another in most cases, or from the edge of one sunspot to the other edge of it. But it's often sunspots generally appear as in most cases are in pairs, and it's often leaping from one to the other is what you get those arcs from. But they are knots in the magnetic field, twisted up, and they pull out the super hot plasma.
In terms of size, you can line up edge to edge 109 planet Earths from the left edge of the sun to the right edge of the sun. So the sun, the Earth is this little itty bitty tiny dot thing compared to the size of the sun itself. And so each one of these prominences, even the small ones that you see, are bigger than the diameter of our planet.
Yeah.
So they're huge. I sometimes tell the students, I said, imagine you have a flamethrower and you got a pretty good one. You can squeeze the trigger on that flamethrower and shoot a flame that goes from where we are in the United States and lands in Australia. That'd be a pretty big flamethrower, I think you'd all agree, that flamethrower, that powerful to be able to shoot Australia from the United States is nothing compared to the size and the energy of these prominences that you see shooting out of the sun.
Yeah,
Another-
if you could capture that energy from a small one, you could probably run the planet for 100 years on this.
Another thing about the prominences is if you look at it as a horseshoe, and then what happens sometimes is they twist. And when they twist, this causes the short, and then this top part actually blows off. And that's what they call a coronal mass ejection. And so sometimes those are what heads towards Earth. And when it does that, you can get the northern lights.
Yeah, so yeah, correct. Northern lights are created by energized particles released from the sun in CMEs, and then when it comes by Earth's magnetic field, the north and south magnetic fields, because the fields curve in towards the north and south of the planet, draw in that material, those charged particles, and it excites the gases in the upper atmosphere, which is why and the different gases is why we get the different colors for the northern lights. Book Davies said something about the Planetary Society flying the Light Sail 2 in orbit. I believe they still are flying it, aren't they? I think they are. You know, the solar sail by the Planetary Society. I think they're still flying that. So Astronomy Crazy Man says hi to everybody on
Hello.
YouTube. So again, guys, if you have questions, feel free to chime. John, tell us a bit about your scope.
Oh yeah, that's we can look at it here. From where I was sitting before, you really can't get a good idea of the size of it. But here, this is over 5 foot right here. So this is 5 foot long. This part here is a dew shield or a light shield also. And so this really isn't part of the scope. The main scope is right here. And this is a SCT, a 16-inch Schmidt-Cassegrain telescope. I picked this telescope up out of observatory in a college. It was Montgomery College out of the East Coast. And basically, it's an observatory grade telescope. It's one of the ones that you may see if you go to a college, but most colleges nowadays, they only have telescopes that they hook cameras up to. Very few colleges have telescopes that you actually look through.
John, there's a question about the shark. I know the story, but it's best if you tell us.
Okay. Since this is painted white, I nicknamed it the Great White Telescope, or the Great White Shark. And the reason I called it the Great White is because it feeds on light. So it's a light bucket, and it just devours any light that it's gets in its path. So that's why I call it the Great White.
So are you pointing at the sun right now?
No, I'm actually pointing to the northeast.
Okay.
I'm pointing away from the sun.
Are
It
you
has-
are you gonna show Venus or?
Nothing right at this moment. I just was setting it up for later tonight. I
Okay.
did have my 8-inch SCT. Let me show you that one. This was my solar observing scope, but that one, the clouds, or not the clouds, but the sun went into the trees back
Yeah.
over here. So it's not
Two
worth
things we
showing.
need in Michigan: cloud and tree filters.
Yeah. So like I say, that one was set up, but it didn't pan out today. So
Hey,
that,
John,
yes.
they're asking you how much does it weigh?
Oh, that weighs about 300 to 400 pounds altogether. If you look there, I have it on wheels, and it's on they call it a wheelie bar. And that has 6 wheels that it uses to move it around. So that helps me get it in and out of the garage. But when I do take it to star parties, if you look up on top, you may see that gray or silver bar that's on the top. I hook a clevis to that, and then I have what's called a buck hoist. And what a buck hoist is it's kind of like,
It's a crane.
yeah, it's a crank.
Hand winch crane,
It's
yeah.
it's a crank like that's on a boat trailer, you know, to pull the boat onto the trailer. Well, this crane or buck hoist, it goes into the trailer hitch on my truck. And so then I can crank it up and pull it off and take it apart.
It's,
I have done it by myself, but it really, two people is better because one needs to guide it when it's going down.
And 3 makes it way easier, remember?
Yeah. So,
Yeah, and you also remember the upper part of that scope and the bottom fork. So the scope and the motorized section at the top is one unit, but the forks do
Yeah.
come, so the top part does come off the bottom part. So the forks and the top and the scope itself are separate units. They
Yeah.
get bolted together after when you assemble. So it is, you're not moving the whole unit as one. You're actually moving it in 2 components, but it's still very, very heavy.
yeah, and when you do pack it, it goes into 3 pieces. So that top part would be 1, this middle part, forks, would be 2, and the base would be 3. But when I just tear it apart to take it to a star party, the forks and the base stay together. And the tripod, this tripod weighs probably 150 pounds by itself. So it is a massive piece of gear.
Okay, we're being asked by Astronomy Crazyman, has anybody ever dropped a scope? Personally, no, I have not.
I
I
have
make it my
not.
business to be super careful because they cost so much. The last thing you want to do is drop it, because the moment you do, when you pick it back up, you walk over to the trash can, you drop it in, you buy a new one because you'll probably damage it so bad. Chances are. So, no, I've never have. Has anybody else ever dropped a scope?
I do repair these telescopes, and you know, that's basically how I got this one. But I've had a couple of them damaged in shipping, but luckily I've been reimbursed by FedEx for each telescope that I had damaged. What they usually do is it falls off a shelf in the truck, or they drop it off the back tailgate and drop it down. One thing that I have to say is a lot of people use Bob's knobs on the front of their telescopes for culminating the corrector plate, or
Yeah.
the secondary mirror
Mhm.
on the corrector plate. And sometimes the Bob knobs actually stick out further than the ring of your telescope base. And so with it sticking out further, it's basically on larger telescopes that will cause the front cover. I can't demonstrate it, but the front cover will
Will
push.
hit the secondary.
Yeah, we'll hit that, and then that breaks the corrector plate. So
Hmm.
that's usually why you always see people looking for secondary or corrector plates for their SCTs, because they broke them. Usually it's with Bob's knobs. And the corrector plate is actually matched with the primary mirror. So you can't just put any corrector plate on there. When Meade builds them, they go through about 10 of them to find the one that matches the best. You know, they're not made in pairs, but they match them up to the best case scenario within tolerances.
Cool. So anybody else ever drop a telescope? No?
I have not. No.
Yeah.
It's
Yeah,
not a good idea. Yeah, you want to be careful.
you'll
I
find that
did-
most astronomers are super careful with their equipment because we know how much they cost, and we know that replacing them is not always easy because of the cost. So we're normally ultra careful. We pack everything in really carefully when we do transport it. A lot of us use Pelican cases to transport our equipment in to make sure that no matter what happens, they're protected. I know I use Pelican cases for most of my scopes and mounts. I know Tim does. John, you have big, large foam boxes filled with foam, properly shaped foam for yours.
Yes, and
That's cool.
I also, for my smaller ones, I use a JMI case,
Yeah.
which I call a coffin.
Yeah.
You can almost fit a body in it.
Yeah. So a lot of us are super careful because we know how much the stuff, like the equipment is, telescopes don't have to be expensive, but it can get that way depending on what equipment you want to use and what you want to get into. And if you do that, yeah, it's kind of, you take care of it like a child, because if it gets damaged, there's no one to blame but yourself, and it's hard to repair them, and it's often hard to replace them in some cases.
Yeah, this one behind me, if you were to buy that one brand new, that's about $16,000. So that gives you an idea. My little one over there, that's about $3,000. So
yeah,
whatever way you're looking at it, you're more than $1,000.
Okay, so we've got some questions. Let's see. Book Davy says it's nice about the scope, but he says his 10-inch reflector is plenty of weight for him, which is, yeah, 10 inches is a good size weight.
Is it a Dob? Book, is it a Dob?
Yeah, I think it's a reflector. So I think it's a Dob for a 10-inch.
You could put it on a mount.
Yeah,
Probably a Dob. But Dobs are nice and manageable because you set the cradle out there and then you just set the optical tube on it.
yeah.
Yeah,
So Astronomy Crazeman is asking, how do you deal with the public wanting to touch your telescopes?
I got the perfect answer for that one, guys.
We have a cattle prod? Oh.
Here, let me show you this. This is my observing stool. And what I do with this is I will put it right in front of the telescope. And then I have people kneel on this when they look, and I tell them to hold on to the top part. So when they hold on to this, they're less likely to grab at something. That works especially well for kids.
Yeah, I do the same. I have a stepladder, a small stepladder, for depending which scope I'm using. And on that small stepladder, I have I get them to walk up the stepladder and hold the stepladder. Or if the eyepiece is too tall for that ladder, I actually extend out my arm and say, put your hands here and rest your weight on my arm when you're looking through the eyepiece. That way, then it's me there's actually touching me and not actually at the scope, because the kid's automatic reaction to something is go like this.
Yeah.
Right?
Yeah, and they pull it to themselves.
Yeah.
So, so I kind of caution people because I say, look, you're looking at a teeny tiny piece of the sky, and if your inclination is to grab it and bring it to your eye, you just moved it. Now it's going to take the astronomer several minutes to get it back on target. Now, as a safety precaution, I should mention that there are no hard gears between the motor and the mount that moves the scope. It's more like a brake system or a clutch. And so we can loosen or tighten that clutch. So I actually put mine so that it is just barely gripping enough to hold the telescope in place. So if somebody knocks it, I want the telescope to slide. I don't want that on so tight that it's forcing gears to turn that don't want to turn. So I make it just a little bit loose as a safety precaution. I would rather the clutch slip, and then I just repoint the telescope.
Yeah. So now, so as you saw here, both the one here in the observatory is on an equatorial mount, right? He's got Tim has an SCT there and a refractor on an equatorial mount. The two that John is showing are both SCT, Smith-Cassegrain telescopes, and they're on an alt-as mount, so they're fork mounted, so they do alt and as. They actually move left to right and up and down, whereas the equatorial is a different mechanism. And Doug, in the background of Doug has there in his background, it's actually an image, but let's showcase Doug for a moment, and we can talk a little bit about his setup. So Doug's setup is on an equatorial mount, and his scope though is which scope do you have again on that?
That's a 10-inch Ritchie Chrétien. It's like a Cassegrain. It's in the Cassegrain type family, like the Schmidt Casses and the classical Cass. This is a Ritchie Chrétien design, which has two hyperbolic mirrors on it. That's the one I do all my galaxy and comet work with.
Yeah.
But right now, I just happen to have my 4-inch refractor on that mount for tonight's session that I'll be doing.
Oh,
But
cool.
on that scope, you focus the scope that the camera itself is moving forward or backward, or the eyepiece, if you had an eyepiece in it. The mirrors are fixed. They don't move.
That's correct. That is correct. I have a, if you look here, I have a little, at the back end, there's the black device that comes right off the scope. That's a focuser. So the focuser moves the cameras back and forth or the eyepiece back and forth to get it focused. So the primary and the secondary do not move.
In fact, you have two cameras at 90-degree angles to each other.
Yes, that's, I'm using what's called an on-axis guiding port, which allows both cameras to see exactly the same field of view of the 10-inch. So the 10-inch is not only imaging with the camera that's pointing 90 degrees, but it's actually guiding as well with the camera that's straight through. That's why there's two cameras on that guiding port. What that means is I don't have to have a second telescope on top to do any auto guiding. The 10-inch is doing not only the imaging, but the auto guiding at the same time.
So one camera is taking a 5, 10, 15-minute, whatever duration exposure, and the other one's taking an exposure every 2, 3, 4 seconds.
Yeah, 2 seconds typically.
And then if the star that you picked on as a guide star appears to move even by a fraction of a pixel, computer notices that and nudges the mount back on track.
Correct. Not only that, but I've also used a tool called Focus Lock, which looks at that guide camera star and determines if it needs to refocus the image train. In other words, since they're both cameras on the same focuser, if the guide star looks like it's out of focus, Focus Lock will move it back into focus, which also focuses the primary camera. So I've got a closed loop focusing system on here too.
And you've explained to me, Doug, but I'll have you explain it to other people, that the distortion that mirror creates kind of makes the guide star look like a plus sign. And if one direction of the plus line is longer than the other direction, it tells it that the focus is too far, or if the other direction, maybe it means it's too close. So it not only knows it's out of focus, it knows which way it needs to move.
Right. It basically, so you have the first black item there is the focuser. The second black item is the on-axis guiding port, which has a 45-degree mirror in it that lets near infrared through to the guide camera and all the white light 90 degrees down to the imaging camera. Well, when it does that, it deliberately creates what's called a stigmatism on the image that the guiding camera is looking at. And it does exactly what you're talking about. If it's out of focus in one direction, it gets oblong in one direction. If it's in the other direction, it's oblong this way. That means it's either inside or outside of focus. So its ideal is to set it up so it almost becomes a diamond shape or a trapezoid. So that's what it's going to try to do, is create as small a centroid as it can to keep focus. And it also improves the guiding.
So I want to put
a question here about, can you visually look through your scope?
Yeah, the whole black unit with the two cameras on, 3 screws come off, it pulls it off, and I put a diagonal in an eyepiece and I can look through it. It's like 90 seconds to switch over to an eyepiece.
Yeah.
So I want to put you on the spot with another question, which is, you can see John's scope is on this very nice cradle supported on 2 sides. He can spin in any direction he wants, up and down. And you've got this crazy contraption off on some askew angle with a telescope hanging over to one side. What's up with that? Why would you have a telescope mounted that very complicated looking way?
So it's what's called a German equatorial mount. And the mount itself, one of the axes is pointing at the North Celestial Pole, which is the same pole that the Earth rotates around. So I'm pointing in exactly the same angle and direction as the pole of the Earth is pointing at. So I'm only having to compensate on one axis for the rotation of the Earth and not both axes.
So the Earth spins west to east, and it spins east to west at exactly the same rate.
Yes.
And then you were about to say something else, and I interrupted you. I'm sorry.
Well, the reason you want to be polar aligned is so that when you're imaging, you don't get any what's called field rotation, which means you're having to switch on both axes. You're having to move on both axes. So you only want to be able to have to guide on our track on the primary axis, which is the right ascension.
And so John's scope, being on forks, has to move 2 axes. It has to interpolate moving 2 axes at the same time. And it's not even a constant rate. It's the rate varies depending on where it's pointing in the sky.
That's correct.
And his image slowly twists over time.
Correct.
Yeah.
So
Yeah, so you can compensate for that in when you're processing your image. The only part that doesn't work is if you have, say, some trees or something in the background, if you're taking something low to the horizon, so that you know, you get a reference point. But if you do it with you know, with that, you're going to see the rotation.
well, the thing that you can compensate with mechanically on your scope is if you got what's called a field derotator, that basically is a focuser and a rotator. And that means that it coordinates with the alt-azimuth movement of the main scope by rotating in the third dimension. And that's another way you can take long exposures. That's how the pros do it on all their alt-azimuth mounts.
I was
They
going to
have
say,
a-
because those telescopes simply weigh too much to hang off on a German
Right,
equatorial
right.
mount.
Yeah, you'll notice that all the pro mounts are alt-az, and they have field derotators basically, so they can take long exposures. I mean, I can take 15-minute exposures with this mount without, and I don't have to worry about field rotation. In fact, when I put the refractor on there last week, took M31, I didn't even auto guide. I just let it track, and it worked out pretty good after 6 hours of data.
There's a
that's-
question about how much your setup costs, Doug.
If you don't include the building, but you include the computers, it's about 15 grand.
So the Losmandy, you have a G11 Losmandy mount?
Yeah, that's about $3,400.
Yeah, it's about 3.5. Yeah.
And then the scope is about 3 grand. I got $5,400 worth of cameras, a $900 focuser, a $900 on-egg.
The on-egg, by the way, is the on-axis guider.
Yes, it's the on-egg. A lot of people will use a separate scope for guiding, or they'll use what's called off-axis. The reason I went with the on-axis is because I could put a big chip in there, and I don't have to worry about, because I can see the entire field of view that the 10-inch is projecting, and I don't have to worry about it finding a guide star automatically.
Yeah.
Doug, they used to make one camera that had a guider built into the
We
image
do
Yeah,
have
so-
those. Yeah, they
yeah,
still have
software
those.
biz
They're
does.
expensive. Yeah.
Yeah, and what happened with that? Because those don't seem to be too popular.
I don't know what the reason why they're not popular anymore, other than the fact that they intrude on the optical path.
Okay.
They, yeah, well, I suppose I run a full frame camera on my mount. And I still have an off-axis guide chip. So this is a little pickoff mirror about the size of your pinky fingernail over on the edge of the frame. What happens is the quality of the optical field starts to degrade as you get farther and farther from the center. You start to pick up coma and astigmatism, and the focus isn't so good. It actually turns out not critically important for a guide star to be tack sharp because the software just sort of treats it as like a oblate, shape, and it's basically finding the mathematical center of it. It doesn't have to be a pinpoint, and it's actually okay with that. But I think one of the other things is a lot of those cameras made by companies like Finger Lakes and SBIG were very expensive CCD imaging cameras, because the CMOS cameras, those are the types of cameras that everybody has in their cell phone. And, if you have a DSLR or something, those are all CMOS cameras. They were good at very short duration exposures, click, you're done, right? In astrophotography, you're opening the shutter and leaving it open for many minutes, 5, 10, 15, maybe even 45, right? Some images can go really long, and CCDs were always better at those long images. Well, the lines now, technology's marched on, and the lines that separate the CMOS from the CCD have really been blurred. So it's not really necessary to have one of those CCD imaging cameras anymore. And I believe neither of the cameras on your scope, Doug, are CCDs. Those are both CMOS, right?
All three, yeah, all of them are CMOS. My Pole Masters are CMOS, my DSLRs are CMOS, my pair of 071s are CMOS, and my 2600 CMOS. Now the 2600 is different than the rest because it's a backlit though. So it's more efficient than all the other cameras I have.
Let me bring something into here to talk about again. This, we were talking about focusing. This is what's called the Botanoff mask. And you can see the different lines and angles that are on this. This goes into the front of the telescope, and you can take a picture of a bright star, and then it will get kind of an X over a cross pattern. And what you want to do is have all those lines get centered and come together. And if you're not focused, one of the lines will be off from center or more will be off. So this is a pretty handy tool for getting your focus precise.
It's quite clever. It plays on the wave nature of light, that anytime photons traveling as a wave hit an edge, such as the slots that you saw cut in there, they will bend essentially orthogonal to the direction of the slot. So you can see 50% of the slots are going, left, right, and about 25% of them are going diagonal one way, and the other 25% are going diagonal the other way. So what you get is because only 25% of the slots are going in one direction, you get a short spike in that direction. 25%, you get a short spike in the other direction, and the 50% of the slots, you get a really long spike in that direction, all caused by diffraction because of the wave nature of light. And a very clever person figured out that if you're bang on accurate in focus, all three diffraction spikes will intersect at the same point. And if you're off focus, they won't intersect at the same point. And so it's really easy visually to find out when you have achieved absolutely the very best focus possible.
Yeah, but that enough mass are not the only way that we actually focus. With modern technology now, we actually use our camera to actually find the most optimal focal point using stuff like full width half mass technology and so on, right?
Yeah.
They're all mathematical algorithms that it zooms in and zooms out. It goes in and out of focus, and by doing that, it measures the change in the star.
Yes.
And using mathematical algorithms, it actually calculates where the optimal point is, where there is the least deviation in the diameter of the star.
Yeah, if you were to make a three-dimensional graph of a photograph of a star, where the surface of the graph does not rise everywhere, the background is just black, and the more light you have, the higher up it rises. What ends up happening is you get this, if you've really nailed the focus on the star, you get a whole bunch of blackness and a really skinny tall spike. Whereas if you're out of focus, the spike is not so tall because the light is being distributed across many, many pixels. And so what the computer does is it takes an image, measures how many pixels the light is spreading across and how bright they are, how high is this mound or mountain or spike rising. And it nudges the focus, does it again, nudges the focus, does it again. And it keeps doing this, and it can tell that the focus is getting better and better and better until it goes too far. And then it starts getting worse and worse and worse and worse. But it has been measuring how much it's been moving the focus motor. And so it sort of does a calculation. It says, okay, well, I can sort of draw an X shape of where it was a really wide spot that became a narrow spot, and I went too far and it became a wide spot again. I can actually calculate, well, this would be the position in terms of the number of microns that the focuser is moving in and out, where the focus would have been ideal, where that X shape would have intersected. And so it can mathematically figure that out by measuring the pixels on the sensors. Yeah,
so that's like if we're doing imaging as photography, that makes it easier because unless your telescope is made out of carbon fiber, most telescopes are made out of metal, and metal expands and contracts as temperature change. Even from when you set up your equipment, and then 2 hours later in the evening, the material of your scope, the metal, will contract a little bit. And because of that variation, by using this technology during an imaging run, you can have and have a motorized focuser. You can tell during the imaging run to stop taking photographs, focus the camera, do a refocus every hour or so to ensure that the camera is always in optimal focus as you go. Now, if you're carbon fiber, you don't need to do that because it doesn't really expand and contract with temperature variation.
Yeah, although the mirror can change as well. But Doug's software, what he was explaining, his is basically refocusing basically continuously.
Yeah.
Well, the way I've got it set up is if I'm not using the ONAG, I use the SG Sequence Generator Pro's method of finding the peak value. Okay. If I'm using the on axis, I set it up to look at 15 frames or 20 frames. It takes like 2-second frames. So after 20 frames, it does a calculation to determine if the deviation is large enough to bother focusing. And then it will automatically look at that pattern that I was talking about in the guide pattern and change it. So there's 2 methods that I use. One is on the refractor. As a matter of fact, I used it the other night to get it to focus. I use SG Pro. It's rare that I do that. I usually use the focus lock, but I happened to run with a focal reducer on the refractor, which means I couldn't fit the ONAG on there. And I thought, well, I'll give that a try with just a primary camera and the autofocus that SG Pro lets me use.
So Doug, what is a focal reducer?
Focal reducer is a set of optics that goes at the outside the focuser itself at the tail end of your optical path to change the focal length of your main system. So if you're at f10 and you have a 0.8x focal reducer, you're at f8 once you've used it. And what that does is gives you a wider field of view and a shorter f ratio.
And also, but with shorter focal length, you can gather more data faster. So therefore, your image, your exposures don't have to be as long.
Well, that's because the extended objects is going across less pixels.
Yeah.
So I'm holding one here. This is 6.3 f6.3. So it would turn an f10 scope into an f6.3. What's kind of clever about that is when you do multiply things by the square root of 2, basically 1.4. Every time you do that, you have the amount of light. So taking an f10 down to an f6.3 is a little more than having it, but that's the general idea. Is you get a wider field of view than you otherwise would with the telescope. But it also means that because you're pulling from a wider field of view, you're concentrating that light into a tighter space. If you said, well, how many photons land on, let's say, a 1 square centimeter area of my sensor, with a focal reducer, if you're cutting it down by the square root of 2, that means twice as many photons are landing in that square centimeter. So now your exposure is half as long and you're getting a wider field. At an expense, though, of usually the outer area of the field, the quality of the optics usually goes down. So now you end up, because it's usually just a focal reducer, so now you need like field flatteners and things like that to try and correct for that. One optical thing that helps you causes other optical problems that hurt you, and just spend more money.
Yeah.
So
Go on.
go ahead.
No, good, please.
I was going to say that Tim's CDK has got optical set of lenses near the focus as well for flattening it out before it even gets to the camera.
Yeah, the telescope that I use, which I'm not going to be using tonight or tomorrow, but that telescope has a field that's guaranteed to be, quote unquote, optically flat with respect to focus, with respect to coma, and with respect to astigmatism. That has a diameter of 50 millimeters from edge to edge of the field. So as long as my camera sensor is smaller, would fit inside a 50 millimeter circle, I get nice flat stars and the focus is good. Now, if I start throwing a focal reducer on there and, maybe I go beyond that and, now I have problems and I have to optically correct that field.
So I don't know if everybody who's on here has knowledge and experience on some of the terms that are being used. So can you explain, please, the coma and stigmatism when it comes to telescope optics? Because not everybody who's here watching will know what they mean.
Yeah.
To me, it means a bad image. I simplify it pretty short that way.
That is a
Go ahead, Tim.
I was gonna say that's a simple way of saying it. So astigmatism means that a point source of light, instead of being a point source, ends up being a smear. In coma, they call it coma because you sort of get this. I think actually coma gives you like a little bat wing shape when you get it. But both of these are optically undesirable. Our friend Gordon, I don't think Gordon's on. I don't see Gordon. Do I see Gordon? No, I don't see Gordon on yet. But what Gordon does is he doesn't focus the telescope as sharp as possible in the center of the image. He goes about 1/3 of the way to the edge of the frame, and he focuses at that point instead. So he says, so I get ideal focus, turns out to be this donut-shaped zone. It's slightly less perfect in the very center, and it's also slightly less perfect in the corners. But he says, but because he does this, it's only very slightly not as good as it is in that perfect donut area, and your eye won't spot the difference. So it looks like he has a perfectly good field all the way across. So that's a bit of a cheat, is to focus partway to the edge of the field rather than exactly in the center of the field.
So he's averaging it out is what he's doing across the view.
Yep.
And that's a clever way of doing it. You're not perfect focus, but you're good enough focus. Almost perfect. So, does anybody have any questions? I know we just lost Book Davies. He's had to go. But anyone have any questions that you would like to ask, or any comments or anything?
Liam, maybe you can talk a little bit about collimating a telescope.
Collimating a telescope. That's an interesting topic. I know more about Dobbs collimation than anything else. It's basically collimating is basically aligning your optics so you lose less light, and the optimum amount of light that comes in through your scope to hit your mirror and gets reflected to your secondary mirror, being that an SCT or be that on a Newtonian telescope. By having them perfectly in alignment, you lose less light, and by losing less light, you get more contrast in your image, and you actually get a better quality of your image when you do that, visually and when you're doing imaging, right? It's about making the light path as clean as possible from A to B.
Yeah, you can think of the mirror as shimmable, right? So if the light is coming down, hitting the mirror, you want it to go straight back up, except concentrate in a little bit. Imagine if that mirror was just slightly shimmed to one side so that its cone that it's focusing is not precisely landing back in the center where the secondary mirror is. Yep. It's off to one side. That actually means two things. Number one is you're losing light, as Liam said, and it also means that the part of the light that is hitting the secondary mirror is actually coming from the edge of the mirror. And that is where the quality is not as good. So the quality of the image is degraded, as well as you lost the efficiency of the light.
Well, yeah, because mirrors are not flat, right? They're parabolic. They're shaped like they're curved, right? Yeah. So when the light comes in and hits the primary mirror, the light is focused up as a triangle to the secondary. And if you're getting the edge of that, and in most telescopes, there's a few exceptions like Timscope and so on, which is optically flat. Most telescopes like a Dobb or even an SCT, the outer edge of the mirror is never perfect. So, and when the scope when that mirror is skewed a little bit and the light that reaches the secondary is off, you're not, as Tim said, you're not only losing light, but you're getting the bad part of the mirror reflecting the light, and that's actually going to distort the image anyway. So you want to avoid that. Now, Dobbs are very easy to collimate. SCTs take a little bit more work to collimate, and refractors take even more work to collimate than an SCT.
Yeah, I did want to mention off topic, but just sort of as a keeping pace thing. I know a bunch of people are on YouTube and a bunch of people are live here on Zoom. If you do join our Zoom directly, when you join, you're automatically muted. I haven't seen any of our guests unmute to ask a question, but you are welcome to do that. If you have a question, if you're comfortable, you can unmute, ask your question, join in the conversation. If you're not comfortable unmuting, go ahead and type it in the Zoom chat. People who are on Zoom, on YouTube, we have no way to hear you. You have to type your question on chat. But Liam will read your chat and recite it.
Yeah, I don't bite much, so feel free to ask questions. And we'll do what we can. We don't always have the answers, but we'll do what we can to give you some form of answer or up to as far as we know. Some of us are more into the science than others, so if it goes delves into science, we'll try. But there's obviously a stopping point because it's not our area of expertise, but some of us enjoy that area. So feel free to chime in and ask questions. I do know there was one young guy that was on a while ago, and he I think he went off channel. It's a pity because he looked interesting, but he realized he hit the button of his camera. And when he realized he saw his face the camera, he kind of ran to the side and hit the button again on his computer. And it was but like you can always come in. We're not going to bite, and we're not like come in and ask. There's no, and no matter what you ask, we'll do our best to answer your questions. So does anybody out there have any questions right now?
Well, I have not a question, but a statement. The word from the president: make sure your optics are good, or your images will be bad. Excellent presentation for the both of you. How long are you all going to be on on this particular channel?
We're on. We have a break, I believe, at 8:00 to 9, and then we have no. Sorry, we don't know. We're going all the way through.
I think so, yeah.
Okay, cool. So you have.
Yeah, I'll be breaking
this
up.
one here. We have another one with a PowerPoint presentation. Jesse's going to tell about his experience about learning and getting into astronomy. He's a new member of the club, and then we're going to go off into doing observing from that point.
Yeah, I know, Doug, you're going to break off. Doug, you're going to break off and have
I'll be going live at 8:30 with my WebEx. I may double book and go onto Zoom as well with you guys.
Yeah, sure.
So for everybody listening out there, that was Adrian. Adrian is the president of GLAC. GLAC is the Great Lakes Association of. Well, actually, Adrian, you tell them what GLAC is.
GLAC is it's basically the association of all of the astronomy clubs that we have in Southeast Michigan. I will try and do this from memory. You're listening to members of the Ford Astronomy Club, who are very active and among the first to have a safe event where people could come and see things through a scope. Also, the Oakland Astronomy Club is a part of us, the University Lowbrow Astronomers, the Warren Astronomical Society. Recently, we had the McMath-Hubert Society, which they were the guardians of the McMath-Hubert building in Lake Angeles, but I think that building, they've left that building, and but they're generally about radio telescopes and about doing radio astronomy, which is very fascinating. We're always looking for other member clubs. Like we know the Kalamazoo Society is more further west, but you know, they're welcome to join. Those of you that are in the astrophotography group, the Plymouth Astrophotography Group, I'm a member of that group, and the group is welcome to join. During COVID times, we've basically done meetings and just about everything online because we felt that it's a safer way to do it. We are slowly trying to transition back into getting out there to the public and showing these scopes to people like we did from 2019 on back. Those of you that attended this event in 2019 and on back, remember what it was like to see all of the people there with the telescopes, being able to ask questions, being able to see things for yourself. And we want to get back to that. However, as a science organization, we also want to do what's absolute safest for the general public. And we know that some of you may feel like that should be okay. Let's just get us out there. We are going to be super cautious of how we handle COVID-19, especially the Delta variant. But we are looking forward to in 2022, just like we were last year, we are hoping that we can get back out to the general public in person. And in the meantime, we invite you to you're here. Those of you that are listening, you're here at this event. You're listening to the Ford Astronomy Club now. We'd like you to go to more live streams today and tomorrow. And we invite you to get out there under the stars and go to some of the dark sky parks that we have in Michigan. We're specifically tailored in Michigan. Some of you may be from other parts of the state, but we're a Michigan organization. And we've got a couple of dark sky parks that you can go to and study the stars for yourself, enjoy the night sky, and send us questions. There's contact information on the GLAC page, and I believe it leads to each of our member clubs. And you can join clubs. We've had memberships in our clubs grow more than they had in past years, just with the circumstances of the pandemic. It seems a lot more of you are interested in what's up there in the skies, what's going on, and you want to talk to some experts like we have here and get some questions answered about what's up in the sky.
And I wanted to say that those membership fees to join one of those clubs ranges anywhere from $0 all the way up to $30. And so at $30 is going to require you to make a substantial alterations to your retirement plan to be able to afford that.
Well, it did for me, but for most of you out there, I'm pretty sure $30 for a family membership is nice, and that includes your entire, your household, those that live with you. So we encourage you all to join a club. If you're in a club, we encourage you to talk to me or any of the board members about joining GLAC and being a part of this. And we'll look forward to growing the event even more. We were hoping to be in person this year, but we felt like it was too much of a risk. So anyone can send me questions. Anyone can send. Tim's one of the main board members that helped put this all together. Doug has been around. There's a few of you in the participant list. Without Liam, I guess everything would fall apart. So, we have to credit
I
to.
can't even seriously for that one.
And just be mindful that this Zoom that you're on and or YouTube that you're watching is not the only thing going on right now. So head over to GLAC.org. There's another Zoom and also live streaming on YouTube. Is that right?
Yes. Yeah. The Zoom. So we've given you the option this year to join us directly via Zoom, or you can just drop in on YouTube, whatever technology you prefer. YouTube is there. You can chime in and chat, or you can just watch the program. You can join us live if you choose to come in on Zoom, but just beware that if there's any strange noises coming from your system, we reserve the right to mute those so that our program can continue. So with that, I'm turning it back over to you, Tim, the Ford Club, and let's keep going.
All right, thank you.
So we have a question.
We are a three-ring circus, so there are other channels going on at the same time.
Yes.
There is a question out there, and Brian is on YouTube, and he's asked, any luck viewing comets and asteroids with your scopes? The answer is yes. A lot of us have done asteroids and comets when they come around. So
Doug is the master.
Yeah, that'd be a good question for you to answer, Doug, if you're still here.
In fact, Doug can probably show you pictures.
If we stay on late enough, I plan on getting 67p tonight. But that's going to be when Taurus rises in the east. So it's going to be late, early morning if we're still on.
It's 1 o'clock. If you all have people watching you at 1 o'clock, by all means keep going, because
we did that year.
We know the forecast for tomorrow isn't very promising. So take as much. Now, also keep in mind that you got about a 70% moon coming up around that time.
I'm looking at some other options to help fill in the gaps, or at least a gap, based on. I have to see if the weather permitting, as long as it's not raining, I can set up my Rubens tube and to demonstrate standing waves in the gas through fire.
Okay, I've seen that demonstration.
Now. Yeah, that's cool.
Yeah, Doug, we had a question about can you image comets and asteroids? I believe was the question from YouTube, and we instantly all yelled your name when we read that question.
The answer is emphatically yes.
As a matter of fact, if you are watching on the Astronomy for Everyone YouTube site, if you look back at some of the past videos of Astronomy for Everyone, Doug gave a demonstration of how to image and process a comet.
That is correct. Yeah, I've done about
Yeah.
35 comments in the last 4 years.
So
Yeah,
and you can actually see them with their true visual as well. You don't need to image them to see a comet. You can actually, depending on where it is and how bright the comet is.
Yeah, I mean, if
Sometimes
it's
you can
like,
see them, like the one that was last year, you can see it naked eye.
yeah,
But some you can see, like you can just see with an eyepiece and a telescope. You don't need special equipment. You just need a scope, and you will actually see it.
yeah,
some
it's
are
like,
visible.
Yeah.
Yes, I agree.
yeah, it really depends on the magnitude and the size of the coma to determine whether you're going to see it even in a scope. And one of the things that was fun is each year we go up to the Stargaze and guys are looking at the usual stuff. I always pull out my little thing out. Hey guys, you want to look at a comet? They go, comet? Is there a comet? I says, oh yeah, it's about 8.5 magnitude, but you know, you got a 16-inch dial. We can fight it and look in there. So I'll fight it for them. Go, oh, and it has a little bit of a fuzzy ball, you know, and sometimes a little bit of a tail, even at 8th or 9th magnitude. So they're fun. I enjoy hunting them because they're transients. There's something that comes around and they'll be gone after a few weeks or a month.
And some you'll see once and never see them again.
Yep. And
Yeah.
sometimes I do time lapse of those things, asteroids and comets, and I've got them on my YouTube channel.
Yeah. So there's a question for you, Doug, about where you're located right now.
I'm about 8 miles south of Fenton and about 15 miles north of Brighton off of US 23.
Okay.
Kensington Park is in his backyard.
Yeah, that's about 8-10 miles away.
That's my backyard. I'm 2 miles from there.
2 miles from Oh, cool. All right, I got the wrong. Your backyard, John.
It's in both of their backyard, pretty much.
Well, a little further away from the backyard.
Yeah, I'm north and west of Kensington Metro Park.
Yeah, it's about 20-25 minutes for me to get there.
And it's about 5 minutes for me.
Yeah.
Yeah, which also means it's 5 minutes from Island Lake, which is where we used to have the live events. I believe you all observe not far from there.
We all do.
Somewhere.
We all observe at Island Lake. The whole Ford Astronomy Club, when we do our public, what we call our beginner nights, that starts in late spring and goes on until early fall. And the public beginning nights are held at Spring Mill Pond at Island Lake. So we do have one, but it's not going to be public because of the pandemic. It's members only this time. But we do have one coming up on the 15th or the 16th, no, the 15th or the 16th of this month, of next month. So I think it's the 16th. It's the Saturday, the 16th is when we have it, but it'll be club only because we can't let the public to observe with us, which we love to, but we can't do it because of the present situation. But yeah, we've started to go back out as a club to actually do our own events because we need to keep the momentum. We're all getting stir crazy sitting inside, not being out with our scopes. So we're doing club members only stuff, and hopefully next year we can start to bring the public back into those events again because they were fantastic.
Yeah,
we're all hoping for that.
We don't want our telescopes to leave us for not paying attention to them.
That can happen. So how would one become, for those of us that would like to become Ford Astronomy Club members, how would one become a member?
Go to FordAstronomyClub.com and the information is there. Everything's on our website. The other option is to, on the website, our PO box is there and our application form is there. You fill out the form, send in the fee. The fee's only, if you pay now, because from Astronomy to Beach onwards, if you pay now, you pay $30. It covers for the end of this year and all of next year. And after that, then it's $25 per year renewal each year. And that's for you and everybody who lives in your house. All of our family members are included. So they're automatically members. And then you send it into our PO box and you're a member. And once our secretary gets the stuff out of the PO box and logs it down into our membership list, you're a member from that point on, and we will send you out your ID, and so on, and you'll be added to our what we call our groups.io. We have a group in groups.io where for the members of the club only, and we'll actually invite you to join that. And from that moment on, you're a full-fledged member. And we, as a club, we do have loan out equipment. So if you are unsure about what to buy, if you're beginning as an astronomer, and you're not sure what to buy and you want to test it out, we actually have equipment where you can actually come and loan the equipment out from the club, and it's free as a club member. You can take loan of the equipment, you just sign it out, and you can use it and gain experience that way before you make your decision up which way you want to go to buy your own equipment.
And we actually discourage, if you do not own any telescope or any equipment, we actually discourage people from buying equipment and then joining a club. You don't even have to join a club, actually. You can show up at our meetings. Meetings are public. Our observing nights, well, actually, we're limiting them right now because of COVID. But if it weren't for COVID, those are public too. What you get because you're a member is you get access to the equipment library. We actually have a special permit with the park. So the park normally closes at dark. We have a permit that allows us to use the park as an observing site 24 hours a day, 365 days a year. Even when the gate is locked, we have the access to open the park. So those are the things that you get if you're a club member. But if you don't own a scope and you're interested, don't buy anything. Go to an event, go join a club, borrow equipment if they have an equipment loaning library, look through other people's scopes, ask them about stuff, tell them what you want to do, and they'll steer you in the right direction. I bought the wrong kind of scope for my first scope. And then I bought the wrong kind of scope for my second scope. And then I joined an astronomy club and found out, I had buyer's remorse. Gosh, I could have had that, instead of what I did buy. So don't have buyer's remorse. Go join an astronomy club or attend some events.
Yep.
Some very wise words.
Another
I
thing-
have.
Go ahead.
Go ahead, John.
I was going to say another advantage of joining the Ford Club is we have our own TV show once a month, and you can be part of that crew. And we do Astronomy for Everyone.
No, John, we're trying to give them reasons to join the club, not reasons to stay away.
The TV
what
show
John
is great,
is
guys.
saying.
It's fantastic.
What
I've been
John
on a
is
couple of
saying.
episodes. I worked in the crew there. John works in the crew there, and it's really interesting. And you learn a lot, and you get to meet interesting people, and it's kind of fun to be involved in that kind of stuff. And it's not only shared by us, but people in the community get to see that. People outside of our state gets to see that. We have people from outside of Michigan who actually replay Astronomy for Everyone on their local access TV outside of the state of Michigan. So we have other states using our content as well.
And I just want to say that last night we got an award for Award of Excellence for our TV show. So now we're an award-winning TV show.
Very cool.
That's excellent. Yeah. So what you all are hearing out there is that there are a lot of folks, a lot of you out there that are very much interested in astronomy. What star is that? Is the Earth flat or round? And how do I see the Andromeda Galaxy? And yeah, well, actually, reason I am going there is because that's what I believe that those of you in the general public, all of these things are floating around. I mean, there's science, there's pseudoscience, there's outright somebody's imagination. No better place than to get the truth than from an astronomy club. Amateur astronomy does not mean, well, they couldn't hack it in the professional world. Amateur astronomers and professional astronomers are probably the closest working knit groups of if you try to draw the line between amateur and professional. It's amateur astronomy groups such as the Ford Astronomy Club that are often responsible for helping organizations like NASA or helping other professional astronomers do their jobs. And in fact, a lot of professional astronomers, a lot of us have worked with professional astronomers, either we online or directly, or we have contacts for astronomers, for telescope making organizations. all of these contacts come from being members of these groups. So that there are a lot of benefits to taking your interest and your passion for the stars and joining a club. It's like going to a next level with that. You can learn as much or as little as you would like to know about this thing we call the night sky, space, astronomy. What's it all about? You'll get lots of information about answering those type of questions by joining an astronomy club. If the Ford Astronomy Club is just too far away from you, hit the GLAC page, look at all the different astronomy clubs that are there. I, of course, because we're on this particular channel, will recommend you join the Ford Astronomy Club, as I'm looking to do. Very active club. I can say that, you know, we joke and say without them, the thing would fall apart, but the Ford Club stepped up mightily to host the event that we're on right now for Astronomy at the Beach on fairly short notice. So there's kudos for that. And there's a lot of knowledge in all astronomy clubs, from visual observing to imaging. Now, imaging has taken off in the last 5 to 10 years with the technology that's come out with digital cameras. Even I do wide field imaging and nightscapes just because of the technology that's out there. Astro imaging and how to do it. We got Doug Bach sitting here, who is going to have a program later tonight, who's been astro imaging for quite some time. I would say since the 70s with film.
Yep. I've got Altair in my scope already.
You know what? I'll stop talking and we'll show that star if you want to share your screen, Doug.
Oh, it's just Altair. It's no big deal.
It's a star.
Hey, listen, Adrian, in 20 minutes, a lot of stuff we talked about, there's going to be a great presentation I'm going to put on here in about 20 minutes about a beginner's journe into astronomy. We're going to talk a lot more about that stuff.
Very
excellent.
Good.
Oh,
so that's a good segue for that.
We should show Altair just to remind Jesse.
Oh man,
that's an internal joke, guys.
Do this publicly too? Come on, man.
This is an inside joke, everybody.
It's an inside joke.
I got to reboot Zoom.
Well, just one thing, guys. On here, like you're talking, Adrian, you mentioned about people being involved with other groups and being involved with professional astronomers. On this call right now, there are 4 NASA JPL Solar System ambassadors, right? There's myself, Tim Campbell, John McGill, and Bob Tremblay. And we are sort of, Bob's video just dropped out. He's the guy that looked like Santa Claus. There's Bob. So we are actually solar system ambassadors, volunteer solar system ambassadors with NASA JPL. We do outreach for NASA JPL. We talk about our missions. We talk about what the science that they're doing and so on with the public. So if anyone in the schools and organizations that are looking for people to come talk about NASA and science and astronomy and stuff like this, on this one video call right now, there's 4 of us here. So there are a group of us out there. You can check out the Solar System Ambassador page on NASA JPL's website, and you can reach us through there, or you can reach out to us through the astronomy clubs. John, myself, and Tim are part of the Ford Club, and Bob Tremblay is part of the Warren Astronomical Society. Now, Bob actually works for the Vatican Observatory. He's their IT person. He's their IT nerd, and a webmaster and so on for them. And I'm actually an ambassador also for the Vatican Observatory as well. So a lot of us are so into doing this. We like going out and talking about it. So we're there for you to reach out to us and get us to be involved in your clubs, your groups, your school, your class, or whatever. If your teachers are out there watching, if you want someone to come in and do talks about different topics like this, we're here to do this. So we are actively involved with groups like NASA, in groups like the Vatican Observatory. So we're not just amateur astronomers. Some of us are more ingrained in it and want to go that step further and share that information with everybody.
I got one thing to say about the difference between amateur astronomers and professional astronomers is that amateur astronomers actually still look through an eyepiece. and professional
Very
astronomers
true.
only look at the data.
Yeah, I can vouch for you for that, John. We've had professional astronomers who were thrilled to come when we could still have nights out with the public, and we invited some that worked professionally, are more than thrilled to look through the eyepiece and actually see something with their own eyes. A lot of technology, they're sweeping the skies, the Pan-STARRS survey, the NEOI surveys. All these surveys are computer controlled. They're panning the skies, and folks are looking at images to see if there's a difference between image A and image B.
They're not even doing that. They have computers.
The computer's actually picking up the image for them.
Yeah.
So see, that's how far behind the times I am.
Yeah,
I'm actually heading to a star party, and I'm planning to do more observing than imaging. Why? Because there's a connection you make with your cosmos when you look out at that light, which is why I was saying, let's look at Altair. When you see it for yourself, those photons are hitting your eyes. You are seeing it. It's light that left millions of years ago or more, and it's hitting your eyes. It ends there in your eyes, as opposed to a CCD chip to be processed. Nothing wrong with that. You get some beautiful images out of it. You can study it, but there's a human to cosmos connection that comes with looking at it yourself.
Yeah.
Even if your eye doesn't have quite the ability to distinguish colors or other parts of the light spectrum that cameras, CCDs, the CMOS chips can, you're still looking at it, and the light that you do get to see is something that you'll remember for quite some time. And a lot of you come back and want us to come back and share the night sky with you, partly because of that reason. So
Couldn't agree more.
Yeah, like when you're looking
we're
at
working on that.
Altair, you're looking back, and you also remember when you're looking at stuff in space, you're looking back in time.
Yeah,
right. Because
space is a time machine.
Yeah, like Altair is 16.7 light years away, right? So you're looking at what the star used to look like 16.7 years ago, because it took that long for the light to reach our eyes. It's been traveling through space for over almost 17 years before you see it. So if we do look at it in the scope, you're looking back in time, almost 17 years ago.
And it's at this point that I should point out that when you wish upon a star, and that star is Altair, it will be 32 years before you get your answer.
That's hilarious.
17 out, 17 back.
Well, those of us with gear acquisition syndrome, the answer is get another scope. So you got to be careful. I would like to do a public service announcement about gear acquisition syndrome in astronomy. The answer is use what you've got. I know there's a presentation for beginning astronomy that may be a part of the presentation. I don't know, but
we're going to get into it.
Yeah, acquiring gear has become something I've noticed. I did a bit of an observation thing a couple years ago, dead of winter. Couple of people who came to look at what I was able to show in my telescope asked questions about the gear and began a discussion about the gear that they had, kind of talking about it proudly, because it was so much aperture, so much, whatever the eyepiece focal length was or the make and model. We want to encourage all of you to remember that gear does not matter when you're starting out. It's all about what you can see through your gear, and your knowledge of the night sky comes first. Then if you need certain gear to try and look at something or do something, you worry about it then. You'll get more info about that coming up soon on why that is. But we encourage you all not to fall for gear acquisition syndrome. A lot of you, when you see a big telescope at Astronomy at the Beach, you'll go stand there because it's huge. It draws you in. We understand that. But even a small 4-inch telescope can show a very beautiful view of something, depending on what that something is.
Yeah.
The moon shows up great in a lot of telescopes. You can see the craters. You can see a lot more detail.
The scope, the best scope to buy is the scope you'll use the most. So something that's easily portable for you if you need to move around, something that's easy to set up, something that's easy to control. they're the scopes you use the most, especially as a beginner.
Absolutely.
When you get into other stuff, there's different setups involved. I have a question for you. Tim, what time is Mike Bruno coming on?
Well, that was going to be 7, but we haven't seen Mike. So I don't think that's happening tonight.
Okay, that's fine.
Jesse's on at 8.
I can go anytime you guys are ready.
Well, except that people who want to watch it are going to show up at 8.
Yep, that's fine.
Now, the smartest thing that you could possibly do when it comes to getting into astronomy is buy the house next to Doug Bach's house and become
really good friends with him. And every time you see the observatory open, bring out coffee and cake, and you'll get to observe with him.
Just be sure not to trip over. Just be sure not to trip over any of the wires, or you'll ruin that night's study as Doug's trying to recable everything.
Yeah, I'm looking at Saturn right now.
Come on, Doug. Let's see what you got, man.
Yeah.
Another go ahead and show us.
Another question is,
if you can.
Yeah, one second.
Go ahead.
We have a question from Brian, and he says, "Is there any database map with predicted coordinates of deep sky objects that are compensated for the time it took for the light to reach Earth?" And so where it should be coordinates if we could calculate, and the answer is yes. Stellarium can do that. The Sky Safari can do that. There's lots of apps out there.
Starry Night does that.
Starry Night will do
it. So the question you're actually asking about is this notion called proper motion, and so this is the idea is so. We live in a solar system, and things are going around the sun, and that means that they're moving from night to night. But only the things that are in the solar system are moving from night to night. Outside our solar system, you can pretend that those objects aren't moving at all. So with the stars that you see at night, the galaxies, the nebula, not moving at all. Turns out they are moving, but you're not really going to notice it on the scale of a single human lifetime. And that means the cheat is in a star catalog or any kind of atlas of astronomical objects. For the telescope, it's mostly just a lookup table. It's like, oh, I want to see Altair. Well, these are the coordinates. Because those coordinates mostly don't change. They do change a tiny, tiny bit. And then there's this thing called precession of the Earth, which causes, where they appear to us to change, because the Earth actually does slowly spiral like a top, 26,000 years to spiral once, but technically it happens. But everything inside the solar system moves from night to night. And so so now you actually have to do math to figure out where that object is from night to night. You don't have to do math to figure out where the rest of the stuff is. But we do have telescopes that very, very carefully track the actual proper motion of these stars and figure out how far away are they, how fast are they moving, in what direction are they going. In fact, that's one of the ways that we can identify when stars are members of what we call open clusters. In other words, they were all born in the same nebula, is they will all basically be moving at roughly the same velocity in the same direction, and they're all roughly the same ballpark of light years away from us. And so in my software, I can turn on the proper motion vectors, and I get these little sticks coming off of every star showing me what they're doing. And so you get a little stick, that means it's moving a little. You get a long stick, it's moving pretty fast. So you can actually kind of figure that out. What it doesn't do is it doesn't undistort. So think of a galaxy like the Andromeda galaxy. That thing is something like 200,000 light years across. The front edge of it is a couple 100,000 light years closer than the back edge of it. And since the stars are going in opposite ways, that means that the stars on one side of the galaxy are in a noticeably different position than the stars on the other end of the galaxy. But that's not how we see it. We see it the way the photons are arriving. So do we have a way to undistort and say, this is what the whole galaxy looks like? This is where that star really is based on its proper motion on the front edge and the back edge. I've never seen anybody try and come up with a rendering for that, though I don't doubt that mathematically a computer could work that out.
Haven't we begun to change also from the what is it, the J2000 catalog for,
that's the epoch.
Yeah, so the epoch is relative to the precession of the Earth, the top thing that I talked about. But now computers, you can just say, I want the thing in what's called JNOW coordinates, where it's like, well, this is where it is right now today. In a paper atlas, you had to have an epoch because the numbers in the catalog aren't, literally rewriting themselves while the book sits in your bookshelf. But the computer can do that. And so in software, you just say, I want J now instead of J2000. J2000 just means this is where it was in 2000.
Yeah, and we use that prior to 2000, didn't we? And basically that's been last 40 years. I think I've been using that. And
yeah, you could still use that as long as you're, all your software and your telescope are all synced to use 2000 coordinates. You'll still find the objects.
Yeah, what I'm saying though is that we're slowly transitioning to a new system.
It'll be 2050.
Isn't the exception to this, because I read something about this, and by the way, for the people that don't know me, I'm new, so I can say things that they're going to say, no, that's not right. But anyway, I read something recently that said something about, though, the planets are a little different, right? That these firmware updates that you guys will hear about with telescopes and mounts and so on, that there are some updates they do to the planets more frequently. Isn't that correct?
That would be correct, and that's because of the fact that they are so dynamic and so close to us, that the little perturbations that have not been analyzed or captured, they might do updates on.
And to make it even more irritating, nothing has a circular orbit, right? If it had a circular orbit, it would be really easy to predict. But Earth's orbit is elliptical, and so the velocity that our planet is slinging around the sun varies from about 29.5 kilometers a second to about 30.5 kilometers a second. And so
Tim, that's true, but all the Sky Safari type software that you're using, the algorithms take that all into account.
They compensate for it. But what I was going to say is, so here's a hand box for a telescope, right? The computer inside the telescope mount, that is not nearly so powerful as your laptop or your smartphone. That's actually a really simple computer. And so it turns out they shortchange the math, and they actually kind of do the math as though it was a circle. That gets the telescope in the ballpark, which is why if you use the telescope mount to go to a planet versus using a computer to direct the telescope to go to the planet, the coordinates that the computer comes up with and the coordinates that the telescope mount comes up with will not actually be the same. And so I tell beginners, never sync your mount on a planet because it thinks that it came up with the right number. It doesn't realize that it cheated on the math. And then it syncs, and it's synced on what it thinks is the right coordinates. In fact, they were the wrong coordinates. That's not where the planet actually is. Your laptop will actually give you the right coordinates. It does the calculus.
Yeah, the software does, yeah.
Yeah.
Yeah, and that's given too that, of course, you're on the right bright star, right? So that's the other.
Well, yeah, you learned that, Jesse.
So
I just want to add that Tim Campbell, he is a beta tester for Sky Safari.
Yeah.
Sweet. Doug, I think you were gonna try and share your screen. Is that
yeah,
what you're gonna say?
I don't have permissions to do so.
Oh, well,
yeah, fix that.
So
we're actually, what are you looking on right now, Doug?
A second.
I'm looking at Saturn.
So we're going to swing the telescope over to Saturn so you get to see Saturn.
Did you guys all notice we have a young visitor here?
Yes, I did notice. I waved hello to our young visitor already.
All right, I got to reboot.
Hi.
The Zoom.
Hi.
Sorry.
Hi. Well, you're welcome to ask questions. If you have any questions, you can ask questions. You're here, I assume, because you have some interest in astronomy, yes?
Yes.
Okay, so do you have a telescope?
Yes, we do. We do.
Ooh, tell us more. What type of telescope?
Tell them where you're at right now. We are up north at my cabin.
In what state? Because I don't know where they are. Tell them where they are.
Michigan.
Okay, we're in Michigan
That's
also.
where you want to be.
We're way south, but you're in northern Michigan. Very nice.
Northern Michigan, yes.
Near Traverse City.
Oh, nice.
Oh, sweet.
Yep, her grandfather just put together a telescope for her the last trip up here. So we came up here tonight.
Cool.
So this is perfect timing.
There's
That's
even
beautiful.
a slight chance tonight and tomorrow night for possible northern lights.
Tim,
That's what. Look at that. This
give me host
gentleman
permission, or give me permissions again, Tim.
Oh, did I not?
I had to restart.
Permission to share the screen, but there's possibilities of northern lights. So I would be, if you get the chance, first of all, wear lots of mosquito repellent.
Yeah.
Because there's Saturn right now.
Oh, that's so cool.
Yeah.
I'm not
Now
getting
it'll
it.
get better
Yeah.
as Saturn is down low in the sky right now. As it gets higher in the sky, the view will actually improve. And we also have that's rising yet. It's just starting to rise. It's Jupiter's also up tonight, so you'll see those, and you'll be able to see them with your telescope. So if you look south, just when it gets dark, you will see a really bright object in the sky, really bright. That really bright object is actually Jupiter. So around within the next half an hour or an hour, you'll see it. And if you point your telescope at that, you'll actually see the planet Jupiter. And then to its right, if you use your hand, your fingers like this, if you can see my hand, so from between thumb and your pinky finger fully stretched out, put your thumb on Jupiter, put your pinky, you'll see another bright star that about that distance apart.
But not as bright as the Jupiter one. It'll be a little dimmer.
Sorry?
But Saturn, it's not quite as bright as the Jupiter object. It'll be a little dimmer. Yeah. And that's the object we're looking at right now.
So Saturn. You have two planets to look at right now. And if you turn and if you have a clear view to your east, to your west, where the sun's set, if you see a really bright object in the sky over there, you actually have Venus in the sky over there. So now Venus only looks like a bright dot because it's so reflective, but Jupiter and Saturn you can actually see through your scope.
And I would say that
go ahead, Doug.
Saturn will actually look better through your scope than it will look through this imaging camera, since the imaging camera is on a short focal length scope. That's only 730 millimeters. So the actual size of this is about, in the scope itself, is about like that for what I'm looking at. I'm just zooming in.
Yeah, so you actually get to see some planets tonight. Do you have any questions you'd like to ask about astronomy?
Or have we rattled your brains to death?
She's muted.
She's muted?
Yeah, go ahead and unmute.
So we do have a question. So we're up north and we have this simple, just very basic telescope, but how do we go about identifying any of the constellation or able to any recommendations on how to say we only face south, so we're overlooking everything south, but and so just any ideas on how to start there, right?
Okay, you have a cell phone?
Yes.
Okay, there's applications that you can install, like Stellarium is one application, or Sky Safari, and there's a couple of other, and so a lot of them are free, and they will actually help you identify what's in the night sky on your cell phone.
I would do let me see what they Stellarium is free on a laptop. It's not free on a cell phone.
Oh, you're right. Sorry, you have to pay $15.
Yeah.
That's because it's open source software. And so some guy took advantage of the fact that it's open source software, downloaded it, ported it so that it would run on a cell phone, but that guy
didn't charge it.
He charges. Yeah, he doesn't give it away for free.
Well, we recommend free software to start, and then as you get deeper into this hobby, that's when you can start looking at, whether you want to pay for it. Sky Safari is still free, right, gentlemen?
There's a free version, isn't there? There is.
Yeah, there's a free version.
And the nice thing about that version is that there's a compass mode. I think depends on your network connection, but it's one where you can hold up your phone and it shows you can turn your phone and it'll show you what you're looking at. Like your phone almost like becomes a window. So like if you point the phone over here, it'll say, well, this is that constellation. Then you can compare to what you're seeing, the stars that you're seeing. And when you make a match, then you're like, oh, that's that constellation. Yeah, it'll take a little getting used to, but those programs are free. They're out there. And we recommend downloading those to get started.
Now, also Sky Safari if you're on an iPhone, it's got an augmented reality button you can push. So it allows the camera to become the background of the screen. So wherever you're pointing at, even though you see the map laid over it, you can actually see
what you can
your screen shows you what your camera sees. So you actually overlay
interesting,
one
yeah.
over the other, and you can actually find objects easier that way as well.
Yeah.
Okay, and then Sky Safari.
Yes.
I wanted to point out there are 3 editions of Sky Safari. There's the basic one. That's $2.99.
Oh, so that was free.
So
Uh-oh,
that breaks the bank right there. There's a more expensive one called Sky Safari Plus. I want to say it's like $15. And then there's a really expensive one called Sky Safari Pro, which is $39.99. Now, the difference between these is the Plus and the Pro. If you have a computer-driven go-to telescope, it can actually drive the telescope for you. And other than that, it's just got a bigger database. Now, why would you care about a bigger database? Well, if you're just looking at the sky with your eyeballs, you wouldn't, because the things in the database you'd never see with your eyes. You really kind of have to have a pretty big size scope to start seeing some of those things that are in the database. So I would just get the $2.99 one.
Yeah.
That's going to tell you where everything is in the sky that you care about, including all those constellations that you just asked about.
Yep. So if you've got the $2.99, get that. If not, I think if you do a search on astronomy, there are a couple of other apps there.
Celestron Sky Portal is free, and that's pretty good.
Yeah. So if you don't want to spend money right now, there are a couple others you can get. Part of the reason that we talk about Sky Safari a lot is a lot of us use it. I'm in a couple of different clubs. I'm looking to join the Ford Astronomy Club because why not? And it sounds like you guys use Sky Safari as well. A lot of us use Sky Safari to control our telescope.
Yep.
But where you're at right now, start with the basics, continue to enjoy the night sky, and download one of those programs to help you navigate your way. Now, go ahead. I think you had a question.
Bob mentioned, very quickly, I just want to say, Bob mentioned Celestron has this thing called Sky Portal. That actually is Sky Safari.
True. I think I've seen it.
They made a co-sharing deal where they give Sky Portal away for free. Celestron Sky Portal. It has a slightly smaller database than Sky Safari because it's free. And then it does actually have the ability to drive computer telescopes, but only if it's a Celestron brand, because that's why it's Celestron Sky Portal. And so
we recommend getting that if you're still looking for the free software, Sky Portal.
We have a question.
Go ahead. Yes.
So Janelle, do you want to ask about the telescope? Come on. So we're talking about how big the telescopes are. All your telescopes electronic?
Not all.
Not all of them.
I have electronic telescopes, but I have a big preference towards manual. So I have a manual Dobsonian telescope or Newtonian scope, and I really like Dobbs. The bonus is you learn the night sky because you have to point it. You also have he's got one there that he's showing.
Yeah.
That is.
This is his little 90-inch telescope.
Yeah.
It's this small, but it works pretty well.
That's good. That's awesome. Well, do you have tips? Like, we've never used the telescope, and while you all have been talking, Janelle went to go look through the telescope and she can't see anything. So, and I don't know if is because you look down into it and it looks out. Is there any tricks? Or is it too light maybe still?
Well, okay, then not to be a bit of a smart ass, but sometimes people forget to take the covers off the front. So it's often easier.
Let's go look at her.
But I'm just saying people do make those mistakes. And then the other thing is what you'd have a lot of people forget is you have a finder scope on your telescope, right? A little small telescope that goes onto it.
Yes.
So what you should do is point the telescope at something bright at a distance. And there's ways of adjusting that smaller telescope, the finder, to make them see the same thing in the center of both views. When you have that done, then to find something in the night sky, use a small scope to get the object in the night sky in the center of the finder scope, and then go look in the main telescope eyepiece, because the one is for such a wide field of view, it allows you to see more of the sky to line it up, and then the other one is like looking through a straw. So you want to be in the right area before you look through that.
Yeah, and don't forget you've got a focuser on there too. So if it looks blurry, you got to turn your focuser up and down, turn it so that it gets smaller and smaller.
It looks like a Celestron. Is this Celestron refractor? No.
This is a very inexpensive.
Yeah, but you get beautiful
It's a refractor.
moon with those. You
I
get
don't-
beautiful. So
Now,
Tim,
we're gonna-
So you have to slip one of these eyepieces in it. Did you slip an eyepiece in the end?
it looks like she did.
Okay. And,
Yeah.
and did it only come with one eyepiece or did it come with more than one?
it came with more than one.
Okay, whichever one has the biggest number. So on the side of the eyepiece, it'll say, this one says 15, for example. I've got another one over there that says 25.
Oh, look.
Whatever one has the biggest number, that's the one you want to use first, because that's the one that lets you see the largest amount of the sky.
Yeah.
If you use the one with the smallest number, you're seeing such a tiny, tiny piece of the sky, you're not even necessarily sure you got it on a star or something. And then pick something, you start with like the moon.
You can look.
It's not going to be up for a while, Tim.
Yeah. So you could do Jupiter because it's really bright.
Yeah.
That would be a good starting point, and and in a low power it'd look okay, and then go up to the higher power, which would be a 25 millimeter, or you probably have a 25, and then with our 26 millimeter, and then Jupiter would look really nice in that.
This one's 4.
Okay, that one's 4. So we have the 4.
That's too powerful. The lower the number, the more it magnifies. So you don't want to. You want to do the lowest, the highest number.
What's the biggest number?
What I can't read. She has to read. I need
This
glasses.
is 10 and this one's 20.
At 20.
20.
20. That's the one.
Start
you
with the
want.
20.
All right, thank you.
Yeah, and actually through that scope, because it's a refractor, Jupiter will look really, really nice.
Oh my
Yeah,
God.
it'd be nice and sure.
Yes, it will. And I also want to point out the library is your friend. Many libraries have books on astronomy. And if you look and you find a book like this one and you flip through it and it has charts for the season, you'll know what's up during which season. So this is Night Watch. This was my beginner book. I'm only a few years into this and I really liked it. And I did find this at the library and bought my own copy.
So Night Watch
Awesome.
is one of the 2 most recommended books. The other one being,
Turn left at Orion.
there you go, Turn Left at Orion.
Yeah, and actually,
Yep.
Turn
I
Left
have
at
the-
Orion was co-wrote by a guy from Michigan, who's actually who's now the director of the Vatican Observatory. So he's a Christian brother.
Brother guy,
brother
Consolmagno.
guy, yeah,
Yep.
and he co-wrote Turn Left at Orion. It's a great book.
And not to brag, but his office was actually above the Pope's. So for a while.
Yep.
Yeah.
Yeah, well, that's in orientation. But let's get this telescope going. So you put the eyepiece in.
Did you get
and
it?
you've
They're talking
Yep.
to you.
Okay, you
She's
can't
saying
look
that-
through a window. You need to go outside.
Oh, okay.
All right, hold on.
Oh,
We're-
yeah.
Oh, you put on a jacket, mosquitoes will eat you.
Right.
You will become a banquet without a jacket on you.
I've tried that. I've done some night photography. I walked out with shorts and a t-shirt and said, I'm too tough for the mosquitoes. Well,
they
I
beat
started walking and the mosquitoes proved otherwise. I had about 10 bites in 2 minutes.
Yeah.
And I said, I'm not sure this image is worth it anymore. So I think I left early from
you
wherever
gotta put
that
Are you
was.
based up there? Or are you based somewhere else in Michigan?
Me or the
No,
or-
sorry, the Davis family.
Janelle. Yeah.
We are in Michigan, but we came up to the family cottage. So this is about a 4-hour drive for us. We
Okay.
drove up this afternoon.
Yeah, but where in Michigan are you from originally? Where
Oh,
are you based?
Troy, Michigan.
Oh, you're in Troy. Okay, so the Warren Astronomical Society is probably the closest
do it. Yeah.
Yeah.
group to you.
What is it?
Yep,
the War-
I'm in that
Warren.
group, so we'd be more than happy to share. Basically, we're just giving out our website to the Ford Astronomy Club has a website. You can join any of the GLAC astronomy clubs that you wish. I don't know if you were on for my spiel earlier, but I'm the
No.
president of GLAC, and but I'm also an avid amateur astronomer. So more important than being president is just telling you what you're doing right now is awesome, and hopefully we can get you to see some part of Jupiter remotely. That'll be pretty fantastic. We can do that.
Well, she's got her scope outside right now. Okay, when you're
Yep,
looking
so go
south,
ahead.
if you look south, you see a really bright object to the southeast.
All right, to the south.
I can't see with your camera because your camera's not sensitive enough.
That's okay. We'll just
you see a really bright,
we'll fly blind.
really bright star.
Okay,
Yeah,
hold
we'll
on.
fly
We're gonna,
blind.
I'm just trying to sync the telescope.
Yeah, we're gonna go down more. but-
Okay.
Yep, go ahead.
All right.
Just
are
want to
you-
get you started because if once we get you on one, we'll get you hooked, and then you'll start finding others. So you'll start looking at we'll point out where Jupiter is or Saturn is, and you can navigate over there and get you into it. We'll get you in a while, Jesse. I'm sorry.
Oh,
okay,
no,
so-
no, this is what it's all about, man.
Agreed.
This is what it's all
Okay.
about right here.
Look up. You see a big bright. You see a
Oh.
bright object.
yeah, we see a big bright star.
We
That's
actually
not a
see it on
star,
your
that's a
screen.
planet.
Yeah.
So,
That is a planet.
so
Yeah,
one
what is that?
2 tips before you do anything else. I see lights further down from you. Set up your telescope and look at one of those lights through your telescope.
Okay,
And
hold
then
on.
when it's looking at that, adjust your finder so the finder sees the same light.
Okay, sorry. You're gonna hear my son. He's on a kayak in the lake, so he's like wondering what we're doing. So
Tell them you're doing amateur astronomy. That's what you're doing.
right. Okay. So we're looking. I don't think you can see. but
We're doing science.
we are doing. This is awesome. You guys are awesome.
So
This is
the
fun
reason-
for us.
You have made this entire the astronomy at the beach online presentation absolutely worth it
Yeah.
because we're able to talk with you. Hopefully we get you seeing Jupiter, but this is what we're here to do. So, we're more than happy.
Michigan amateur astronomers are the nicest bunch you're ever gonna meet.
That's
So
awesome.
the reason we're telling you to do this is your telescope is seeing a tiny, tiny little piece of sky, like looking through a soda straw. But your finder scope sees a bigger piece of sky, maybe the size of the diameter of your fist. So you could get really close to what you want to look at with the telescope and be frustrated because it's not in the telescope and you have no idea which way to move the telescope to get it in. So now you got this little finder scope off to the side that sees a bigger piece of the sky and typically crosshairs or something in it. And so when you get it centered in the finder scope, then you will see it someplace in the main telescope and it makes it a lot less frustrating.
Okay, thank you. We didn't know what that was for.
Yeah. So the
I knew
finder is to give you the wide field of view to find your object, and then you go to your scope and you center on the object.
Magnify it. Yep.
Yeah.
Okay, I'm gonna put this down so I can see with her. So hold
Go
on.
ahead.
Sure.
Take your time.
Do you have were you able to find it? No.
Okay.
It can be frustrating at first. Don't give up.
Look along the length of the telescope to point it at a light that's actually on, like a stationary light on land, first of all. And then align your finder so it looks at the same object. And then using your finder, point the telescope roughly in the area where
Yeah,
Jupiter
Liam,
is.
they
and
might not
center.
understand. They might not understand how to set and align.
Yeah, and it's kind of hard to do remote.
But we're gonna do our best.
Right.
Just see if you move. I would say move the telescope around until you can see that light in the finder,
Okay. Okay, hold on.
even
let
if
me
it's fuzzy.
see my finger. No, I don't see.
I'll give you a cheat code for if the telescope, if we do our best, but we're unable to get the telescope going quite for you, we'll have you just look up in the sky and we will direct you to some places in the sky that that will still give you a rewarding experience just being out under the stars. So we'll see if we can get this telescope going, but if we don't get it going, we got places for you to look that you'll be able to see naked eye.
Okay, well, and tell them what we just found in the side. What do you call it? The finder on the
The
left?
finder.
So tell them what you just found.
Like a planet.
Us, the big star.
Yeah.
Well,
So
okay,
we-
that's
So you
Jupiter.
actually put the star in the finder scope.
Well,
Yes.
that's
Okay,
good.
well, they're jumping ahead. So let's
Now look
So
through
we're-
the telescope eyepiece and
Yep.
see if you can see it.
Yep.
You may have to move it around a bit because you didn't align them. So you may have
Right.
to move over, go left and right and move up a bit, and left and
Yeah.
right and move up a bit, and repeat that
Yeah.
process until you come across that bright object again.
Yeah,
Yeah, it's a little harder.
Yeah, don't go super fast either. You want to kind of take your steady, slow motions, right? In little circles, right? And then move around until you see a light pop through.
Yep.
I think I'm as excited about this as they are. I think it was in the first light.
Oh yeah, all of us are like, it's like where you're going across a bolt and it's got a nut, and all the guys are like, "Here, let me try that. I'll get that off." Yeah.
But I still think that it's hard to see in this little
Finder scope.
yeah.
You know, it'll take you a few tries to remember the words finder scope. We'll help you with that.
It did a meridian flip.
This goes in and out.
Yeah.
What does that do?
Well, that's your focus. So if you get into roughly the right area, you'll see a really big, might be a blurry blob.
Yeah, with a little bit of red in it.
Then you turn the knob on your focuser to move in the main telescope, and that moves the eyepiece in and out, and that will change the focus point, so you'll be able to get the image in focus.
Okay, well, I can't hear you. You try it. All right. We're not having luck, but we did find it in the side part. We just can't do it in the other part. But I'm excited.
Which is why we are recommending to align them during the day, because that way, then once they're aligned during the day, when you bring them out, and if you leave them out, then at nighttime you just point one, and the other will see it automatically.
Yeah. So what Liam's trying to tell you is that little scope on the side, that's the finder scope. What you have to do in the daytime normally is you're going to point it at something on the land, right? I don't care the top of a tree or a chimney or something, or a light pole. And then you're going to look at that in the little finder scope, and you're going to go over to your telescope, and it's probably not going to be there. So then what some people do is they'll go to their telescope first, and they'll say, okay, let me move this around, because you're going to see things in the day move, right? And then you're focusing, and you're going to be able to point it to where you're looking. And then you're going to go to the finder scope, and there's little adjustments on it. And you want it to point to what you're seeing in the eyepiece. So then at night, when you go out, you're going to look first through the little finder scope. And then when you go to your eyepiece, you should see it.
Yeah.
Okay. We'll do that in the morning. So that's good.
I don't know what your forecast up north is for, but down here, his focus is not good tomorrow night.
Oh,
all right. So here's what we're going to do. Yeah. We're going to have you look up. You're going to look up at Jupiter with your naked eyes.
Okay.
And you're going to see Jupiter. You see
that
planet.
Yes.
That's the bright one.
Yeah.
So you're going to look at that. So that's Jupiter. And now you're going to look a little bit to your right of that for the next brightest star looking thing. That's Saturn.
That's Saturn right there to the right.
I see it. Yeah.
You see it. That's Saturn. Now let's keep going. To your right. Tell me if you see something that looks a little bit like a river or like steam. To the right of Saturn.
All the way across the sky. Right over your head.
It would be coming up from the ground, going up into the sky.
Yep. Do you see that?
It looks like a cloud or a haze.
Yeah, it's a hazy cloud.
That's the Milky Way. You're looking at our galaxy.
Oh my gosh.
Yes.
Now, let me give you a tip about that. It takes your eyeballs about 40 minutes to get used to the dark. That means your pupils get really big. They collect a lot more light, and they become very sensitive to seeing faint things. Yeah. It turns out in about 20 minutes, you're more than 90% of the way there. If you look at a bright light bulb, all of that is erased, and you got to wait another 20 minutes again.
Yeah.
And that includes the light from your cell phone.
Yes.
So you definitely using your eyes at night, you got to be careful, because you'll knock your night vision out again and again and again. I'm guilty of doing that all the time because of my imaging.
No,
but
nobody's up here, so we're at the lake by ourselves. So it's probably a good night to do that. Then
it would be great.
Yes, this is a great night to stargaze.
You see that haze? That haze you looked at, okay?
Yeah.
Now follow that right over your head and over to the north side of the sky. Can you see anything in the north? You should see.
We can't see north. We see from mid sky south and east and west, but more on the south side of the.
Okay, because I was trying to show you Cassiopeia, which is a constellation in the north.
Yeah. It connects to it. Now, are you able to look straight up? If you follow that steam going straight up, do you notice that that steam seems to get a little bit brighter up there?
Yes.
Oh yeah.
You might be able to see, once you dark adapt, you might be able to look there and you just notice thousands and thousands of stars that are making up that river. That's what we call the Cygnus region up there. There's a constellation called Cygnus the Swan, which is a part of what we call the Summer Triangle. And right now it's directly overhead. And you're seeing a lot of stars that are part of the galaxy's arm that we're looking at. So you're looking at that.
Up north, the skies are just beautiful.
Yeah, they are.
Yeah. And that's why you're able to, that's why even with 15 minutes of being out there, you're still able to see all of that. So you're looking, that's one of the hot spots of the sky is the Cygnus region. You can look up there, see thousands of stars. You might be able to make out of some of the brighter stars, you might be able to make out a cross. If you can do that, you're looking at what is typically called the Northern Cross. That is, it's called an asterism. It's a part of a constellation, Cygnus the Swan.
Yeah.
There are other, binoculars are always a fun thing to get because you can look closer in at some of these things.
Yeah, we have them. We can go run it. Well, not now, but we'll go get our binoculars too. I didn't even think about
Yeah, those are great.
Go back. The things that we're sharing, go back, come back and look at them through your binoculars, and you'll see some awesome views. The stars, you'll be closer to them. You'll see a lot more stars through those binoculars, and you may catch fuzzy patches here and there. That's a very good way to start enjoying the night sky. So let's see, let's go. So right of the Milky Way,
you
what
have
can they see,
Vega.
folks? So they can see, they can see Vega. So one of the real bright blue stars that you're looking at, you might be able to see it. It's called Vega.
Okay.
You see that beautiful bright blue color, the brightest star of that summer triangle. And by now you should be able to make out that triangle.
Yeah, that's it.
Yeah, the triangle's right there. Do you see like right above our heads, right there?
Yep, absolutely. That is a summer triangle. You can follow that summer triangle and it can help tell you what season you're in. As the summer triangle rises east, you're in spring heading to summer. Directly overhead, it's summer. Summer falling down into the west, you're in fall season. Summer triangle's gone with only one star of it rising, you're in winter and there's usually snow on the ground. We use those stars, we use certain special stars to help us determine what season we're in. But the secret is, if you stargaze all night, the night sky moves and that triangle moves all the way to the same position it'll be in a few months from now as the sun sets. So it's pretty fascinating. You get a preview of what the sky's going to look like at sunset if you stay up late enough and watch it roll right over you. The Milky Way moves too. Everything moves and turns. So that's one interesting thing about the night sky. It shows you kind of how the Earth rotates, how fast the Earth rotates as it's moving from night to day. The moon is going to rise a little bit later. I think around 2 or 3 in the morning. I haven't checked.
So one thing to remember when Adrian's saying about rotating, you're standing still right now, but even though you're standing still, you're moving at almost 1,000 miles per hour because that's the speed the Earth is rotating.
Yeah, but space is so big, it doesn't look like anything's moving much. But if you stand there for 5 minutes, you may notice that where you were looking, everything moved a little bit to the right. That's something that you get to see as you get used to the night sky more. You begin to understand that it moves, how it moves, and in some cases, it feels like it moves pretty quickly. So let's see. Let's go.
Now the moon is going to rise in about an hour.
Yeah.
Because they have a view to the south. It's going to
They'll
take
be
a
able to
little
see.
bit, but you'll start seeing it. And that's also a nice little object for you to try to put your scope on that, because it's so bright. It might be easier for you to find that too.
Yeah.
Okay.
For lining up your scope, the moon is a great first target because it's so bright.
Okay, we can do
In
that.
other words, what he said. Yeah. So yeah, you've got about an hour, maybe an hour and a half for the moon to rise high enough for you to see it, depending on what's on your horizon.
I would say when you do get back to Troy,
Don't expect to see everything you're seeing now.
To the local astronomy club and find out when they're doing events, or reach out to them, and maybe somebody can come and help you.
What's the name of the astronomy club?
Well, in near Troy, the nearest one is the Warren Astronomical Society.
Yeah, I'm in the Warren Astronomical Club. So if you sent an email,
No, I usually do, and I don't know that.
yeah.
Okay.
And so is Bob Tremblay.
Yeah, I'm their outreach officer. Well, for the next couple months anyway.
So someone in the club would probably meet up with you and give you some pointers and help you get lined up. When they'll do it some evening on a weekend, like maybe a Friday or Saturday night. And then,
absolutely.
After that, then if you want to join a club, because the club does their club member only events. If you join the club, you can go along to those events with your scope, and then you get all the guidance and help you could ever want, and then some.
Yeah, we'll get that scope pointing. The moon is always the easiest way to, bring your binoculars out and look at it too. If you still struggle with that scope, use your binoculars on the moon. It's a fantastic view.
Yeah,
she's running up to go get her binoculars. She's like, I'm gonna go get my binoculars now.
Well, every astronomer worth their soul carries a pair of binoculars with them, because if we want to find stuff that's kind of tricky to find, like a comet or whatever, that's it's not easy to do so in a telescope. So if you want, and especially if it's a manual telescope, so what we'll do is first we'll use binoculars to find the object in the night sky, and to identify stars that are nearby and star shapes that are nearby. And then we'll turn our scope to the same area and match them up to try and get the object into this telescope. So they are an essential part of astronomy.
This is so exciting. I had no idea we'd be doing this tonight, but we saw the link and we said, let's join. And this is very, very cool, you guys.
And if this was in person, if this was an in-person event, you'd be looking at planets and globular clusters and open clusters and planetary nebulas already by now. I'm telling you, you would be, and we show you the constellations, we guide you around the night sky, we teach you the constellations, we teach you all of this stuff and get you up and running.
Sorry about that.
Fast.
Yeah, we'd be pointing instead of having you look. But
look, that's all right. It's all very cool.
Yeah, we're glad we got you this far, because what we're gonna direct you to do is we're gonna have you take those binoculars when you get them and go right back to the top of the sky where you were looking at all the stuff in the summer triangle, and we're gonna have you
look back up the triangle.
Yep, and you're gonna have you follow that cloud, that steam through the triangle, and just look at all the stars that you're gonna see. You may see.
So all of those are steam, as well as Adrian's describing it as.
Yeah.
That is the light from billions of stars in the Milky Way galaxy.
Yes.
Okay, if you look at, are you seeing it with the hair? I'm gonna not give you the light. So
they try and avoid shining the light near her eyes, because it wipes out her night vision.
Okay.
Yeah.
And she was just inside. So it's probably wiped out anyway. It'll take a while to come back to it.
It'll take it a while. So I think what we're seeing, someone sharing. Who's sharing? Are you sharing?
Tim is sharing that. That's Sagittarius.
Yeah, that's what's out right now.
Sagittarius, yeah.
Yep. So Sagittarius may be visible. The asterism is called the Milk Dipper. Interesting fact. Can you see the Big Dipper from where you are?
It should be in the northwest.
Yes. Can you see the Big Dipper?
Yeah, I do.
So there's a little haze that is not normally up here. Like, we don't have crystal skies up here.
Oh, they have a bit of light cloud, it sounds like.
Yeah. So here's an interesting tidbit that just from observations. look at the angle of the Big Dipper bowl, looking northwest, then turn directly south where you see the haze. Look for stars that kind of look like an inverted dipper or kind of like a milk dipper, and they're angled almost the exact same way. That's the constellation Sagittarius, which one of its stars points towards the center of our galaxy. Around the equinox time, as the sun sets, the angle of Sagittarius and the angle of the Big Dipper are just about the same. It's just a personal way that I've always used to kind of tell what season I'm in, the transition from summer to fall.
Yeah, I think we might be overloading a little bit. So,
but that's a cool little thing that I just from naked eye visualizing. I'm not even sure if you saw Sagittarius yet, but it's one of the neat little things I'd be pointing out if we were in person.
Yeah.
But the important thing
we
is
need to get that little app, but because we're not with you guys, but we need to do that little app so that we can see.
Yeah. And it helps. So
that'll help. That'll help a lot.
I would say maybe use your telescope or use your binoculars and look at Jupiter. If you look at Jupiter with your binoculars, you will see a big bright dot, and you'll see some small dots beside it. The small dots are actually Jupiter's moons. You can see them in binoculars.
Yeah, good point, Liam.
Okay, and just as a refresher, Jupiter is where you had
biggest,
a star.
brightest dot in the sky.
Okay.
Yep. Brightest thing in the sky.
Besides the moon is one. Besides Venus, the moon. You have the moon, Venus, or sun, the moon, Venus, and Jupiter is the order of brightness of the objects in the night sky.
Do you want to walk out further, Janelle?
Then it goes Saturn, and then it goes Vega.
Yeah. All right, go walk out there. We're on a dock, so I'm like, okay, we just can't.
Oh, be careful! Don't we're getting wet.
Yeah, yeah. Falling in the water is not a good idea because water's cold, and looking up from water doesn't work as well.
So, if you see the bright object in the night sky, the brightest one in the southern sky, point your binoculars at that. You will see 3 or 4 dots right beside it. I think it's 4 is what you'll see. It depends. Sometimes some of the moons are in front of or behind the planet, but you'll see some dots that seem to be in a line with the planet, with the bright dot.
I see it. It's right over right here, right there. I don't think that. I think you're looking at the wrong. Look this way. Which way?
Toward the bright object that you started with.
Here, back, right here, Janelle.
So quick public.
Yeah. Okay,
you see the dots beside it?
She sees it.
Yeah, now she sees it.
Well, those dots you see beside the big one, the smaller dots, which are in a line together.
Yes.
They're the moons of Jupiter. You're actually looking at the moons of another planet.
Whoa! You see Jupiter?
Yeah.
That's what we love to hear.
That's the response we hope for. For those of you that have joined this channel and are looking for beginning astronomy, you're living it. We have 2.
We'll have the presentation in a while, but we are actually helping someone get up and running.
Yes.
So now, if you do the same and go to Saturn, you'll see at least 2, maybe 3 dots similar, and you will actually see the moons of Saturn as well.
Let her look at the rings.
Yeah, it's possible. You might get the rings. You just might, but they're very small.
It looks like an elongated planet, but you will see its moons for sure with a telescope with binoculars.
That's the second brightest thing, to the right of Jupiter. Yeah.
Now, since you managed to be able to see them with the binoculars, when you get a moment, when you go back to your telescope, try and align your telescope in like you had a while ago, and look at the very first bright spot and focus your telescope. If you can try and get it, it'll take a while, but practice with it. Forget in the finder first, then search around the sky with the main scope with the 20 millimeter eyepiece, and you'll be able to. You will eventually come across the biggest, brightest object, and you will actually see Jupiter. And what you'll be looking at will be, you will see striped colors on the planet. You're actually seeing the cloud tops of another planet.
Okay, so the other thing you need to know is that all of us that are sitting here inside buildings and in our
Are
little
jealous.
areas are jealous right now because we can't be out there with you looking at it.
Yep.
Well, we wish you were here with us. Trust me.
Oh, if we were, I'm telling you, you'd know half the sky by now.
Oh my goodness. Well, and now it's gone really dark. So like the last light has gone up here and now everything's starting to pop.
Excellent.
That's what we want.
Now you see
That,
the Milky Way overhead even better right now.
Yeah, the Milky Way is probably getting brighter, a little brighter.
Yes. And as long as I don't look at the screen, I see the difference now. That night vision you said about the eyes adjusting,
Yes.
like that is real evident.
Yeah.
Yes. You're getting used to it. Everything comes out. Anything that you look at in the sky that looks like an interesting region, put your binoculars on it and see what it looks like in binoculars. There you might run across some amazing things while you're looking at it. For the rest of you that have joined and we're looking for the beginning astronomy, I think we've said it once, we'll say it again. We have a very fortunate opportunity to actually be living beginning astronomy.
Yeah.
Any of the tips that we're giving to, and I don't see the names because I'm using my cell phone here.
The name is the Davis family.
Yeah.
Janelle.
Janelle and Nancy.
Janelle and Nancy, any of the tips that we're giving, if you're looking to begin your journey in astronomy, we recommend doing the same thing.
Yeah.
If they have the ability to get to a place that's dark, they were able to do that. If you're living in a city, you've got city lights, there's less that you're able to see, but I can tell you that even under city lights with my binoculars, I was still able to see the moons of Jupiter, and I was still able to look at Saturn. I'm able to look at bright objects in the sky. So you can still enjoy the night sky, even if you don't have as dark a sky. As my name memory goes bad, terrible. I think Janelle, you said?
Janelle and Nancy Davis.
Janelle and Nancy have a nice dark sky that they're looking at right now and beginning to learn. And you can still look at objects in the night sky as well. So,
are you still using binoculars, or have you been back to your telescope?
We are still using binoculars.
Okay.
Yeah, we're not having much luck with the telescope. I can
Well,
find it,
how about,
but not in the eyepiece.
well, how about you enjoy the night sky with the binoculars, because the views through binoculars are fantastic, and you can continue doing that. And when you do get back, if you bring the scope back with you, reach out to one of the astronomy clubs. Someone will meet with you. They'll help you get set up. They'll teach you the basics. They'll get you going. And from that moment on, you'll be able to know how to do it yourself. So when you do next time go out to dark skies or any skies, you'll be able to get yourself up and running. And I recommend you do so initially set up while there's daylight and get aligned and all that kind of stuff. When that's done, then at night it becomes easier because it's all done during the day and you can see what you're doing.
Okay.
So I hope you're enjoying the view through the binoculars because you can see an awful lot. If you look at the stars, you'll see they have different colors. You see that?
Yes, I do.
So different color stars tell us a few things about the star. And one of the biggest things it tells us about is the temperature of that star. So if you imagine a piece of metal and you heat a piece of metal, first of all, it's a really dark red. And then it gets hotter, it turns a brighter red, and eventually turns orange, and then goes a yellow, and what we call it into really bluish white, like a white hot, okay? So the different stars, based on the color, going from red is a cooler star, yellow is a hotter, white is a very hot, and a blue-white is the hottest star you can find. So if you look around, you actually notice a lot of the stars have varying colors. So we can tell that whether the star is a big star or not, because the hotter stars are always the bigger stars, which is they're always a very white, bright white, or a blue-white color.
Oh, okay. Oh, look at all of them.
I know there's like if you could see what we see right now, it's hundreds of thousands of stars. It's crazy.
Well, what you're actually seeing is what you can see is a few thousand really, but behind that, the light you're seeing in the sky is actually from billions of stars in our galaxy.
Whoa.
Yeah, you're looking at billions of stars is what you're seeing.
Billions.
Now, sometimes it looks like they flicker. Is that something?
That's our atmosphere.
Okay.
Our atmosphere makes the stars dance or flicker. That's twinkle, twinkle, little star. It's twinkling because of our atmosphere. Because the amount of light that reaches us from these distant stars is so little that our atmosphere can bend that light. It gives it the twinkling effect.
Kind of like looking at something that's underwater, under clear water, and there's ripples. Our atmosphere is doing that for the stars and for the planets as well.
Wow.
The planets are so close to us, they reflect so much light that from our sun, because you can see a planet doesn't give off light. It's our sun's light reflecting off the planet. So the light reflecting off the planet is so bright that it doesn't really get affected as bad. But stars, the amount of light that reaches us from a star, a distant star, is so little that our atmosphere has a greater effect in it, which makes it twinkle. And the less they twinkle means the better the sky quality is.
So if you're seeing some stars like Vega, if you look up at bright star Vega, which is one of those 3 stars in the triangle, the bright blue star.
Yes.
If it's not appearing to twinkle as much, then you've got a good steady night to be looking at those stars.
She said there's a haze.
Yeah, they're pretty solid on those 3.
Mm-hmm.
That's what astronauts comment when they're in space and they're looking out at the stars. They don't twinkle.
I can't hear you, John.
Yeah, I already said when you're out in space, they don't twinkle.
Yeah. Okay,
And
so I was going to say I recommend that you just go and enjoy. You can listen in to us. But go and maybe even get a blanket, throw it on the ground, lie down there, and look around the night sky. It'll be comfortable, and you get to see so much with just your binoculars. Even if you don't get up and running with your scope tonight, just your binoculars, you get to see so much. You see all the colors of the stars, and you'll see areas where there's few stars and areas where there's lots of stars. But right now we're looking into the Milky Way directly above, so there's a lot of stars there right now.
Yeah.
So there's Saturn. If I don't know, I know you don't want to look at your phone, but if you are on there, we have an image of Saturn right now.
Are you seeing our screen right now?
We are.
Okay.
Yeah, we almost recommend.
We're having trouble getting through the twinkle factor here. You know? A lot of atmosphere.
Atmospheric scintillation.
Scintillation.
Scintillation. That's the proper name for it. I did not make that up.
Well, he's not incoherent. He's decoherent, perhaps.
So our guests have gone on mute because they're enjoying the night sky, I think.
So, do we want to turn over to Jesse?
Jesse?
He's about 45 minutes late for his presentation. So
let's switch over to Jesse and do
what I'd like you to do
presentation, and they can listen in the background.
And Jesse, put 4 slides up at once and talk.
Look, I can talk fast. I can whip through them pretty quickly, but I would like to share at least the slide deck for you guys. And
since we did go through all the trouble to make it and everything.
Yeah, since I spent the time of actually putting it.
We had
a serious emergency.
We had someone who's close to our cause.
But the real value of this to everybody listening is that it will give you an opportunity to heckle.
Oh yes, we have to give you
one of the more entertaining presentations tonight.
That's right.
And Jesse, for the people who are joining for this, are you doing this again tomorrow at this time too?
Well, not at this time. Hopefully at 8. Yeah.
Oh, at 8. Yeah, that's what I meant.
Let the heckling begin.
Yeah, we had
it's 8
a
o'clock
necessary
Central Time.
delay. We had a clear sky delay.
Yeah. So okay, Jesse.
By the way, the Yankees are far ahead of the Red Sox, so I'm doubly happy. Not only because the Yankees are far ahead of the Red Sox and we're trying to get into playoffs, but we've done outreach, which I don't know if we did that last year with our online presentation. I'm more than beyond thrilled. And Ford Astronomy Club, you get the thumbs up, the presidential award for the Astronomy Club event that I haven't invented yet, but I'm going to work on that.
Just
for doing outreach online directly. Sharing the night sky with folks that are new to it is our passion, and we had a perfect opportunity to do so. So you carry on. I'm going to go on mute, and I've got a few other things to work on, but I'll be listening in as well. Carry on, and now you got even less time to rifle through your slides.
Okay, so Jesse is who's presenting his journey, the beginner's journey to astronomy. He's a new member of our club, and has recently acquired a telescope and so on after lots of conversations and so on with us. And he's going to explain the ups and downs that he's experienced as joining, or not only joining the club, but getting into astronomy and stuff he's learned, so others can learn from that. Over to you, Jesse.
Starting with the misfortune of selecting the wrong astronomy club to join.
No, the right astronomy club.
So I'm assuming you guys can see my screen.
Yes, we can.
All right, good. So my name is Jesse. I do belong to the Ford Astronomy Club as a member, and I love all the guys and love the club no matter what they say. So let's get into this. And so the items that I'd like to cover today is sort of the why. Why do I have an interest in the hobby? What did I think I wanted to do?
Can I pause you for a moment?
Yeah.
Do we want to record this?
Or tomorrow, either way.
It's going to be recorded. It's recorded by YouTube automatically.
Oh, that's right. It is. Okay. I apologize. Go ahead.
Oh, you're fine, Tim. So this is sort of the items I wanted to cover is sort of the, why do I have an interest in the hobby? What did I think I wanted to do? How much did I think I wanted to spend? And we'll get into that a little bit more. And sort of the journey of where I started, what I expected, and sort of the reality of it, and where I wanted to go and where I want to go now. And so obviously that indicates something's changed, right? And at the bottom, you'll see each of you will have your own journey in these, and these are just my thoughts and experiences that I want to share with you guys. Okay, so first of all, I'd like to open it up with Carl Sagan, of course. Somewhere something incredible is waiting to be known. And this is one I like just because I think continuous learning is important. And I think when you stop learning, you're on your way out. So, okay. Why did I want to get into astronomy? Well, I can tell you that right out of school, when I was in high school, there was a local astronomy club in Hillsdale, Michigan, for those of you that know that area. And I went to a very small school called Camden Frontier. It's K through 12, one building, one lunchroom, one library, gym, so on and so forth. Class D school. Graduating class size, I think, was 38 kids. So anyway, we didn't have much to do except work on the farm and milk the cows and that kind of thing and bale hay. So I wanted to get into astronomy because I had an earth science class, and it was just something really super exciting to me. And my first telescope I ever got was an Edmund Scientific 4¼ reflector. And I know some of you probably know that scope, and that was my first scope. And so I got really excited about that. I also, from this list, as you can see, I wanted to see things, right? That's one of the biggest things about astronomy. I think a lot of people is like, look, I see these things in videos and I see them on TV. I want to be able to see them, like was mentioned earlier. I want to have a connection to the universe. I want to feel that. So I wanted to see that. And I thought, I'd like to take pictures of things. I didn't know anything about it, but I thought it'd be kind of cool to take pictures of things and show it to people. I wanted to involve my family and expand, my children's knowledge and experiences so that we could do something together and you could look back on that and they could and say, this is something we did, right? It's that family time. Meet new and interesting people, some of which you're seeing tonight and hearing them. The bantering, there's a lot of that goes on, but that's all in good fun. I want to be one with the universe. Kind of this was already mentioned earlier. from Adrian, I think. And then this is the funny one, like be the cool neighbor with the big telescope, right? So it's like, who doesn't want people to come over because you got this big telescope sitting there and share it with them and show them things, right? Because I think it's really cool. You guys still with me?
We're here.
Yeah, we
Okay.
still are. I muted myself.
We'll give you a hard time later on. Don't worry.
Okay, all right, very
Let's
good.
get started first.
Because I would be disappointed if this 20 minutes goes by and I was talking to myself because something
Oh
happened.
no, we're letting you get started on your own first.
All right, so where to begin? What do I need to get started? Right now, this is really important, and this was also mentioned earlier. So this is some of my advice, some of which obviously I've gained from other people, and that's the other important thing to know. I'm one of these people, I'll be the first to admit that sometimes when I know something, it's because somebody else shared it with me. I didn't necessarily read it or watch it in a video. Somebody in my club shared something with me, or I had a conversation with them, and I gleaned this information from them. So some of this is that. Starting out, join an astronomy club. You guys heard that earlier. Like, this is really important. Join an astronomy club to gain that knowledge and talk to people, which is the second point. And look at their equipment. Now, this is good and bad because there's certain people, I won't mention names, but they've got the means to get some really nice equipment. And so there can be this tendency to look at some of that and go, oh my gosh, I really want that. And then you start researching it and you're going, oh, I don't want that because the price is astronomical. But anyway, it's all a matter of priorities, I suppose.
No pun intended with that astronomical.
Yes, that's correct. And then again, ask questions, get involved. Okay, you heard I'm new, but here I am, right? And I'm sharing things and I'm putting this presentation together. But you get involved, you do your part, and then ask more questions, right? Because that's the only way you learn is you ask questions. Don't hold things back, even if you think it's stupid. And these guys will tell you, I'll ask some stupid things sometimes and they'll laugh about it. But it's also one of those things that it's a good learning tool, because when those things happen, you don't forget it and you retain things better when you're uncomfortable. And that's my experiences. Your agenda. These are things you need to ask yourself. Like, what is it I want to do? Right? I'm hearing Jesse what he wants to do, but that might not be what I want to do. Make a list of those things that you're going to need. Research each item. Watch reviews and read. Watch YouTube. Watch videos. Talk to the guys in the club. You know, ideally, you do want to set a budget. All right. And then no matter what, this was also said earlier, bounce it off of somebody that's experienced in the club. Right? These guys, as you heard too earlier, I think Tim was sharing that, hey, look, my first two scopes, I kind of made the wrong move. And those things will happen. And so that's why it's really critical to talk to people in the club and bounce things off of them before you do anything. So during the time you're trying to figure this stuff out, right, here's some other suggestions. And we're seeing this tonight, and it was mentioned again. Learn the night sky. This is one of those things, you know, Liam and I talked earlier and he says, hey, share your experiences. Okay, so here's my experiences, right? I wasn't learning the night sky like I should. And so what happened is I get out to stargazing and I got my telescope and I'm feeling pretty good. And I'm, you know, going through the alignment process. And then at one point, you know, the guys were like, so what's going on? And I'm like, I'm aligning it again. Well, of course, then they want to help, right? So they're thinking, okay, I'm going to come over and help. And one of the questions was, well, put your scope over here and, you know, look through it at your finder scope. I said, yeah, you know, that's a problem because I didn't align that first. And of course, they're like, well, that's the first thing you do. So anyway, and then it came to, well, identify the stars, right? You got to kind of know what you're looking at. So when the scope goes here, or if you have a go-to as an example and you're trying to align it, and it says, put this into the center of your eyepiece. If you don't know what you're looking at, and this is, you can get lost, right? I can tell you as a new person, like when you look through the eyepiece, everything looks bright. Okay. I mean, to me, like, I understand that, yes, there is a brighter object, but if you're not moving around looking for it and you run across the first one and you think that's it and you say, go, this is it, align to that, everything's going to be a mess. And that's what I was running into.
That's when we taught Jesse what a bright star looks like.
Yes. And so you'll hear that. And so learn the night sky. It's important. And have somebody like Liam help me, have somebody help you align it for the first time, and so that you can have that experience. So the binoculars, right? As we said earlier, this is a good one. That's really going to help you identify things. And yes, I think it was Tim that said earlier, you can go out and look at things with the naked eye and constellations and identify things. And you can have a good experience with that, but a pair of binoculars really opens that up even further for you to look a little deeper and get you more excited about things. This second bullet point's really close to me. And when I say this, I say it sort of jokingly, and that's go outside at night and look around and look up. And what I mean by that is, if anybody has paid attention in today's world, everybody's always looking down, right? They're always looking at their phones. They're always looking at their tablets. And sometimes even in astronomy, they're looking down. And so I think there's so much beauty out in the world that when you go outside, even in the daytime, I think it's healthy to look up, right? And it's also healthy to spend time with your family and look up and get everybody off the phone. That's one of the saddest things you see, is when you go out and people are having dinner, nobody's talking to each other. They're all looking at their phones and stuff. So anyway, that's my little pet peeve. Look at apps and start learning the night sky and where things are at. So that's the other thing. It's not just necessarily knowing, oh, that's the Big Dipper, but like understanding where they're at and when they're at. We talked about this a little earlier too, about seasons and where things can be at different seasons. And that's going to be critical too when you go out, and especially if you're by yourself and you want to try to find things or get your equipment set up and aligned. You need to have an idea of what you're going for and what you're looking at as you're out, let's say in October compared to June. Research some good apps. We talked about this earlier too. Go ahead.
I would say about learning the night sky, each season you need to learn maybe 4 or 5 constellations, and that's it. If you know those 4 or 5 constellations per season, you can use that to guide your way around the night sky. And in the next season, you learn another 4 or 5. And by the time you come around 1 year, you know them all already.
Yes, it's good advice. We talked about the apps earlier, Stellarium, Sky Safari, there's several others. Get the family involved, right? This is important to me. And this doesn't mean just children. Some people don't have children. I mean, get your partner involved, get your friends involved, get your other family members involved, bring people outside and let them see there's a different world out here. And then again, ask more questions. Okay, so 3 areas of concern. These are things that I've sort of picked up on. Speed. You'll want to go from 20 miles an hour to 100 and start buying things before you really understand what you're doing. Like I'm talking about my experiences. If you're somebody that has a concept of delayed gratification, that's fantastic. I have not been one of those people normally, even though that people close to me would say I could work on that. So I would encourage people to kind of follow that guideline. This will in turn make you realize what you think you know is wrong. And that's what I'm finding out. And I think in general, as you get older, right, we can all look back on what we thought in high school, what we thought in college, if you went to college, what you thought when you're in your 20s compared to your 30s and 40s. Like you think you know, but you don't. And this hobby I'm finding is very similar. When you think you know something, you find out, wow, I didn't really know what I thought I knew. Budget. You'll start spending more money than what you've allocated. Now, again, this is my experience. You will also minimize what you've spent when talking with your partner and convince yourself it's okay to do that. So it's sort of like we joke about it. It's like, well, that looks a little different. Oh, I sent it away and got it cleaned, or, whatever. I mean, so I say this jokingly, right? Obviously, big expenditures, you want to share with your partner what you're doing. I'm not saying you don't, but I'm just saying that this is sort of the fun with it, is that you're going to look at some of these prices at times, depending on what you're looking at, you're going, holy moly. It's sort of that whole rule. Do I want to tell them now or later?
Have the name of a good bankruptcy lawyer.
Yes, right. Or hope that they have a hobby that is expensive too. That's the other thing that helps. Okay. So frustration, your concept of what you think you needed and what it will take is going to be wrong. And I talked about this earlier. Again, this is my experience. And again, I'm not trying to scare anybody. I'm just sharing my experiences. You will soon realize that you're in a black hole and you cannot escape. So this is at least me. Like when I get into something, it's like 150%, and I want to know everything. And I got a million questions, and I can't keep them all organized in my head because I'm thinking too fast. And then I see things and I'm like, oh, I gotta have that, and I gotta have that. And then like Tim just said, the next thing you know, you're like, wait a minute, do we need groceries for the next week? So anyway, there's things like that come up. Highlights of items I've learned. So this one was a tough one for me. I thought I had the naivety to think, at least, that for the most part, and I'm not saying this isn't absolutely true, that you couldn't do it, but I'm just saying in my experiences, that one telescope I thought should do it. Like I kind of knew what I wanted. I want to be able to view. I like to view, but I also want to do photography. And, you know, I thought I'm going to find one scope and I can do it all and be equally as good as any of these other people that are out there doing the same thing. Well, what you soon start realizing is, well, yes, you can do some of that, but how good do you want to be and how much detail do you want to see? And then you start learning that, oh, well, you know, if you want to do imaging and astrophotography, there's sort of this rig if you want to get really good at it and get a lot of clarity and be dedicated to it. But since you like viewing and doing imagery, maybe you want to go over to this one. If you don't want to do any imaging, well, then this big light bucket you might like. So anyway, you'll learn that, yes, there is a scope for you to get started. But if your interests are like mine, where it's very broad, and you like to dabble in lots of things, and you go 150%, no matter which one you dabble in, you're going to have probably more than one telescope. You're going to spend more money than you thought, and you're going to change your mind at least 10 times. That's, again, this is my experience. Go ahead. Somebody was going to say.
Yeah, I want to chime in a little bit because I had the experience. I remember looking at a Telview eyepiece and saying, $400, that's a whole lot to spend for an eyepiece. Then I got into photography. I've spent $1,400 on a lens, and then I've gone and done it again. And then I looked back and said, $400 for an eyepiece. Maybe I should have stayed a visual astronomer. And I use my camera for photography, for night sky photography as well. So yeah, the money will disappear if you don't set up a plan and say, okay, I will gradually get through this thing. So yeah. I can attest to that. A lot of us have
to that. To your point, I heard, I think, again, Tim talk earlier and some other guys, maybe it was Doug, they're talking about cameras and stuff. And I know some of the prices of these cameras. And, you know, I hear people like, I think it was Doug talk about his equipment earlier and cost. Well, here's the thing. When you start looking at your telescope and you say, well, I paid this. And then you look at this itty bitty little camera that you put on there, and it's like half of the cost or 3/4 of the cost of what you paid for the telescope. I start asking myself, do you really need that camera? so anyway,
that's good. No, that's good. You don't have to buy everything you need in one go. You can start off small and work your way there and trade up and slowly get there. And you don't always have to buy new either. You don't have to pay $5,000 for a mount or $4,000 for a mount. You can get them used. Don't always go new unless you are 100% sure. You can get really good equipment on the used market.
Yeah. And again, though, the caution is obviously there is this line of, and I think somebody said it earlier, is like, don't just start buying things because you have, let's say, the $500, and what you really wanted and what you think you want is the one that costs like $900 to $1,000. When the point was made earlier, like, don't have buyer's regret. Don't just like be compulsive and say, well, I can get that now, so I'm going to get that. And then realize later that you really wanted this other thing. So it's okay, again, to have that delayed gratification and force yourself to wait a little bit.
Yeah.
Okay. So then you get to this position, which I did, and I'm looking at myself and my surroundings at one point and going, should I really be here right now?
Can I make a statement?
Yeah.
I would give my left arm to be there right now. And I think everyone sitting here, everyone watching this who's into astronomy would do the exact same to be there right now.
Right.
Yeah, but after you return to Earth, because you might need your right arm while you're there.
I'll give my left arm. I'm right-handed, so I can give my left arm, no problem.
Well, I'll just get rich and give a few $1 million and fly on Bezos stuff. That's how I'll get out there.
Yeah.
Or
So
ask for a
anyway,
loan.
the question is, you'll get to the point where you're sort of like self-reflecting, and you're like, should I really be here right now? And that's not about maybe your interest, but it's about, you start seeing, like somebody said earlier, like, okay, I'm looking at the money going, and I'm looking at the equipment I'm buying, and holy moly. And then, the other thing, this is the other disappointing thing I'll tell you that I haven't mentioned yet. And these guys tease me, and they've said it way before I came to the club to lots of other people. There's this saying, and Liam, you can say it better than me, but it's something to the effect, when you buy something new and you're all excited, that you got a week or two that you can't even use it because the clouds roll in, right? It's that whole...
Oh, the astronomer's curse. Yeah.
Yeah. So that's the other thing. You like me, if I go out and all of a sudden I do get a camera, a really nice one like Tim and some of the other guys have, and then I probably won't be able to use it. So anyway.
Well, there's a theory around that. The theory is the more when you buy a new telescope equipment, we get cloudy nights, and the amount of cloudy nights is based on the expense of the equipment.
Yeah.
Now, so the more you pay, the more cloudy nights we get. But there's a way to cure it. You can either take the telescope, or the new equipment, or the astronomer, and throw them into a volcano. So, and I hate to waste good equipment, so I volunteer the astronomer every time.
Yeah. Well, so remember, we had a lot of smoke in our atmosphere.
Yes.
So, right on cue, there were a lot of purchases being made this past spring and summer that I can attest to all that smoke hanging around in our atmosphere. Yes, we know the wildfires were there too, but we astronomers like to take credit for everything. Carry on.
So now I'm going to get into something that's going to be maybe controversial. And again, you guys will forgive me because I'm new and I can play that card for a while. So there might be some disagreement about this, and there might be some corrections, but I'm going to just flow through this, and you guys can disagree if you'd like. This is my limited learning experience so far that I've collected, and I'm sort of demonstrating it in a few different slides. Now, the beginning visual, I'm going to break this down into the beginning visual. If I had to start from the scratch of the beginning, I would do probably a reflector or a Dobsonian, or somebody likes to call them light buckets, because I think you learn the nice sky. It forces you, a lot of times these are manual, so you have to move them around. You have to figure where things are at. There's this excitement about, oh, look, I found it. That's a little different than going boop, 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 and it goes bzz. So I think there's something to that. There is some small photography you can do. And I know this as far as like some of the planets, and you can capture things, even if it's moving, and you can, put it through some different software and programs and stack it and still get a neat image. There's constellations, some of these sky objects you can really look at. And again, like I said, with the photography, planets and star clusters, and I kind of break these down into little groups. Now, what I'd like to do is we'll go through all three of these, and then we can come back if you want to talk about your opinion on some of this. The second one is a Schmidt-Cassegrain. And I'm specifically calling this out as Alt-Az setup, meaning not an equatorial mount. Again, learn the nice sky, intermediate photography, and we'll get into that in just a second, because I think it was Doug maybe mentioned earlier, there's some things you can buy to, and there was a comment made about professionals and Alt-Az, but we'll get to that in a minute. The go-to functionality and tracking's there, which is cool. On the Schmidt-Cassegrain, not that you can't get it for the reflectors, but it's commonplace, I think, with the Schmidt-Cassegrains. And again, for at least the Meade line and the Celestrons, can you buy one and then put it on a different mount or buy them separately? Yes, you can. The intermediate photography, I think we're kind of moving now into sort of the planets and nebula and galaxies, where if you wanted to do the photography, again, with the back here at the reflector, it's sort of like planets and star clusters, because some of this requires more timed exposures, meaning you have to have some tracking. So again, this is just my experiences, and you guys can come back in and inundate me here in a second. The last one, I kind of see, my opinion again, advanced imaging is more on the refractor side with an equatorial mount, where yes, you learn the nice sky. The advantage though that you have is you have a wider field of view most of the time in a refractor. So you get, especially, and we'll get into this in a second with the photography, I think you can get things like, as an example, the Andromeda Galaxy, you can actually fit things in. You're not looking, I think Tim likes to use the word look through a straw. It's not that way a lot of times with a refractor. Yes, you can get, again, some field flatteners and some other things for the Schmitz, but we'll get to that in a second as well. The go-to functionality tracking is still there, planets and nebulae and galaxies. So again, those are sort of the three that I kind of categorized in my head. Now, these guys have a lot more experience than me. And so if you guys want to disagree or you want to go through any of these or maybe add some exceptions, now's the time to do it.
So I agree with you. The only thing I would say is the other than the Dob, which is the first one you showed, you can put a reflector and a Smith Cassegrain on an equatorial mount. So number 3 can take the first 2 of variation types of them on the equatorial mount. So because it's a mount that you can attach whatever you want to it, okay, within reason, of course, based on weight. But I think the overall summary, I think, is great. I think one is for easier to find and it's manual, but you have to learn stuff. Others are computerized.
The comment that I would make. Oh, I think I hear Liam's echo. Okay. So the comment that I would make is kind of twofold. So one is hooking a camera to a Newtonian reflector or a Dob.
Whoops, sorry.
Can really be problematic because normally when you put a camera on a normal telescope where you have that diagonal at the back, that diagonal adds a couple inches to the overall path that the light has to travel.
Yeah, someone who's also watching the presentation on YouTube, if you could mute, that may help us. We're hearing all that echo.
I'm looking, I don't see anybody unmuted.
Oh, I see several people that are not muted.
Yeah, but I don't see their microphone.
Let's do this. I'm going to hit mute all.
Yeah, and I'll mute Jesse.
Okay. And then, all right, and I think I am unmuted, and we'll unmute, and then anybody who needs to speak can unmute themselves.
Okay. I'm unmuted. Yeah.
Okay. So what I was going to say is that diagonal adds a few inches to the overall path.
Yeah.
When you put a camera on like a DSLR, that sensor is a couple more inches still. And so all of a sudden the sensor is so far away that it won't come to focus. But you take the diagonal off and you put the camera straight on the back of the scope. And so now you've sort of made up for it because you've sort of subtracted a couple inches by taking the diagonal off, added a couple inches by putting the camera on, and now you're back to where you started. When you're using a Dob, there is no diagonal to remove. And so what can quickly happen is you run out of focus path, you focus all the way in and there's nowhere left to go. So I just want to mention that. Gordon is on, I see he's muted right now, but Gordon would tell you, don't even think about astrophotography the first couple of years you get into astronomy. And I tell people, just put your camera on a tripod, which is what Adrian does, right? Just put the camera on a tripod, gateway drug, great way to do easy imaging.
Yeah, no, I agree. And as you know, that's actually the first thing I did with mine is I did the Big Dipper, right? I remember sending it to you guys.
But I like to add something about using Newtonians. There's
Yes.
Dobs, which are primarily designed for visual, and the mirror size and the placement are set up for getting an eyepiece into focus. If you're going to do astrophotography with a Newtonian, you go to a slightly different design. They start calling them astrographs, and the secondary mirror becomes a whole lot larger, and it gets positioned further forward so that the amount of out focus you get is easier to get to. So a Newtonian design for astrophotography tends to be set up differently than a typical Dob you'd use for visual.
Yes, good point.
When I took my 10-inch Orion and set it up for imaging, I had to move the secondary mirror forward to be able to get focus that wasn't sticking out 6 inches. So,
Janelle, you're very welcome. We're always happy to assist.
Okay, so now I've kind of broken this down a little more of a summary with the donut ring. And so on the left, reflector Dobsonian, big light bucket, very easy to understand and use, can learn a lot of things about the night sky with this and see a lot of beautiful objects. Also much more financially reasonable and quickly can be set up and ready to go. Now, if we move over to the refractor, again, these are my views. Designed more so for imaging and not so much visual. And again, I know there's some disagreement about that, but we'll get to that in a second. Except maybe planets, non-deep sky objects, unless you go with a large aperture. They do, however, have a great field of view visually. These can get very expensive very quickly, especially when you start moving up an aperture. And they are, however, usually much more portable. And I'll get back to that one in a second. The Schmidt-Cassegrain, just a good all-around telescope that allows you to not only learn the night sky and see a lot of objects, but also allows you some nice imaging as well. They can be heavy and somewhat less portable, and the cost of these is sort of in the middle of the road. Now, again, these are my views. I know one other conversation we had maybe a day or two ago on refractors, maybe it was at the club meeting, there were some opinions that said, no, wait a minute, there can be some nice visuals too with the refractor. So does anybody want to maybe add to that or kind of say something about that and their experiences?
Well, there are two kinds of refractors. You could spend $150 on a refractor, and that would be what we call an achromat. So it has an achromatic doublet, two lenses in the front of the scope and an eyepiece in the back. But those get color fringing. So, move the telescope off axis a little bit so the star is not in the center of the field. It's now at the edge of the field. And you'll notice a little bit of a red fringe on one side and kind of a purple fringe or blue fringe on the other side. And that's because the prism of the glass is sort of splitting the light apart. So great for visual. You don't care. Just put the object you want to look at in the middle. But if you're doing astrophotography, it drives them nuts that they get this color separation. So you can get this other kind of refractor called an apochromatic refractor, typically at least 3 elements. Some of them even have 4. Instead of $150, probably not less than $1,000 for a telescope that looks the same. But
Tim, I would jump in. If you want an APO, you're going to be spending $3,000.
Well, depending on the size, but you can get an Apo for about $1,000. It'll be a small one.
Yeah, and they're good, and they're really good.
You can get an ED glass doublet that is kind of a wannabe APO for that kind of money. You want a true APO, 4 inches or bigger, and you're going to be at the $3,000 to $4,000 range.
Explorer Scientific have a 102 Apo, proper three element, and they're about $1,000
for 4 inches.
I think you need to go.
It's 4 inches.
Well, I think the bottom line here for me, $1,000 is tough. Now, if you buy the the Apo, if you spend $3,000 on an Apo, not only are you getting, you're getting the craftsmanship of the Apo, and more than likely a better overall image. Mm-hmm. But I think there's still, even with those, don't you still need field flatteners if you hook up your camera to it?
Yes.
Yeah.
Okay, so you're adding on just to make sure you have a flat field.
I got a Stellar View 4-inch, and it's got four pieces of glass in it. It's got three pieces of glass in the front to form the APO, and then it's got a field flattener at the back end. That's I think the help me, Tim.
The
Nagler Teleview. Their Petzval design is essentially a 4, and that 4th element is the field flattener.
Correct. And in fact, I have that. And if I really go to a large field, they make a thing called a large field corrector. Even though you have a quad element telescope with a field flattener, you still put a 4th element on there. I did want to mention, though, they're not just being greedy. Regular achromat is just optical grade glass. These expensive Apos are typically made out of exotic elements like fluorite crystals. They have to be grown in kilns very slowly. It takes months and months and months to grow a lump of crystal big enough to be able to grind a lens out of it. And so they are limited in how fast they can make them. And that is why they are so expensive.
Yeah, and you know, look, the other thing, I just, you know, this is kind of why I broke it down this way. I think a lot of it does hold true. I'll tell you from a beginner's experience, right? If I were to go out and buy a refractor, and obviously, usually beginning for most people, they're not going to drop 3,000-4,000 or more. They're going to probably be, you know, 1,000, 1,500 starting out, and they're going to get something, a double or whatever they're going to get. And here's what's going to happen, I think, is they're going to be with other guys in the club that might have a Schmidt-Cassegrain or a Newtonian reflector, and they're going to be like, look at, you know, this nebulosity as an example. And then you're going to try to pull that in, and I think you're going to be disappointed, right? You're going to be disappointed in the fact that that refractor that you have isn't going to be able to see some of the things that these other scopes are seeing, unless, again, you start really moving up an aperture if you want to keep that refractor. And I think that was the point I was trying to make, is that, yes, they're fantastic for imaging, but there's things you're going to run into, especially in the smaller apertures, you might be disappointed in.
Well, one other thing to mention is in the visual world, there are these things called filters, oxygen filters. They're low band pass filters that will enable the views of some of these things that the cameras can pick up that light and image it. But in order to see it visually, you have to put a filter in your telescope, and that's how you see. So some of the views so someone has a Newtonian on a Dob, and they're looking as like, here, take a look at the Crescent Nebula, and you're like, that is so cool. Or take a look at the Helix Nebula. That is so cool. Then you wheel out your $3,000 Apo with no filter, and you point at it, and all you see are stars. And you go, what the heck is wrong with, did I just waste $3,000? And you're confused until the astronomer tells you, I have an O3 filter on my, and that. So in order to see it, you're going to need an O3 filter. Well, how much is an O3 filter? And then you have to start figuring that out. So there's even more to it than you get a good view, but then you also have to, I have no idea where its camera is. You also have to ask the astronomers, well, what are you using to get that view? Especially if it's visual, you'll find that a lot of advanced visual astronomy filters are a must. And that's how they're seeing a lot of other things in the night sky that you otherwise would be pulling down with like a special set of night vision goggles or H alpha modified DSLRs.
See, and again, now you're
dedicated
talking
astroscopes.
Money.
I just spent $300 to have my Canon 6D Astro modified. Why? Because I want to do night sky images, and I want to do nightscapes where more of the Milky Way is visible in the nightscape. There's a lot of HA data that's there that doesn't show up unless you're at a truly dark sky. And even if you're at a truly dark sky, there's other data you still may want to process. And you don't have to, so there's a lot of considerations that go into it the deeper you get into it.
There is, but my point, Adrian, is like, as a beginner, you're probably not going to start out doing all that, right?
Heck no.
If you're a beginner, I think
not
you
at
start
all
with a Dob.
Yeah, I
If you're
agree.
a beginner, you start with a Dob. If you can afford it, get an 8 or a 10-inch Dob. They'll fit in the back seat of your car.
Yep.
A 10-inch. You'll have plenty of aperture to see things. You won't be taking out a second mortgage on your house. Spend some money on some decent eyepieces, and just start enjoying the sky for a couple of years before you start trying to get exotic.
So this is good stuff. But I want to keep going because I want to keep seeing what.
So let me keep going. And besides, I got my daughter tagging me saying I'm going to need picked up soon. So let me. All right. So let me move to my next slide. So now I've broken this down into what I call the funnel of the journey. And this is, again, my experiences. So there's this sort of the beginning of an awareness phase. And this is where I listen and ask questions, right? I start becoming aware of sort of different options. And just like now, I'm still learning from you guys. And then there's some of this, like the discovery phase, right? Did some heavy research, watched some things, looked into some things. And then, of course, I start evaluating. And this is where I get a little more detailed and maybe a little more in depth in what I'm looking at, what I think I want to get into. And then at some point I decide, what is my intent, right? This is what I think I want. And then it's a matter of purchasing, getting the funds together to pull that trigger. And then I think a lot of guys do this. I'm one of these guys, I think. You start developing almost a loyalty. You start loving what you have and you become biased to the brand a little bit. And I think this is a very natural thing that can happen through this journey. All right. Suggestions of what to ask and what to do. And again, this is sort of a recap, sort of where's the nearest astronomy club I can join? Where do you all get together to observe, and how often do you guys do this? Do you have some club equipment I could try once I have joined? Somebody mentioned this earlier. How many eyepieces do I need and what sizes and types? This was a big one for me. It's like, okay, this is interesting. You know, I've got 8 eyepieces and I find I'm only using 2 for the most part. So anyway, that's just my experience. I like the 26, I like the 32. You know, could I use a 9 on a planet? Sure, but most of the time, what am I using? A 26 or 32? I mean, this is just my experiences. But again, I'm learning. So you guys could say, look, you're just getting started. Don't worry, you'll use the rest later. Find a mentor or someone you can connect with and help you on your journey. And so this is critical for me. It's like, you know, if you think you're going to figure it all out on your own, you're going to be spending a lot of money that you're going to look back on and go, I shouldn't have spent that money. So it's important to find a mentor, somebody that's already maybe went through that themselves. They can help you along the way. Ask members if they mind you looking through their equipment. And I say ask, don't assume. People are very, I've even become, I mean, people become very close to their equipment and they take very good care of it. And so, yes, most of the time people will share, but don't assume. Ask for advice on equipment needed to get started from other members in the club. And should I ask my partner for permission or forgiveness? Because that, to me, is probably the last part of what you're going to do. And so that's my little presentation. And that's the address for information on our club, if you'd like to contact the club. And that's what I got.
So Jesse, I just want to point out there's a local bike shop that I like, and on their counter there is a sign that says, for an extra $25, we will write you a receipt that matches what you told your spouse you spent on this.
Indeed.
There's another option as one of our club members, named not to be given out. He bought a new telescope and hid it behind the couch for a couple.
So there you go. I did it. I got it done. I don't know. It's about 9:30.
It was good stuff. It was good.
That was great.
That was great. Stuff.
So listen, I appreciate it, guys. I hate to run, but my daughter's at the Brighton High School football game, and I have to go pick her up.
All right.
Roger that.
Thank you again, Jesse. We'll see you tomorrow night.
See you tomorrow,
All right.
Jesse.
Hey, you guys know I love you all, so I'll let you go. All right, bye.
All right. All right, so it's 9:30, and I think we still have Adrian. Now, Adrian, I think the other live stream is kicking up with Doug Bach on his telescope going live, and I think we're about to go live here as well.
Yep, it's time for live views. We've got a pretty nice night and a pretty good choice of telescopes to choose from. We invite those of you watching this live stream to stay on this live stream because you've been getting a lot of good information from the Ford Astronomy Club. But we also want to let you know, I'm holding this thing with my phone again. We want to let you know that we've got a couple of other, I think we've got 3 other live streams of night sky. And I think for the first time in AATV history, we're including southern night sky. So things we can't see here in Michigan. We've got someone coming in, a good friend of mine from the the Explore Scientific Star Parties that I'm a part of every Tuesday. He's agreed to do some live night sky photography from his town in Argentina, South America. So you've got some options for viewing the night sky. We invite you to go check all of them out and support all of us that are doing night sky, live views of night sky, like the view of Saturn that you're seeing right here. Most times seeing Saturn's rings is when you get that ooh and ah and wow reaction when someone sees those for the first time. Now, we were able to get that reaction with binoculars and Jupiter's moons live here on Ford Astronomy Club's Zoom channel and I'm still thrilled about that. But there's more to look at, and a lot of night sky coming up. So with that commercial break over with, excellent presentation earlier. I'm packing my things for a star party I'm going to in Oklahoma, and I am looking at 6 bags of gear and cables and a computer and things, all because I started with an 8-inch Newtonian and said, hey, I want to do that. I want to learn more. And I ended up going the route of the camera. And my goal is to actually return to doing more visual astronomy and just getting through the night sky and seeing it, almost like seeing it again for the first time, because I've imaged so much. I've looked at the night sky with naked eyes, just looked around, see what target do I want, or do I want to get all of it? Do I want to image it with the Lake Huron in the foreground and all these other considerations? Where we'll be at, we're just going to observe. So, and that's what we would be doing right now. Hopefully next year we'll all be together and observing, maybe try and do some sort of a hybrid thing where we can still have presentations online, but live viewing with real people you can talk to and ask questions about your scope and come out. So we'll see if that's possible for next year. Hopefully we're much further along in this pandemic to where we can do that safely with top health officials agreeing. So with that, I'm going to turn it back over to you, Tim, and go ahead and show them some of the night sky.
All right, thanks.
So Tim, we've got one comment that was mentioned, and we were talking about the black hole of Jesse mentioned about falling into a black hole. Brian, who's commented a few times, said he accidentally connected his wife's DSLR to his first reflector just because, hey, why not? And from there, he fell into the black hole of astrophotography. It's contagious.
Yeah, and it's
So,
and
for me, it was Milky Way photography. It's like, I want to do that.
And
now I have, actually, I don't know if this will show you, and now I have a print of the Milky Way that I took at Lake Hudson.
Nice.
And I don't know if you can see it because I think you're sharing your screen, Tim.
Oh, yeah,
but, I have a 24 by 36 giant print of an image that I took at Lake Hudson of the Milky Way, kind of in this orientation that it's in right now. So it grows on you fast.
You have indeed fallen to the dark side, Darth Bradley.
Yes, I am a Sith. Oh yeah, there's my picture right there. It's available for sale if anyone wants it. Just inquire in chat if interested. I'm not gonna take this over and talk about selling this thing, but you see the reflection. That's why it's put in glass. But Lake Hudson at night at the boat launch.
Wow, beautiful.
So, all right, back to you all.
All right. So let me hit the share screen. I'll just share the whole screen. That'll just be easier because I can toggle through things. So in here, if I just bring up and then go to, I'll make it center. Actually, I'm gonna magnify on Saturn. So this is where Saturn is in the sky, almost perfectly due south right now. So this is not the live telescope. This is software that's doing this. And we'll take you in and you can see. So this is what the planet would look like. And actually, I will tell you, I have seen nights where, like right about like that, maybe not quite as sharp, but pretty close with your own eyeball. These rings, the ring system that you see here, about 150,000 miles from edge to edge. Thickness of the rings, however, I don't know if I'm gonna, let me see if I can cheat. Yeah. Let me go to the location scroller. I'm gonna see if this works. No, it's not, because I'm not actually in orbit around Saturn. This software will let me leave Earth and actually put myself in orbit around the planet. But these rings are only 65 feet thick. And this thing is about 9.5. Let's just liberally round it off and say it's 10 astronomical units away. What's an astronomical unit? The distance from the Earth to the sun is 1 astronomical unit. So this is about 10 times farther from the sun than the Earth is. Well, we're about 93 million miles. So that would be 930 million miles from the sun, or probably, well, more than 800 million miles away from Earth, no matter where you are. At all times, it's at least 800 million miles away. You can't see something that is only 65 feet thick from 800 million miles away. So it takes about 30 years to go around the sun, and twice every 30 years, those rings we see from edge on. And when that phenomena happens, the rings appear to simply disappear, and you see absolutely nothing. You see a naked planet out there. So Galileo saw that. His telescope was not really very good, and so he called these ears, and then one day the ears simply disappeared. He had no idea what they were. We now know what they are. Lots of little, chunks of ice and rock, not very big. This little gap here is called the Cassini division. The Cassini division, that actually is a gap. It's not just that the material there is dark or black. It's a gap. It's caused by a gravitational resonance with a little tiny planet called Mimas. I'm sorry, moon, Mimas. And so this is the resonance, the 2-to-1 resonance point between Mimas and Saturn. Mimas, by the way, looks like the Death Star, what the moon actually looks like. And so if you could put an object in orbit exactly in that spot, it's not going to be a perfect circle. Everything is slightly elongated, slightly elliptical. And so depending on what happens when Mimas comes around and your little particle that you put there comes around, it's going to get a little kick. That little kick is either going to raise its orbit or lower its orbit, depending on where it is. And it constantly clears out that gap. And so that gap stays there all the time. So we call that the Cassini division. The one thing I do want to do, if I can make this happen, actually, I'm going to hit this and I'm going to say I want to go there. This is going to cause a whole, there's something I want to show you about Saturn. This is going to take me a second. Okay, so now I'm in the location scroller mode. Really cool thing about the top of Saturn, if I can keep scrolling it up, if I can zoom in, let's get closer to the planet. Kind of hard to see, but this is a hexagon. So Saturn actually has this hexagonal storm at the poles. Kind of weird, don't know why it happens. But now that I'm in location scroller mode, if I go, I got to move away from the planet a little bit, I'm too close. I'm so close that the phenomenon won't happen. If I go absolutely edge on and I really work at it, and there you go. That's what happens to Saturn twice every 30 years. So that's what I kind of want to show you on the little solar system tour of Saturn. And now here's the actual Saturn. We're getting a little mud from the sky, the air kind of wobbling around. And so that's why you see Saturn kind of bouncing up and down, hot and cold turbulence in the atmosphere mixing together. It's why the family that was on earlier, and she was going to look out the window, right? Telescope through the window, said, don't do that, because your telescope needs to be out in the same temperature as the air outside, or these bad things happen. So we're getting some effects of turbulence seeing conditions, which is why we're not getting a crisp image right now. So it's viewing is not the best. I'll pause here. Do we have any questions?
There's none at the moment in on YouTube chat, and Adrian has said he's dropping, and he's that he enjoyed hanging out with us, and he said he's dropping. He wants to go join in some of the other streams.
All right, sounds good. You guys want to go look at Jupiter?
Yeah, Jupiter would look fantastic.
Okay, so Tim is going to drive the telescope over to Jupiter. And then we might need to go move the shutter. Okay, a bit. Let's see.
No, you're good.
Yeah, actually, we need to move it just a little bit, about 1 cinder block to the left. So flip the lever to the right, Tim. A little more. That's good. Yep, perfect. All right. Yeah, we were about a third of the aperture of the telescope was covered up. Now, I actually did go to a star and focus the instrument as good as possible. And so now what I need to do is change the target.
You can see the moon's off to the right. Now,
You can.
top, yeah.
Oops, let's go back to this mode. And now I need to change this to this, and let's brighten it up a little bit. And now we can see a little bit. So you can see Jupiter actually is that the
the great red spot.
I think we're seeing the great red spot. Now, if I keep brightening this up a little bit, you'll see the moons come back. So it's going to wash out Jupiter, but you can see the three moons off here to the right.
Those are Io, Europa, and Callisto.
Callisto.
Ganymede is up and to the right, probably out of frame.
Oh, Ganymede is out of frame. Okay, so Ganymede is out of frame, the upper left, on the other side. So those are the four bright moons of Jupiter. But I'm going to go ahead and bring the exposure back down. So the planet.
There's no filter. They're just changing the exposure length of the image to be able to see the clouds. So there's no filtering right now. They're just using a monochrome camera. And we've moved from Saturn to Jupiter, by the way.
Yeah. And so you can see if I flip back over to my software and tell it that I want to see Jupiter. And actually, you know what I need to do is I'm at Saturn. I'm looking at Jupiter from Saturn. This software is not like Stellarium where you're pinned to the ground. This is Starry Night made by Simulation Curriculum. It is a proper simulation engine. And in fact, I can open up multiple view screens. I can give you different angles of the same thing. What I really want to do is send the camera back to the ground here in Michigan, and now magnify on Jupiter. So it's going to swing the planetarium around, and it should zoom in, and you can see both of the planets out there, and it'll zoom in on Jupiter.
Okay, there's a question here from Brian.
Yeah.
Saying that is there a benefit for looking at planets with an IR pass filter to avoid some of the atmospheric turbulence?
So that is actually a really good question. Infrared is less affected by those turbulence than the visual wavelengths, right? The 400 to 700 nanometers. And so the lower the wavelength you go, the problem with that is many cameras designed for ordinary visual use, they are designed to mimic the response of the human eye. That way, the photo that you take with your phone looks like what your eye saw. So if you buy a special camera designed for astrophotography that does not clip the spectrum, and it's sensitive a little bit into the UV and it's sensitive a little bit into the IR, with those cameras, you could put a filter on the camera that blocks out much of the visual wavelengths, right? The 400 to 700, and lets you see the stuff that's longer than 700. And if you did that, yes, Brian is right. You would suffer less from the effects of atmospheric seeing conditions because you did that.
Yeah.
A little bit.
A little.
Yeah.
You know, I might add there though, that works great with a reflector. But if you get into a refractor we were talking about earlier, now you're going to even a decent APO is still going to have a hard time bringing IR and the visual into focus at the same spot. So you really want to do one or the other. That's where doing things at different filters and then blending them together later works.
So you can see the four Galilean moons out there. In fact, I can even turn their orbits on. I'll turn on the orbit of show the orbit. Show the orbit. Show the orbit. I'll show this orbit. So now I've sort of turned on the orbits of the four Galilean moons. If I do well, actually, yeah, I guess I could turn those up. In any case, if I zoom in a little bit here, you can see the great red spot there, right? And so now if I flip back to the actual telescope, you can see there it is, right where my cursor is. So you can see the cloud belts and you can see the great red spot. So the software does actually know how fast Jupiter spins. Oh, so Astro Trivia. Which planet in the solar system has the shortest day? So I'll let you noodle on that for a bit. I
know Jupiter's one. I'm trying to remember Saturn's one.
Saturn's
Short.
Jupiter is 10 hours. Right?
That's the fastest.
Is that your final answer?
No, I'm trying to think. I'm trying to think of the other ones.
My final answer. You are right or wrong.
Well, the longest one is probably Mercury, right?
Well, we'll get to that.
All right, I'm sorry.
Yeah, I think Jupiter is the shortest.
Yeah, I think so.
Saturn's a little longer than Jupiter.
Yeah. Uranus, it's hard to tell because it rolls around.
Yeah, there's not much. There's about an hour between Jupiter and Saturn. I think Jupiter's the shortest. It's just under 10 hours.
Waits Neptune. No waits. Venus. Venus goes retrograde.
That's my last answer.
Okay. So anybody guessing on YouTube and anybody filing answers on chat?
Nobody's put any answers in chat yet. Let's give them a small bit of time.
All right, we'll give it a small bit of time before I reveal the answer. All right. So seeing the great red spot is kind of cool. One of the other things that we like to do with the software here is I go into this feature called Advanced Find, since you can see my screen, and I'm going to ask for events, and the events that I want are planetary moon events. And I will ask for, wait a minute. Okay, yeah, planetary moon events I think I want is, I want transits and shadow transits. I'll turn off occultations and eclipses of the Jovian moons only.
At night.
And I want it to be visible during darkness for us. And let's just say between today and, let's give it a couple weeks. So I'll say 10/26. That's a month. Okay. And so I'll just click this, and now we can see there's a whole bunch of them, right? So on Sunday, is that tomorrow? No, it's day after tomorrow. At 2:11 in the morning, Io is going to transit Jupiter. I could click on that, and you'll see what happens. So there it is. I'll zoom out just a little bit so you can actually see it. And then let me just put this in motion for you, and I'll put it in fast motion so we're moving a lot faster. Great red spot, you can see Io here. And this little black spot here, that's actually the shadow of Io on the surface. These are really fun. If you have a telescope and you look up when these shadow transits are going to happen, it's fun to watch the planet go on, and then its shadow is following it, especially when you get to see the great red spot all at the same time. Those are kind of cool events to have. Let me hit the stop button here.
Especially when you get three at a time.
But you can look at how many of these there are. Now, a lot of these are going to be at awkward times. So this one is at 3 o'clock in the morning. I'd rather sleep. 2:30 in the morning. But here's one, 8:38 p.m. That's not bad. 10:27 p.m. That's good. 11:30. That's good. Right. So a lot of these are happening in the evening. Now, if you're wondering why these happen all the time, Io goes around Jupiter. I think it's like every 42 and a half hours or something like that. It's I have to remember the number, but it's pretty frequent. It's more often than 2 days. Now, Io is the closest of the big four Jovian Galilean moons, but these things actually happen quite a lot. The order of the moons is Io is the closest, and then Europa. And then Ganymede is the biggest moon, but it's actually the third farthest away. And then Callisto is the farthest one out. And so Callisto is going to do it the least often. When I search for these, sometimes I find double transits where two moons go at the same time. And just once I managed to find a triple where three moons were transiting at the same time. And that was really kind of cool to see.
Tim, do you remember about a few years ago, we were looking at a double transit event? And one moon cast its shadow over the other.
Yes. Yeah.
That was phenomenal. The moon actually disappeared. we could see the moon, and then the shadow of the other moon actually cast on the. So the moon went through. It was a double eclipse. So one moon was creating an eclipse on the planet, and the other moon eclipsed the moon that was eclipsing the planet.
Yeah,
that was cool to watch, and that's a rarity to see that.
There we go. I forgot to hit the debayer button, so now you can actually see it is colorful. That's because this is a color camera, so we were looking at it in black and white. So now you can actually see a little bit of that color in the Great Red Spot. All right, any other guesses on the shortest day? No other guesses? Nobody's entered on YouTube? Liam, are you there?
Guesses entered. Nope.
No more guesses.
I'm sorry, I was mutely challenged.
All right.
Would you please mark that on the calendar? It's very unusual.
So Jupiter wins. Jupiter is just about 10 hours, 9 hours, 56 minutes. It is the fastest spinner. Saturn not far behind, about 10 hours and 42 minutes. So the next trivia question is, how long does it take for the Earth to complete one full 360-degree rotation on its axis? And I'll let you noodle on that for a while.
24 hours.
I know the answer to that, but let's see if anybody else chimes in on that one. Will I give them a hint, Tim?
Do you want to give them a hint, or do you want me to give them a hint?
I can give them a small hint.
Okay, give them a small hint.
It's why we have a leap year.
No, it's not why we have a leap year, actually.
It's part of. But yeah, well, the orbit of the sun is as well, yeah.
Slightly different reason that
yeah.
You're saying from the point it makes a 363-degree relative to what?
Well, 360 degree. So the Earth is spinning on its axis, right? So one complete revolution is 360 degrees. So how long does it take for Earth to spin one complete rotation, 360 degrees?
Well, are you telling it to stay in the exact same spot in its orbit around the sun? Because that will affect.
No, not orbit around the sun. The planet orbiting, rotating itself.
How long does it take the planet to orbit? 360 degrees.
Rotate 360. Yeah.
Whether it's going around the sun or cut loose in space, how long does it take to go 360 degrees?
Yeah, I know the answer to that.
Yeah. Is anybody guessing on YouTube? Well, I'm hoping to get some participation here.
Nobody is
guessing on YouTube.
And how many do we have on the Zoom?
9.
9, okay. All right. I'm kind of hoping to get some people guessing.
I know.
23 hours and 56 minutes.
What was that?
23 hours and 56 minutes.
23 hours and 56 minutes. So that's
4 seconds.
All right. Are there any other guesses? All right. So it turns out 23 hours and 56 minutes is correct. Now, for double the money here is if there was money. Why? Why is it not 24 hours?
The Earth is not perfectly spherical.
So it is and I don't necessarily expect people to guess this, but I would have just been really impressed. So what happens is we always think of a day as 24 hours because if you mark from when the sun is at the midpoint in the sky to the next time the sun is at the midpoint in the sky, it's 24 hours. Now, it turns out the Earth is slightly faster in the winter and slightly slower in the summer, which is why they have that weird figure 8 thing that you see on the side of some globes called the analemma, right? So it's not exactly 24 hours, but it is close. But
24 hours relative to the sun.
Well, not every day, Gordon. Which
right.
is why they have that thing called the
right. You're right.
Called the equation of time. Yeah. So there's a part where the days are getting fractionally faster, and I don't mean less daylight and more night, or more daytime and less nighttime. I mean the actual midpoint of the sky to the midpoint of the sky. If you were measuring that, you'd find that most of the days of the year, it's not actually precisely 24 hours due to this thing called the equation of time. But the real reason for the 23 hours and 56 minutes is because there's 360 degrees in a circle, and there's 365 days in a year. And that means that the Earth moves in its orbit around the sun almost 1 degree per day. And so when you take the time for the Earth to complete one complete rotation, not relative to the sun, but pick a star in the middle of the night, right? What time does the star in the middle of the night cross the middle of the sky to when does it happen the next night that it passes the middle of the night? That would actually be the 23 hours and 56 minutes, because that star is dozens of light years away, hundreds of light years away. But our star, we're going around it. And that means that we've moved about 1 degree. And so our sun is not really where it used to be relative to what's really going on. Is our Earth is not where it used to be the next day. Our Earth has moved. And so we have to continue to spin about 4 more minutes until the same point on the Earth is now, if you had an arrow on the Earth and you're waiting for it to line up with the sun, it needs an extra 4 minutes to spin to compensate for the fact that it moved about 1 degree forward in its orbit. And that's why it's not actually 24 hours. So that's the geeky answer behind why that happens.
Why would the day be shorter and not longer if you have to add another 4 minutes?
Well, it's 23 hours and 56 minutes if you pick a star that's far away. Yeah. And so the problem is we're the direction that we're going, our planet spins west to east, and our Earth is also sort of going in the same direction around the sun. And so what happens is we've moved forward, and you could imagine, if you want to go back to the heliocentric theory, that the Earth is what sits still, the sun moved to the left. Right? So if you imagine that the Earth is sitting still, the sun now moved to the left a little bit. And that means that when the Earth completes one spin, the sun is not where it's supposed to be. We have to keep spinning a little bit farther to the left before we catch up with it. Yeah.
It's just a little short.
Yeah. So that's why.
That's cool.
Yep.
That might stir up some conversation.
I'm looking to see if we have. What time is the moon rise? I didn't ask my software what time the moon rises. I guess I can go here, pull this up.
Moon should be up pretty soon here.
Let's see, I want to go back to. Let's pick the moon.
So it rises at 9:21:11 p.m.
Which it should be up by now.
It is indeed 10 p.m. exactly. So it should.
Oh, but it is pretty low. Okay.
It should be about 40 minutes up in the sky. But like you said, very low.
So let me just step out here. That's south.
To some of it.
Okay. So I can actually see a clump of trees.
Moon is 5 degrees above the horizon. I think we're going to be hard pressed to find it yet.
From the observatory, it is in fact in a bunch of trees, and in fact, it's not even high enough to be above the wall of the dome. So we can't look at the moon yet. So we're still looking.
Go to M13.
Oh, well, I might need to change cameras for that.
Well, why don't you let me do it?
Okay.
Okay, Gordon.
Yeah. Why don't I let you do that?
Gordon,
Let me hit the stop button. And Gordon, I forgot you've got all this stuff down there.
Well, I'll tell you what I'm going to do because I was trying to get things set up this evening. So I started on M92. So why don't we bring that up, and then we can. And I've actually completed a run on M92, and then we'll swing over to M13 and start doing that one.
When you say completed a run, so we're live stacking?
Well, I did, but okay, you got host disabled participant screen sharing.
Oh, that's right. I have to make you a co-host so that you can present.
Okay.
There you go.
There's a good question there from Brian, and I actually know the answer.
Okay.
He's asking, how long is a day on the moon? So a day on the moon is 29.5 hours. Or sorry, 29.5 Earth days.
Yeah.
29.5 Earth days.
Days, yes.
1 day in the moon.
Because the moon is tidally locked to the Earth. So we always see the same face of it. We actually see a little bit more than half of it because it also has an elliptical orbit. And so...
and it wobbles.
It only seems to wobble. It's getting closer, farther, depending on where it is in its elliptical orbit. And because it's an ellipse, when it's getting closer to the Earth, it's accelerating. And when it's getting farther from the Earth, it's slowing down. But what's not speeding up and slowing down is the speed that the Earth is spinning around on its axis. And that means that it seems to viewers on the Earth that we are getting a little bit ahead of it or a little bit behind it, depending on whether it's speeding up or slowing down. And this creates the illusion that it wobbles. And they call that oblation. Libration, sorry.
Yeah, libation.
Libration, yeah.
Yeah, libration, not libation.
I'd like to have a libation.
That's right.
Okay, is my screen up there?
Yes, it is.
It's up there, yes.
Okay, since I came in late, have we talked about what Messier objects are versus
we have not, and your telescope focus is better than mine because when I look at the sky, I don't see all those words.
Because you don't have the right filtering.
Yeah, you need a word filter.
For those that maybe who aren't familiar with Messier objects, maybe a very brief history lesson. Charles Messier was an astronomer back in the 1700s that was out searching for comets. He was a comet hunter. In those days, if you found a comet and named it after the king, he may throw you some money. It's known as a grant in today's lingo. So he was out there looking for comets, and he'd run across things in the sky, and then he'd find out they really weren't comets. They didn't move night to night, and he got fooled by them a couple of them a few times. So he made up a catalog of things that looked faint and fuzzy in the sky, but that weren't comets. Well, those what turns out to be about 109 objects in the sky are probably 109, 110 of the objects that us amateur astronomers look at over and over and over again because they are probably the best, among the best in the sky.
And he called them comet imposters, and one of his contemporaries referred to them as embarrassing objects. Right. That is how little they thought of these things.
That's right. So he's famous for what he didn't want to see. So it's kind of a run. So the one I picked on first tonight is M92, Messier 92. It's a globular cluster. Here's a planetarium software showing where M92 is right now. So you can see it's west northwest, and it's about let's see, it's about 30 degrees up. So it's been going down here as the night went on. But before I came on, I started imaging it. So shrink this down here. Oh, sorry. Let me get rid of this completely. There we go. So what I did is I took 15 30-second exposures of M92 and let the software align them and stack them and did a very poor job of calibration. Unfortunately, I was rushing tonight and my flat is pathetic. And so you can see I got all kinds of dust motes are populating this image. But here's M92.
Gordon, those are new nebulae and black holes.
That's right. That you could call it that. This was, like I said, too much of a rush to try and get things done. But this junk in the background is unfortunate.
Can you increase the size of this window in the screen share so that we can get a little bit closer look of the?
See if we can come in here a little bit more.
That's very nice.
Now, I suspect that the core of this is overexposed even at, there we go. So it's a globular cluster. So this is probably among the oldest things in our solar system.
Not solar
galaxy,
system.
I should say. They're a group of stars that are tightly bound by gravity and pretty much have stayed together for several billion years at least.
Yeah, easily. The stars in the area of the galaxy where our sun lives, the density of stars is approximately 1 star for every 5 cubic light years. So 5 light years by 5 light years by 5 light years, you'd have 1 star. In a globular cluster, you'd have about 60,000 stars in that same space.
So this is M92. I picked on it because it was pretty high in the sky when I started. M92 frequently gets short shrift. Let me bring this back up here again. Let me close this down a little bit. Here's M92 and M13, which is the biggest globular cluster that we can see from the northern hemisphere. It's pretty close to it, and as a consequence, most people start going to that, and M92 gets ignored. But M92 is not too far behind in size. So why don't we swing over to M13 and we'll start doing some imaging on that. So I'm gonna go to M13. I'm gonna find it, and then I'm gonna tell the telescope to go slew to it. And we'll...
Gordon, meanwhile, I have a pop question for you. You said Charles Messier's list of not comets was about 109 or 110. How many comets did you discover?
Oh, I gotta wait a second.
How many comets did
All right, give me a second here. There we go. Here's a list of comets. Discovered 13.
Yeah, and 7 more independent co-discoveries.
Yeah, so.
And he observed a total of 44 in his life.
Right. And, for those who want to see what he looks like, there he is. His beautiful flowered hair.
Out of bed in the morning, he didn't.
Okay, so what I'm going to do here is I'm going to go take about a 10-second exposure here.
This was my first photographic option. I was like, wow.
By the way, this was the last M92 picture, so this next one coming up is, and you can just barely see it in there. I want to make sure we were reasonably centered on it.
It looks like it.
Yeah, there should be. Okay. So what I'm going to do is start taking a series of these. Make sure I'm going to put these things in the right spot. I think I already had this thing set up. Choose. Yeah, I got to make a new folder. $13. Okay. Okay, and now we're going to start taking, I'm going to take another 16 30-second exposures of this.
And there it goes. Is it running?
Yeah, you can see the bar coming across here.
Okay, gotcha. So, Gordon, you mentioned you sort of said in the Milky Way.
I should have said galaxy if I
galaxy. Now it turns out they're technically not in the part of the galaxy that most of us, if we imagine the galaxy as being this disk thing with spiral arms and a bulge in the middle, that's not where they really are. They're in this sort of halo region. So everybody else is going around the galaxy on this merry-go-round, and these things are kind of looping over the top and dipping underneath. They're not following in the disk like everything else. And that made them very useful to astronomers who had no idea how big our galaxy was or where the center was. And the problem is if you're a blueberry in a blueberry pancake and you look around, all you see is batter. And you don't know if you're in the middle of the blueberry pancake or the outer edge of the blueberry pancake. But since these things were not in the pancake, we had the ability to see many of them and track them over time and sort of try and figure out, well, if they're gravitationally bound to the galaxy, but not following around in the disk, we should be able to figure out what exactly are they orbiting. They should be orbiting the center. And indeed they are. There are quite a few of them, and they were able to figure out that the center of the galaxy seemed to be in the direction of Sagittarius. So they take telescopes and they swing it in that direction and they see nothing because it's all full of dust. So then they grab infrared telescopes and do it all over again because now you got wavelengths that are bigger than the particles of dust, so they can sort of go right on through the dust like it isn't there. And that's when they discovered a whole lot of stars swinging around the middle of the galaxy, orbiting seemingly nothing at all. That would be our black hole at the middle of the galaxy. Figured out that we are, I want to say, about 26,000 light years away from it. And the galaxy is, we used to say it was 100,000 light years across. They think it's a little bigger now, maybe 120. Home to, we used to say it was about 100 billion stars, then we revised it to about 200 billion stars, then we revised it to about 300 billion stars, and I've even heard people say it might be 400 billion stars, but it's a lot. And so we are about halfway between the center of the galaxy and the outer edge of the galaxy, roughly. And so now we know about how big our galaxy is and how far away we are from the middle.
Tim,
all thanks to these.
What's the radius of the halo? If you draw a line straight through Sagittarius, say the black hole,
yeah,
and you go from one, the northern, if you will.
So the radius would be, we used to think it was about 50,000. We used to think it was about 50,000 miles radius. Now we think it might be more like 60,000. I'm sorry, 1,000 miles. Light years, excuse me, not miles. Yeah, about 60,000 light years. I think is the later number as we learn more.
And then here's a bit of trivia that I have no idea whether it's true or not, that the age of the globular clusters in some cases exceeds the age of most of the stars inside the Milky Way galaxy itself.
That is true. Yes.
They're old.
They are very old. They're
really old.
Yeah. So the stars in M13, what we're looking at right now, are
they're pushing the edge of 14 billion.
Well, not 14 billion, but well over 12 billion years old. Okay. And not quite sure exactly how old the Milky Way is itself. And we do know that the Milky Way has probably merged with several galaxies by now and, about to merge with more.
Okay, what this software is doing as every 30-second image is saved into a directory, this software detects the new file and then starts adding it and stacking it, aligning it and stacking it to the previous one. So you can see in the window in the back some processing things going on. Here is the alignment of the image to the rest of them here. So we've got 7 in the stack right now. So
can you magnify a little?
I suppose we can. Yeah, let me make this bigger.
So these are really fun to look at through telescopes because you actually do see a lot of this stuff. On some nights when the sky quality is not great, I'll see a smear with a handful of stars. And on nights where the sky really calms down, it's just thousands and thousands of stars, and it just boggles the mind.
I think I messed up and didn't turn the color on properly, because I think we're getting a monochrome image here.
Oh.
I think I was too quick to start things there.
Oh yeah, that's you did that last time. There's the tick box to.
Yeah, I know. But I don't see the tick box now. Well, we'll do it on the next one. I can go back and redo these, maybe.
Just get your crayon. How many images is going to stack?
I told it to go take 16, and there's 9 in the stack now. So we get a couple of 30-second exposures. So they're.
And what software are you using to stack?
This is a routine within PixInsight
Okay.
called Easy Stack. And the nice thing about PixInsight, by the way, is an image processing software designed. Photoshop is out there, and lots of people use Photoshop. I do, but it's a general purpose image processing or software. PixInsight is dedicated to astrophotography. And so there's some things that it does. Photoshop will not allow you to do this kind of stacking very easily. There's some workarounds, but it's image calibration and alignment and stacking is something that is better off done in a dedicated astrophotography package.
Yeah, not hard to imagine.
I think myself and others will do some processing within PixInsight, but usually wind up in Photoshop to do the final tweaks. Photoshop gives you a lot more control over things.
The artistic part of it, Photoshop tends to be better, and the mechanical parts of getting all the data together, this is better.
By the way, this image, the telescope I'm using here is a Newtonian astrograph. It's an 800 millimeter focal length, 8-inch diameter. And that's part of the reason why, if we look at the full scale here, it's kind of lost in the middle. If you were to do this with an 8-inch SCT, it would probably take up, a good 25% of the center of this image. So the image scale would be a whole lot better with an SCT. So yes, short focal lengths do good for wide field things, but when you're starting to get at smaller clusters and the vast majority of galaxies, short focal lengths don't all you get is smudges. You really can't see the detail.
Like you can't do the ring nebula with an astrograph very well. Is that correct?
Yeah, you really want, you really want more magnification. You want bigger image scale.
I did that with Greg Knechlian in his front yard one time. We tried the ring with his 11-inch astrograph, and it just, you could see it, but it was like,
Yeah, and even if you were to choose to add a Barlow as an example, right, then you start losing some of the light, right?
It dims like twice, right? You lose 50% of your light.
Right, exactly.
Yeah, but that's really something you think about when you're doing visual. But what you do in astrophotography is you take a longer exposure.
Oh, that's true.
What's the name of the unit of that guy who you said so many, I forgot what, Janskys or whatever, equals 30 hours of light collection?
Oh, Strobels.
Oh,
Strobel?
well, yes, but now see Doug Struble, and I really invite anybody who wants
How many hours in a Strobel?
30.
That's what.
And he's now up to things approaching at 100 and better on some of his images.
Over
But
how many years?
I'm sorry?
Over how many years does he collect 100 hours of light?
Well, some of it's over, a couple of seasons, but some of the things are over, a week or so. You get 7-8 hours a day, and he's got 2 telescopes working in his backyard. So he can get, in 8 hours, he can get
Cloudy for both or not for both, I suppose.
So Gordon, in your processing, and maybe you already covered this, sorry, I had to go get my daughter, but do you do a lot of this from remote, meaning, hey, I got my scope outside, I got a computer, I got software, I'll just sit here and let it do its thing and help it out a little and then do my processing and not leave the house kind of thing? Is that?
That's my fervent prayer.
So Gordon takes it a step further. Gordon kicks off an imaging run, goes to that sofa right behind him and takes a nap.
Actually, I go to the bedroom next door. It's more comfortable.
Oh my God.
So, and then so once it starts and looks good, he'll go take a nap, get up a couple of hours, like set an alarm, get up, come out, checking it. And when it's ready, he'll start, and it looks like it's done and it's good. He'll start off another run for another target, hit go, and then go back and nap again.
Wow.
There it is. Wait a second. Was that that? No, that was the previous one. Okay, that's this one. This thing isn't part of the problem with this software is sometimes it gets flirky, and I think it just froze on us. So I'm gonna kill it. Yeah.
So let me ask you guys a question since you're into this. So one of the things I've been learning again about astrophotography is you've got some options, obviously, but let me go over through two high point options. One is, depending on your equipment, you can do the same object, but you would do in one set of equipment, shorter exposures, more of them. And on the other equipment, you can do longer exposures and less of them. And you can kind of come up with similar results, yes or no?
Yes. And you'll get into an endless discussion on and what's better. What's the proper way to do things? Do I take a whole slew of 1-minute exposures, or do I take a whole slew of 10-minute exposures? And it becomes almost a preference of the imager on what you're going to go for.
So in my case, Gordon, with my Schmidt Cassegrain, which is a 10-inch, it's alt as, right? So I do have a wedge, but I'm probably not going to go there for a while. Then I would do short exposures, right? And do more of them and stack them. That's my option, right?
Okay, if you're on an alt as and you're going to do deep sky, you're going to get yourself into a world of frustration very quickly if you're not on a wedge, because you can take your fork mounted SCT and it will track, but as it's tracking, the image is rotating.
Yeah, you're limited to about 20 to 30, 20, 25 seconds at maximum of exposure before you get rotation in the image and before you get trailing.
But every image you take is going to be slightly different rotated. And in some software packages, Pix Insight will derotate the image.
Yeah.
But some of the ones out there that are a lot less expensive will only align, height and width. They will, X and Y, they will not do a rotation, and you'll not get a good stack.
See, and this is again back to my presentation about there's a beauty about refractors where they're so portable. And I mean, yeah, of course, you could take and defork the SCT, and you could buy an SCT and put it on an equatorial, but you still got this big old thing. So again, it's like if you're interested, and this is where I keep going back to. Yeah, you've got a Newtonian, you're using an astrograph, right? Those are probably somewhat portable and they're lighter. But again, you get a nice refractor. The only thing missing for me on the refractor side right now is, can I see what I want to see visually and be pleased with it? Because I know it'll meet my needs as far as astrophotography. That's the only piece that's missing right now for me.
Well, whether you've got an SCT or a refractor, if you're going to do deep sky stuff, you need to be on a wedge or you need to be on a gem.
Understood.
So there's a question here actually that's right on this topic. And Brian says, I always wonder if my exposure times are too long. I typically do 4 to 5 minute exposures for DSOs and just take hours worth of them. But like I would say it depends on the object and it depends if you're blowing out the stars or not. If you're getting pixel bloom on the stars, you're overexposing, right? So you're trying to overexpose each of the pixels. If your pixels are pinpoint, then you're doing well. What do you think of that?
I was being asked a local question. What was the question?
The person was asking, Brian was asking if he often wonders if he's overexposing his images.
Yeah.
He often does 4 to 5 minute exposures for DSOs.
Yeah. Okay.
He does a whole pile of them.
Yeah.
And my response was, as long as you're not getting pixel bloom and you're not overexposing the stars and causing them to blow out, you're doing okay. If you get pixel bloom, you're overexposing them, and you need to shorten your exposures.
So I'll let Gordon make a comment, and then I'll make a comment, and Gordon may be about to make the same comment I'm about to make.
Okay, it's almost impossible if you're at 5 minutes, you're going to overexpose almost any bright star in the image. What I typically do when I'm doing deep sky is I will take a series of 10-second, 30-second, 60-second exposures. Not many, maybe 10 of each.
You can turn on the light if you need to.
And I take those for star colors. And then I go out and my go-to exposure length is 8 minutes at ISO 800 with the DSLR. And I will take 5 to 6 hours worth of exposures, at least. I live in a very light polluted area. I'm in Woodhaven, downriver here. And the skies are terrible. And the only way you can clear through to get any hope of getting at the fainter stuff is to take hours of exposure so you can beat down the noise caused by the sky glow. But I will then take those images that I've taken the long exposures and use them for the faint stuff. And then I'll use the shorter exposures to keep star color and then blend that in later. And that's the artistic part. This is not science anymore. This is pretty pictures.
So basically you're using PixInsight to take at the start out of the image and leave your DSOs behind. And then take the short exposure and merge them.
There's you can just do things like there's some ways that you can add them in without stripping them out in the first place. Now you're getting into some other techniques that work great with relatively short focal length, but don't work very well with long focal lengths. But you can get the stars in later on, and to get star color without it just takes work. I probably spend a typical images. I typically spend 4 to 5 to 6 hours processing.
That's a lot of data.
Yeah,
the actual data processing is relatively quick, depending on how speedy your computer is. But to now start nursing out and pulling out the stuff out of the background becomes
so you're saying you spend a lot of time post processing, which is probably not uncommon, right?
Yes, if you want the stuff that's in magazines, these people you're spending hours and hours doing the process. Now, the darker your skies, the easier it becomes. But when you're in the muck like I am here, now you got to work.
So what I was going to say is, if you think of your stars, if you're shooting with a color camera, you've got a red, green, and blue channel, and let's just suppose you're shooting JPEG. Now you'd never shoot JPEG. I shoot JPEG only for frame and focus, and then I switch over to RAW. But JPEG is 0 to 255 per channel. So 256 possible brightnesses for something. And you don't want any of the red or the green or the blue channel to be at that 255 number. You know, you want to kind of keep it down around 250 or something like that, because if one of those channels hits 255, that channel stops collecting data because you just saturated it. But the other channels that were not yet saturated, they continue to collect more photons because they haven't hit their max yet. They haven't hit the ceiling. And so now the stars lose their color, because if you have equal amounts of red and green and blue, it's all just white. So you just lost your color in the image by doing that. Now, in reality, you're probably shooting RAW, and with an astrophotography camera, you're probably either a 12-bit or maybe a 14-bit camera. So a 14-bit camera is roughly 16,000, 535, I think, 0 to 16,535. PixInsight, I think Gordon says it normalizes everything from 0 to 1.
Yes.
Yeah. So
and it assumes that the image coming in is a 16-bit image.
okay.
And for instance, here's a test shot I just took of M31. I figured we'd go for the galaxy now. We've done some globulus. So here's a 10-second exposure of M31. Now the ISO is cranked up here. I got the ISO up at 3200, so we can do things relatively faster tonight. You know, and here's the histogram. So this is only a 30-second exposure. And by the way, you can see, I don't know if you can read these numbers here. This is, I've got the upper slider set at 14,400. My Canon 6D, yeah, 14 bits is 16,000 and change, but the reality is you don't get it all because there's overhead that needs to be taken care of in the electronics. And so my pixel saturated about 14,000 and change. So you can see, here's this white line here, is that saturation. So even on a 30-second exposure, these stars are saturated. So
is this all PixInsight we're seeing on your screen? The maps?
What's on the screen right now is I use the Sky camera module to run my camera. Okay, so this is the software within the Sky that actually took the picture, and I'm just using a screen stretch here so I can see what's going on in the image. If I take the stretch off, then you get this.
Okay.
Okay, and part of the problem is this software too is expecting a 16-bit CCD camera. So it's out here at 65,536, okay, which is, DSLRs don't get there. You don't get anything more than the 14 to 16,000, depending on the camera.
Right.
So now I've just brought it down so I can see the full range of the.
And I'm sorry, what was your control software behind this with the maps and everything?
I'm using the camera add-in to the Sky X Professional.
Oh, Sky X.
If you've been around for a while and have heard of CCD Soft, that used to be, at one time Software Bisque and SBIG, that was one of the first CCD manufacturers of astro cameras. They were pretty well tightly tied at the hip. And so the Sky software was kind of developed around SBIG cameras. But they've expanded it now on DSLRs, and every camera on the market could be used within this software. There's other things you can use for image acquisition. If you got a Canon, you can use Backyard EOS.
Yeah,
is probably a favorite, and I use that a lot too when I'm not inside the Sky.
Okay. So like one of the things, like when I don't know what you guys call it, but when there's no lens and I just mounted the DSLR to the 10-inch to normally where your eyepiece would go, I just plopped the DSLR in there with a T adapter, brought it to focus and said, okay, start recording a video for the planets anyway. one of the things I noticed, and there's not really a digital zoom on the camera, right? So you're only going to see the planet. It's kind of small, right? Even on the 10-inch. And so at least some of the research guys were like, well, you throw a Barlow in front of it, but then you lose some light. And so then I'm thinking, okay.
If it's a planet, it has a lot of light.
Yeah, you don't need to worry about light loss with a planet. There's too much of it.
So is that common? That's my question. Is it common for non-refractors, I guess I'd call it, or maybe even refractors, to throw a Barlow in front of a DSLR? Is that not?
If you want to get good images of Pluto and Saturn, you need to be up around 6,000 millimeter focal length. Okay. That's the only way you're going to get image scale big enough to really start bringing out the details and look at the magazine type thing photos. So you need to take an SCT with a focal length around 2000 and put a 5x power mate onto it to get up where you need to be to really start.
There's something called Shannon-Nyquist sampling theorem that says that the thing sampling your data should have double the resolution of the data that you are trying to capture. And so you're like, okay, well, cameras have resolution in pixels, but telescopes don't have resolution in pixels. Well, they kind of do. A telescope, depending on its aperture, there's something called Dawes limit, which is what is the minimum separation that the telescope can distinctly tell that something is two objects instead of one merged object. And that has to do with the wave nature of light and the aperture of the instrument. And so there's a relatively simple math formula that figures out what that is in arc seconds. So now that you know what the smallest number of arc seconds is that your telescope can resolve, and you know how many arc seconds it is across the field of view that the camera sensor is capturing, you want to make sure that the sensor has double the number of pixels is the number of arc seconds that you can capture in that amount of space. And so that's how I said, so it's an analog concept. It's not really pixels that the telescope has, but there is kind of a way to get down to it. And so that's what these guys are doing. They're doing the math, and then they're figuring out how much do I need to Barlow up my telescope so that I am capturing, at least 2 pixels worth of, 2 pixels width for every one, unit of what the telescope is finest ability to resolve. And that's what they're going for. And then the other thing is seeing conditions are not your friend. So if something is wobbling around and your shutter is open for, let's say, a whole second, it wobbles around a lot in a whole second. So if you get that down to, say, 1,000th of a second, it doesn't wobble around as much. So you're trying to get your frame rate as fast as you possibly can so that you can grab that. That's why they, for deep sky objects, open the shutter and leave it there for minutes. But for planets, you want really, really fast frames to try and capture as much data as you can. And so my camera that I use for planetary imaging, so the camera that's in the telescope right now that I'm not showing my screen, that has a typical rolling shutter. So a rolling shutter means I am reading out the pixels one row at a time. But I have another camera that has a global shutter, which means it captures and reads out all rows simultaneously. And so that camera can capture at its full resolution, something like 168 frames a second. And and that's at full bit rate, full resolution. If I drop the bit rate or drop what we call region of interest, so I'm not capturing the full shutter, I can go to hundreds of frames a second. And so that allows me to hopefully do this, what we call lucky imaging, get the occasional really sharp frame in the seeing, and the planet doesn't get to wobble around so much in that amount of time.
Gordon, that's outstanding right there.
That's
Yeah,
only
so
the
this is
beginning.
this is only 90 seconds worth of exposures.
That's incredible.
Yep, Andromeda.
Hey, it looks like that thing on the wall behind you, Liam.
Kinda, it does.
Actually, I'm taking a picture of Liam's screen and then
zooming in.
That image on the wall behind me is actually Tim Campbell's photograph.
Oh, I see. So that's your buddy now, huh? You got pictures going. Okay, I see how it is.
I'll see if I can show you the, I have it on the laptop. I'll see if I can show it to you real quick. There's a little bit of a trick that I did here to get this image.
You want me to get off the screen and you can take it?
Oh, just for a half a second, and then I'll show you the, where did it go? That's not it. I think I got to go to my pictures folder. There we go. Okay, so now if I do a screen share, back to Zoom, share my screen. By the way, I turned off my video because it's so dark in the observatory, you wouldn't see me anyway.
No, that's fine.
Share screen. And here it is. But
whoa, look at that, man.
Now you'll notice that Gordon doesn't have that color in there.
Yeah, how'd you get all that vibrant color like
All right, so here's the trick.
Crayon.
Exactly. So the trick is there's a little trick in PixInsight where you separate the luminance channel from the data. So the luminance channel is just, never mind what color it is, I just want to know how bright it is. And then you recombine it back in with saturation such that color is going to saturate, but it's going to saturate each pixel based on how bright the pixel was. So the brighter stuff will get more saturation, and the dark stuff, the blackness of the sky, won't saturate at all. It's no saturation because it has no brightness. And so if you really, if I took before I did this, so this is the artsy fartsy part of the image processing. If you really were to take your mouse and hover it over the pixels, and I mean before you do the saturation gain, if you moused over it, you would notice that out here, the blue values were ever so slightly higher. And in here, the red values were ever so slightly higher, but it would be a really small difference. But because of the way I separate and then recombine it with saturation, it really exaggerates the difference between the part of the galaxy that's fractionally more blue stars versus the part of the galaxy that's more yellow stars. And so you get this effect.
How did you get the two objects there with the fuzziness around them? One at about
they're galaxies, they're companion galaxies of Andromeda.
And so they just naturally will pop like that?
Yeah.
And what about at the top there about 10 o'clock, that orange?
That's a red giant star out there.
That's crazy how you can see all that like that.
That star is in our galaxy, not the other galaxy. All these stars that you see, those are all in our galaxy, not in the Andromeda galaxy. So all of this is, stuff that's between our planet and the outside of our galaxy, and then you've got all this mostly empty space until you get to the other galaxy.
So how long did it take you to take this photo, and like what did you use?
So I was at the Great Lakes Stargaze several years ago. I set up my mount. I manually did a precise polar alignment using one of those little borescopes that goes through, and you line up where Cassiopeia is and the Big Dipper, and then there's a fairly decent one for Law's Mandiscopes that you can get. And I got it dialed in, and I wasn't sure if it was good. So I said, let's just take an 8-minute exposure. And I didn't really want 8-minute exposures, but I said, if I can do an 8-minute exposure, framing and checking the focus to see how it comes out, and then I'll just kind of know how good I am. I had already put the guide scope on, and I put the guide camera in the guide scope. And I was ready to do this. By the way, this is not taken with a great big SET. This is just taken with a refractor and about 500 millimeter focal length telescope, roughly. And I do this image, and the first image comes out basically like, well, not color, it was monochrome, but the stars were as sharp as what you see here. And Gordon is next to me. And Gordon looks at we zoom in on the data to make sure that the stars really are, point sources and not going sideways on me. And remember, I'm not using the guider. And Gordon says, do not turn on the guider. You will only screw things up. So this was about I want to say these were mostly 5-minute exposures for about an hour.
Wow.
Unguided image. So
That's fantastic.
yeah, I felt like I got lucky with that. So and now that's only an hour. And it was I reprocessed that and reprocessed that and reprocessed that many times because I would make a mistake early in the processing steps that I'm going through, but didn't know about it until I got to a much later step, 30 minutes later. And I hated how it turned out. It turns out what I really screwed up was a mistake that I had made 20 minutes. So I had to throw it all out and do it over again. So I reprocessed that many times before I was happy with it. And honestly, people look at it and go, yeah, that looks good. I still see mistakes in that image every time I look at it and go, yeah, I should really reprocess that one more time when I have time on a weekend.
An important step that we haven't talked about tonight, image calibration is typically applying a bias and darks subtraction, and then a flat, which is to get rid of vignetting and dust donuts and things in it. But the next important thing is color calibration. The color coming out of your camera is wrong. There's no other way to say it.
So I've heard of everything you said, except I've never heard or read anything about color calibration.
It's another, I don't want to call it an art form. There's lots of ways to do it. 10 years ago, we were doing it, but strictly by eye. You would take an image and you'd start taking the color sliders in Photoshop and start sliding the blue, green, and red things around until you got an image that looked right. Okay, so it was purely a judgmental thing. PixInsight has got some software for color calibration that, let me go back to, let me share this thing again.
Yeah, since you're doing that, one of the things I know, like in Registax, you tell it to do, or is it the other one? You tell it to do like that RGB align. And the thing is, it's weird sometimes, is to me, it like feels like it took a bunch of color away. But anyway.
Well, what that's trying to do is take the separate RG, red, green, and blue channels and align them so they're properly aligned. Because you can get some color separation, especially on planets and things. You red, green, and blue get separated from diffraction effects, especially if you're close to the horizon. If you're not directly overhead, and unfortunately, most time the planets are only 25, 30 degrees up. So you're getting into some separation effects due to the atmosphere here on Earth.
Yeah, they call that atmospheric dispersion. It's really bad in summer. For outer planets. So if you think about the axial tilt of the Earth, right? If during our summer, our north polar axis is tilted toward the sun, what that means it's tilted away from the outer part of the solar system. So when Jupiter and Saturn are in the direction opposite the sun, so we can see them at night, our northern polar axis is pointed toward the sun instead of toward them. That causes all those planets to be very low in the sky. Now, wait for Jupiter, which takes roughly 12 years to go around the sun, Saturn, roughly about 30 years to go around the sun. So wait for Jupiter and Saturn to get to the other side of the sun. Now, our northern polar axis is tilted toward those planets and away from the sun. And that means that Jupiter and Saturn are really high in the sky. That's a great time to image them. Unfortunately, that only happens in the middle of winter and you will freeze your butt off, but they will be very high in the sky.
But wait a minute, from what you guys are showing me, you could just set up a wire and run it outside and sit in the heat in the house and watch TV while it's imaging.
Amen.
Nirvana.
That's George Carody's got his whole garage redone.
Oh yeah.
He's got an observatory too. So he's
I think Liam, you were telling me, wasn't it, that we got, there's people sometimes that they don't even use eyepieces anymore, right?
So eyepieces are just a collimate.
They just like, where's my camera and where's my wire? Yeah.
Yeah. I said the eyepiece is just for collimation. And once you're done collimating, take the eyepiece out of it. You don't need it anymore.
I don't use an eyepiece for collimating.
I was gonna say the hardcore imagers don't use eyepieces. even.
Oh, see, this is
Yeah.
getting deep, man.
Yeah.
Okay, now
I-
let me finish up on the color calibration. When the tools in Pix Insight on a thing like this is finally done. Pix Insight in the color calibration tool will go in here. You know what plate solving is?
Yes, I do. It's where it takes a picture of the sky and can kind of tell you by that picture where you're at and in what location, right?
It essentially puts it now finds the right ascension and declination of the center of the image and the four corners. So it knows every time it finds its star, it looks at the pixel, it can generate and then convert that into the right ascension and dec coordinates of every star in the image. And then what this software does, it goes into the Gaia database and finds all the stars that are in there and finds out what the color characteristics of every star in the image is, compares it to your image, and then comes up with an adjustment to bring your
Wow, that's incredible.
You take every star in the image that isn't saturated and find the best fit and that's how you get the color calibration done.
Okay, so Pix Insight is worth its weight, sounds like, in the money. Yeah.
In gold. Yeah.
But there is no instruction manual.
Yeah, there is. I'm looking at him right now.
It's no. The instruction manual you find online for Pix Insight covers about 5% of what it can do.
Yeah, no, that's why I said I'm looking at the instruction manual right now on my screen. Yeah.
One page. Or you're watching Gordon's video. Gordon,
Yeah, that's what I'm talking about.
What you do is you buy something like this. This is Warren Keller, and you buy his Inside Pix Insight, and this is a good place to get started. And I'm being a shill for him now. But you join IP4AP, his website, and then there's all kinds of tutorials and things and video things.
So do you keep learning new things, Gordon? Because that's what's important, right?
I know 10% of Pix Insight.
It's crazy, man.
It is impressive. Well, it is expensive to buy it. Well, it's not like Photoshop expensive, but it is several $100s.
Yeah, but it's a one-time payment though.
Having said that, yeah, their policy is once you pay for it once in your life, and all the updates are free forever.
So let me ask you that: can you can image with it though, right? Capturing things, and processing, or just processing?
Just processing.
Well, okay, you probably wouldn't, but technically, yes, you can actually image with it if you are on a Linux or Mac. That is because Gordon uses the ASCOM platform on Windows, and I use the Indy platform on Mac. And it turns out Pix Insight supports Indigo, which can take direct control of your camera from within the software. So I can actually go into Pix Insight and tell it to actually control the camera, acquire the data, and pull it straight into the software. I wouldn't do that because there are other software that's better at creating the schedule of all the data that you want to capture.
Okay.
But normally what you do is let somebody else capture it, and then you let Pix Insight muscle its way through.
Okay. So yeah, so this is a post-processing application,
right?
And obviously very powerful. It sounds like a pretty good learning curve.
Just one more. This is the final image. This is all 16 images, so it's not going to get any better than this. But we talked about these two other M32.
Yeah.
There's actually here you get 3 of your Messier objects in one shot here. But this 800 millimeters is with my full frame 6D is about the right image scale to get on a diagonal to get M31 in. But if you're trying to go after, most galaxies are like this or smaller, and so you need focal length. You can't chase down these small galaxies and expect to do it with an 800 millimeter focal length. It's just not.
But can you Barlow up on those or no? Not really.
Well, yeah, you can. There's all kinds of ways to get up there. There's eyepiece projection, and there's and you can put Barlows in.
But the,
Things start to get fussy and more difficult to get things done. It's,
the resolving power of your telescope is whatever it is. And
Gotcha.
so when you Barlow, it's like, if I said, let's Barlow, that would be like saying, hey, Gordon, let's just take that digital image and make it twice as big. It doesn't really get sharper. It just gets
I
twice
got
as big, which means that, when you really start to zoom in on it, you see where the focus isn't, quite where you want. And so that's what happens. The resolving power of the scope is the resolving power of the scope. Barlowing only magnifies what your eyeball sees.
So Tim,
scope sharper.
Tim's and Gordon, so what do you do if, like, since you have the refractor, it does great on a lot of things, you guys are enjoying those, right? Or the astrograph. So what do you do when you say to yourself, do you digital zoom? Like, how do you say, I want to bring this in closer so I can look at the detail?
So if I'm just doing visual, remember you mentioned how many eyepieces do you need, right? I own a lot of eyepieces. I mostly use 2. And so now it turns out I kind of use 4, but let me tell you how that works. So I have this 41 millimeter Teleview Panoptic, and that's the first eyepiece I put in my telescope because it has the widest field of view, lets me get things centered, looks great. Then I go, okay, I want to see it closer. So the question is how good is the sky quality that night? So there is this general rule that says that you can go to 5 times the, I'm sorry, is it 5 times or no, it's 2 times the aperture of the telescope when measured in millimeters, or 50 times when measured in inches. So if you've got, oh, hey, Greg. So if you've got a, let's say,
2,500, yeah.
Yeah, let's say you have a 4-inch telescope. So that's 100 millimeters, right? So that's 200x magnification. That's the maximum that I can do. So the magnification is focal length of the scope divided by focal length of the eyepiece. Simple enough, right? The problem is that's what you get when you're in the most ideal sky conditions ever anywhere on the planet, like you're in the middle of the Atacama Desert. You ain't there, you're in Michigan. And so the best that we tend to get is if you can get to 1x the focal length of the telescope in millimeters. So that means, so now I'm going to go to 100x magnification or something like that. So it turns out, if you figure out what it would take to get there, it turns out it's the focal ratio of the telescope. So if you've got an SET, that's f10.
F10, yeah.
You probably should not use an eyepiece smaller, shorter than a 10 millimeter, because that will always get you to that 1x number that I talked about. If the focal length of the eyepiece matches the focal ratio of the telescope, that's about as far as you want to push it, unless you won the sky quality lottery, which maybe happens twice a year, and then you can go shorter. So hypothetically, you could use a 5 millimeter eyepiece on an f10 telescope, but you probably won't like it on 98% of the nights.
Now, then what is the focal reducer when you can add that, right? Does that change that math at all?
Yes. So now you're reducing the you're kind of reducing the magnification by doing that, because you're changing the focal ratio of the telescope by putting that in.
Yeah. Now mine would convert to a 6.3, I think it is.
6.3, yeah.
So the idea is, so here's where I said, so if I have a f10 FCT, I can use a 10 millimeter. I don't own a 10 millimeter, but I do own a 13. But let's say I looked at, M13, and I put in my 13 millimeter eyepiece to look at M13, and it's really just mostly fuzzy with a couple of stars. That means the seeing quality is bad, sky quality is bad. So depending on how bad it is, I might back off to my 17 millimeter. If it's worse,
I got
my 21 millimeter. Now, if
Okay.
if it's worse than that, I pack everything up and go home.
Gotcha.
That means the sky is horrendous.
All right, so I'm with you all the way. All right, so now that we've covered the eyepieces, like how does it work with the cameras? Like how is it different? How do you know when you grab your camera and you plug it in? How do you guys judge? Like, I don't understand how some of these cameras work, right? So do they digitally zoom? Like, how do they take something and bring it in? Like, how does that all work?
So I don't digitally zoom. I own a handful of cameras. So I own a Canon 60DA, which is basically a APS-C size sensor DSLR, except that it's a camera that Canon is slightly more sensitive to the reds than the human eye naturally would be. So that's one. But you could just get a basic DSLR that isn't astro-modified, or a basic DSLR that wasn't meant to be astro-modified and have it astro-modified. That's an easy thing to do. It does not need to be the newest, slickest, highest resolution camera. It could actually be a camera that's many years old to do it. And in fact, there's some advantages for why that might be a good idea. I have a different camera that I use for solar imaging and lunar imaging. I have another different camera that I use for planetary imaging. And then I have a fourth camera, but that's really my guide camera. So I don't really image with that. And so those are the four cameras that I use. So the camera that is best for the deep sky objects is not the same camera as the one that is best for planetary objects.
Let me try and get at it this way. When you're imaging, you really now got to start talking about image scale and how much of the sky am I getting onto the chip, or how into my picture itself. Okay.
Okay.
Here's, you can see this list here. This is the camera telescope combinations that I've got programmed into the Sky software, so I can start composing where things are going to be. The one with the check is what we're doing tonight. It's a 8-inch Newtonian, like I said, 800 millimeter focal length, and I've got a Canon 6D, which is a full frame camera on it. That's going to give me an image scale of 2.29 arc seconds per pixel. Okay. And it's going to give me a full frame of 29 minutes by 19 minute arc minutes.
So therefore, you get an idea of coverage by
Oh,
that.
I'm looking at the wrong row. It's 151 by 101.
Yeah, but you get an idea then of coverage, right?
Now, the Andromeda Galaxy is about 189 or something like that arc second or arc minutes in width from. Now, you notice I put that image. I put it on the diagonal because this is the length and width. So by putting it on a diagonal, I squeeze out a little bit more space.
Oh, I gotcha.
Okay, so now if I'm going to try and do something that's now my other telescope that I tend to do is a 10-inch. It's a Ritchie, but for the sake of argument, it's a Smith. You know, it's a Cassegrain type telescope, and it's got a focal length of 2,000 millimeters. So if I take that 10-inch with the same Canon 6D, you can see my image scale goes down to about 0.66 arc seconds per pixel, and my field of view now is only 61 by 40 arc minutes.
Yeah.
So I can't get a Andromeda Galaxy onto that frame.
Not without a mosaic.
Not without doing a mosaic.
Right, but I think I know where you're going. So depending on the object you want to do, though, you have different setups that can give you more of the result you're looking for.
Now, if here you now go down to the bottom, and here's a 200 millimeter telephoto, right, with the same camera, and I'm getting up now. My pixel scale is 6.73 arc seconds per pixel, but I'm now seeing 614 by 410 arc minutes. I'm seeing a heck of a lot more of the sky, but my resolution is gotten pretty coarse.
Yeah,
Gordon, can you go to astronomy tools on the website? Can you Google that? and go through that for imaging?
I'm not sure what astronomy tools, what,
Um, Google astronomy tools.
Astronomy.tools is the name of the site.
not tools?
Astronomy.tools.
Okay,
Oh, field of view calculator.
Yes. Now go to the imaging mode in the middle there.
okay.
And now, does
Yeah, I
that bring in what you were talking about?
I see, John. I think this is similar to Gordy, what you're doing on that sheet or that
Yeah.
program. Yeah.
I know it.
Type it. You can do a type and search in there.
Okay, here, okay, well, here's my Astrotech AT right here. And the camera is a Canon 6D. I gotta have it here.
Yeah, they got it in there.
There's a 6D.
And that's already got your focal length?
Yeah, it's already 800 focal.
Yep.
For 200 millimeters.
So that gives you your pixel size.
Yeah.
So what does that add to view? Yeah, what's that do?
That should tell you what it should look like in your
There you go.
image.
Oh, look at that.
Yeah, but see what, so you can use, you know, there's lots of tools out there. What I do is I've already got this thing selected, right? Let me close this thing down. Get rid of the picture here. I've already moved to another target, but let me blow this thing up. You see the purple square?
Yeah.
That's the field of view of the camera.
Oh, I gotcha.
And so I can either
So-
straighten it out a little bit. So that is what the image I just took is going to be defined by that. Whoop, let me bring it down.
Yeah.
I already changed where.
In that other one that Gordon was just at, that astronomy, Astro Tools, that has it where you could put the Barlow in there and then it would show you what it would look like with a Barlow.
Okay, so here I took a test image of what's going to be on it here. So I was going to do this next as an image just to get an open cluster in here. When do I start that? Let me. Then if somebody's got some things they'd like me to go after, we can do that. I don't know.
We still have 9 people watching on YouTube right now.
What about like the dumbbell?
Let me get this one. That may be let's see what the dumbbell I think is going to be pretty small for this.
I was like looking on the emails. I'm like, I wonder if.
Yeah, you know what I'm going to do? Let's do it on this one so I don't screw the.
I'm like, oh, the twist right now.
Yeah, so I did the dumbbell on the C14, which is about a 3,900 millimeter focal length. And that does actually kind of fill the frame.
Did I spell it wrong? I can't.
On the C14, Tom?
Yeah, on the C14. I give me a second and I'll show you what the photo was.
Number on a dumbbell, anybody know?
27, I think.
27.
That's from memory.
Where is it? It's at 59 degrees. Oh, why is this thing finding me?
Let's see if I can get this to. Where's my?
Apparently, the school employees left just a little while ago with lunches. Observatory for tonight. I realized it was cold.
So if I go into the, while you're hunting that down, can I share my screen for a second, Gordon?
Yeah, let me,
So I'll
I
just
don't know why this thing here is,
screen share, where to go? Share screen. I'll just show the whole desktop. That'll be easy. Where to go? Switch. There. So this is the dumbbell shot in the C14.
Whoa.
And this is a Canon, APS-C size sensor camera. This is by far, this is just a kind of okay dumbbell. I've seen way, way, way better than this. And there are people like, there's a whole lot more data way out here in the part of the sky that's just black that I didn't capture nearly enough data to get those parts of it. But this was actually shot in the light polluted skies here in Lincoln Park. So it was amazing that I got this out of it.
So was this with the old Meade 14?
No, this is with the telescope inside the observatory here at the school.
Oh, that's why you said C14. Okay.
Celestron C14, it's an F11 scope. It's like 3,900 and change focal length. Oh, 3911. Greg Connect Lens here. He says it's 3911. So that's what we got. Tim Dillon.
And I'm sorry, what camera did you say?
It's a Canon 60DA, which is identical to a Canon 60D, except Canon replaces the filter on the camera with one that's more sensitive to reds.
Oh, I gotcha.
It's not as good as a properly astro-modified camera, but it's a lot better than just a.
And so there was no lens, no Barlow, just raw camera?
Yeah. Yep, this is just shooting the sky. In fact, actually, let me see if I can, do I have it in here?
I think you want to get the formula.
Yeah, here it is. Okay, see this?
Yep.
Yes.
Okay, that is what comes out of the camera in the light polluted skies. And then I used a light pollution filter to try and knock some of that back, and then used image processing to go to the rest of the way. But this is what the telescope actually sees thanks to the urban light pollution. And I was able to get that out of it.
Yeah, that's amazing. You can process out a lot of that.
Yeah.
okay.
This is what Gordon has to deal with.
Well, Lincoln Park here, we're only, as a crow flies, I don't know, 8 or 9 miles, and it's actually Lincoln Park probably worse by a little bit. But the dumbbell is only 7 arc minutes on the side. It's pretty darn small, and my rig that I'm shooting tonight, let me.
It's funny that you're bringing that up because, I remember, I don't know where it comes from. It could be from the history of when astronomy started, but what's this whole thing about aperture? I mean, it's like, I get it, right? So some of these things we're talking about, it's like, how much aperture do you have to draw it in? But then it's interesting because it's not always the case, it seems like, because you can take a smaller aperture size refractor, at least compared to a aperture of an SCT, and get some pretty darn good photos.
But it depends on what you're shooting and what the angle is. The Andromeda Galaxy is 6 times, like you could stack 6 full moons side by side across that disk. So it's a big structure. When you're trying to shoot something that's really tiny, then now you want more aperture. What more aperture gives you is the ability to resolve finer and finer and finer details. So Jesse, quick story. The first telescope I had was a Meade ETX 90. It's about a 3.5 inch scope, 90 millimeters. I could see Jupiter, and I could tell that Jupiter had cloud belts. And I could see Saturn, and I could see that Saturn had rings. Then I jumped up to the Meade ETX 125. So this is a 5 inch scope. So I went from a 3.5 to a 5 inch scope. That's a noticeable jump in terms of the aperture. And all of a sudden I noticed that on Jupiter, not only could I see that there were cloud belts, I could actually just barely make out the fact that the cloud belts were little swirls of detail in it. Couldn't see them very well, but I could see hints of it. And in Saturn, I could barely see hints of the Cassini division in the rings. Now, on this big 14-inch SCT, you see all the swirls in the cloud belts, and easily, unless it's a poor seeing night, you easily pull out the Cassini division in the rings. That's because it's able to resolve finer and finer details in terms of the number of actual arc seconds on the sky.
Understood.
But if I wanted to image the Andromeda Galaxy with that big C14 at a 3,900 millimeter focal length, I'd be taking frames for a week, because it's like I'd have to take a mosaic with, it'd be like shooting a chessboard, just image after image after image after image that would all have to be pieced together to do it.
And people do that because if you really want the detail down and fine and you want to blow it up, that's what you got to do. Because with the smaller telescope like we did here, the detail isn't there.
Yeah, so it's interesting. This whole hobby is, it's just, you guys, you've been in it long enough, it's just second nature. But for somebody like me that's hearing all this, your brain starts to get foggy. It's like when you think you understand something, then you realize, no, you got part of it.
What I was going to say, Jesse, when you think of Barlowing or digital zoom,
yeah,
what you got to remember is that, like your camera, it might be like a 20 megapixel.
That's right. Yeah.
And so if you digital zoom or if you use a Barlow, then you're really not getting well, the digital zoom for sure. You're not getting the full 20 megapixel. You're cropping the image, so now you're putting less pixels on the same size. So if you go to the same size frame of the shot, say it's 16 by 9, you're going to get less pixels in that 16 by 9 area than the 20 megapixel. You might only get 10 megapixels. So it's not going to be as sharp.
Gordon, there was a suggestion of the North American Nebula.
All right, let's go.
There you go.
Is
yeah,
that up
John,
yet?
I hear you.
Let me, I started one here because I think we talked about globulars, and we're doing an open cluster now. And we can see this. Maybe blow this up a little bit. This is a favorite, especially among the youngins.
I'll try it. Let me mute this before I do it. It was.
Can we see this here?
Yeah.
Oh yeah.
This is called the owl cluster. You can see his two eyes, and here's his body, and some wings coming out here and wings coming out over here. This is in Cassiopeia. It's also known as the ET Nebula because it looks like ET.
Oh yeah.
Or the number 5.
He's looking at you.
It's a bit like number 5 as well from Short Circuit, the movie.
Yeah. Okay. Yeah.
Oh, disassemble.
Yeah. Mama was a snowblower. Remember that one?
Hey, I'm old.
Like
I remember the Gremlins and all. Yeah, I'm back. I can go back.
So that's but that's what it looks like. But yeah, the ET Nebula is also, or the ET cluster is also what it's called. But yeah, I've heard it being called number 5.
Connie number 5. Yeah.
This, the nice thing about these is this is great for visual. I mean, you put this in visually and it just pops.
Yeah, it does.
Yeah, you see less of the stars and
yeah,
the bright ones pop. Guys, I'm starting to get clouded up on the west out here.
Well, keep them there. Don't send them over here.
John, what have you been doing? I know you've been doing something there. What have you been doing tonight?
Actually, I've been doing a little imaging on Saturn, and I got to process it. I took different exposures, and I got to stack them. So I took dimmer video of Saturn, and then I took stills that were brighter where Saturn was basically blown out, but I got the moons and I got the stars around it. So I'm going to stack those as a composite image. So I got stars and moons of Saturn, along with Saturn being in not blown out when I get done with it.
Well, you gotta make sure you email us so we can see that.
If it comes out good.
I'm going to drop, guys.
Yeah, I am too. I'm old enough where I'm ready for bed.
Well, my day started at 5 a.m. So it's been 19 hours for me already.
If anybody else is staying on, I'm going to stay on because I want to try to get that Comet 67P but that's not going to really be up till 2:30.
With clouds, you may not get it at all if what you're seeing is happening.
Yeah, if it moves on over, I'm about halfway clouded up right now.
But wait, this is part of the deal. You got to stay up till 2, 3 o'clock in the morning when you're doing this stuff.
No.
Oh, when we do this
for
stuff,
astronomy?
we usually wait till the sun comes up.
Come on, man.
We've Tim or John, tell him about the times we spent outside laying on the benches at Island Lake for hours.
I'm not gonna be able to hang with you guys. I can already tell you.
We went home in the sun. We went out, and the park rangers were coming in at 6 o'clock in the morning to start their day.
Oh,
the sunrise, and we were leaving.
No.
Yeah, it all depends.
You, me, Ken Anderson.
I had that Comet last year or the year before where I did the dusk till dawn viewing of it, and I put that video together. So yeah, it was going, getting dark, and I had it captured at dusk and photographed it all night long and put the video together of the sun coming up the next day.
You guys like just down in energy drinks or something, or
no
coffee?
No, we just grew up here.
No, it's I think it's when there's a special event, like comets are special, and they're not there all the time. So you want to catch it while it's out, and that's what my excitement is something that's not up every night, every day.
See, my dream, like Gordon and I were talking earlier, my dream is like I get it all set up, I start filming, I snuggle down into the bed, and I set the alarm for 4 and check on how it's going.
No, that's not the fun.
Well, if you build an observatory, you can do that. Otherwise, you're on watch.
No, you got to get out there, man. It's
I hear you, brother. I do. I know.
You hear the coyotes at night going. And
oh yeah, that sounds like a good plan.
No, we hear them all the time. Yeah, in this area. Yeah.
Yeah, especially when they hit the kill. Oh, they start yiping. And,
that's just eerie. I've heard that. It's so eerie.
I have a recording of them in my backyard. Because we have the nature preserve south of me, and then immediate north of me, then I have the state park directly north of me, Kent Lake. So I hear them all the time at nighttime, at about 10 or 11 o'clock. When I take my dog out for a walk at the end of the night, you hear the coyotes. And one night around midnight, I was just getting into bed, and they were so loud. I mean, like you swear they were in the room with you. They were that super loud.
That's creepy.
My doorbell, I have the recording. My doorbell, my Ring doorbell, not Ring, my Google doorbell recorded them, and you can hear them on my doorbell recording them yelping and hollering in the backyard.
Yeah, that's every once in a while I find a feather, spot with all feathers that tore up a bird.
But birds will do that.
Yeah, well, that's what I'm saying. It probably
was kill a small bird.
A hawk or no, these were big birds. So it was either a hawk or an owl.
Yeah.
Barn probably a barn owl in my neighborhood.
I've seen a starling eating a baby finch, and the parents are flying around and trying to stop it, and it would kill it and eat the finch.
Yeah, those are small. No, I'm talking about, 1 foot birds that, I
Yeah.
see the feather pile.
Probably an owl or maybe a coyote or something got him.
Gordon, you were going to say something. What were you going to say?
Well, what I was gonna say is, you guys are worrying about these coyotes when you're sitting in the safety of your house. Go down to Lake Hudson at 3 o'clock in the morning and you're the only one there, and you hear something in the woods crackling behind you.
That's the werewolf. No, see, that's the werewolf. And I know the boogeyman exists too. The boogeyman, once in a while, he comes out.
No, but like at Island Lake, you have them all the time out there.
Let me tell you about the Kennedy Space Center. When we go there for night launches, where we're at, you hear the alligators in the background in the woods. They got the wild boars in the woods.
No, if it can eat me, I'm out. I'm out.
Oh yeah, that's when you see those wild boars. Those are the ones that get me. The crocodiles or the alligators, I don't worry about the alligators because they're scared of people.
No. If it can eat me, no. Mm-mm.
Yeah, those wild boars, I don't know where they came from, but they're getting infested over there.
It's like
Now
those snakes. Those snakes that are big enough to eat you in some of these places. It's like, no.
Yeah, those were from, I think there was a hurricane down there one time, and it flooded out a pet store. And a lot of the snakes got out from the pet store, and now they've just been going wild in the woods there in Florida. Another thing a lot of people don't realize is they have what they call Chimpanzee Island down in Florida. It's from when they were making the Tarzan movies, and they had the chimps down there. Well, anyways, they left them there after the movies, and now there's one island that's got all the chimpanzees. You think you were in Africa?
Seriously?
Yeah. Yeah, that's I got to get pictures of that. My brother-in-law, or not my brother-in-law, my niece's husband, he says he's going to take me to that island one day. So I'm going to have to take him up on that.
Liam, are you asleep? Did you go to bed already?
No, but I'm getting ready to. The eyes are slowly but surely dragging down.
I was watching you.
My days have been insane.
Look, man, every time I call you, I don't even have to ask you what you're doing, because I know every time I call him, I'm working.
Even at 8 o'clock at night.
I'm working. I call him early in the morning. Are you up? Oh, I've been up. I'm like, man.
I normally start my day at 5 a.m.
Okay, here's the North American Nebula. Here's the first.
Oh, that's nice.
That's really cool.
I got to get over to that.
This would be a lot better. This is a modified camera, so I'm getting all the hydrogen alpha that I can through, but this would be better with a filter that kind of I call it a quasi narrowband that gets you the hydrogen alpha and the O3 band and blocks everything else, and that would really make this thing start to pop.
See, that's the other thing I got to learn all about. There's so much to learn. There's so much to learn.
Brian you went to his target, and now he sees it.
I just wanted to tell you guys, I went to George's today. He's doing good. He was outside blowing the leaves around, and Pat said hi to everybody.
Good.
She was, her color didn't look good. I know George said, that she has her memory problems, but she was looking more like cancer or something, that yellow tint to her. I just hope she's all right.
All right, I gotta go. So I'll see you guys, man.
I'm going
take care, Jess.
Going to bed.
I'm going to drop out too.
All
I
right.
badly need my beauty sleep. I'm on here again
I
tomorrow.
know. Yes.
I would actually, is anybody going to stay on?
Yeah, I'm staying on.
Well, can I turn over host to you?
Yeah, if you want.
Okay, because
You'll be running on your own then, John.
I'm actually starting to close things down here. What's that? Okay, got oh, a second. I'm taking down software here so I can get.
Do we have any other people? We still have people on YouTube or what's?
We still have 7 people right now.
Tell them I said bye, Tim.
All right, Greg Connectlian says hi and bye.
Oh, hey, Greg.
I was here.
I want to.
I left.
So I can either make John host or I can make Gordon host. Who should I make host?
Make Gordon a host. I want to go up. I got to get a different camera. I want to piggyback it on my scope and get that set up. So I won't be able to do anything for a while.
So
The folks on YouTube, I don't have any access to seeing that from here, right?
You can see the chat. You can just go to youtube.com, Astronomy for Everyone on YouTube. Go to videos, and at the very top, you should see this event. Click on it, and it's muted, and the chat will be there, and you have access to the chat from there.
Okay, wait a second. Let me.
Yeah, go to YouTube/Astronomy for Everyone.
I just lost this. Give me a second here. I screwed something up.
We still see you.
Yeah, but I don't see anybody else. I don't know what the heck I just did.
Oh, go up to your upper right-hand corner.
Yeah, but I don't have an upper right-hand corner. That's what I'm afraid of. What did it do to me here? All I can see is John now. I don't have anything else. What happened here?
It's just a view change. It's okay. Just do what you need to do.
yeah, that's just how. Yeah, that you have.
Oh, wait a second. There we go. I got it again. I'm sorry.
There's a view menu that you can, do you want to see the gallery view? Do you only want to see one person, whoever's talking? You can control that.
Okay, what am I going to YouTube?
Go to YouTube and find Astronomy for Everyone.
Actually, the link is youtube.com/c/astronomy for everyone.
You don't need to put it in the C.
Just
Yeah, you think I'm going to memorize that, right?
Just go to astronomy, Google Astronomy for Everyone, and it'll pop up.
Yeah. And when you go in there, when you get to the page, you go to the videos page, and at the very top will be our event. And you'll see this showing live. You click on that, and that'll bring you in there. And hit mute the moment you go in. Mute the audio on the bottom right-hand corner, and that's all you need to do. And then you can see the chat there.
Okay.
You got it?
I think so.
You see us?
I see, yeah, and I see
being on screen.
Yep, and the chat is on the top. There it is.
And the last comment was Brian saying awesome, right?
Yep.
Yep. So you just watch that, and if someone asks questions, you can answer them verbally. Is probably the better way to do it. So I want to say one thing. Everybody who's still out there, thank you for hanging out with us. It's been fantastic. I will say, if you have not already done so, please give a thumbs up to the channel. Click that subscribe button so you're notified when we go live again tomorrow. And we will be here again tomorrow. And every time we post new videos for Astronomy for Everyone, which is our TV show that the club runs.
Our award-winning TV show.
Sorry?
Our award-winning TV show.
Forgive me. Our award-winning TV show, Astronomy for Everyone. You'll get notified when the new episodes gets posted each month, so you actually come and watch those shows as well. And as a club, if we're going to do public observing through a virtual public observing, we will do it through just we will do it through this channel. So please like, subscribe, make sure you give us that thumbs up, and if they want to get reminders, click on that little bell beside the subscribe button and select all, so you get notified when we do all of everything we post, and you'll keep up to date on what we do. And I'm gonna hand you over to Gordon and John. I need to go get my beauty sleep badly. And thank you all for hanging out. It was fun. It's great. It was interesting, and I hope you all learned something. And I will see you all hopefully tomorrow night. Thank you, guys. It's good night for me, and over to John and Gordon.
Yeah, I just wanted to mention a few things about the Astronomy for Everyone TV show. If you go on the videos, we have, our last one was getting ready for the James Webb Space Telescope. That was a very insightful talk we had with Amy Oliver from out in Arizona. And the one before that, Tim Campbell and myself, we take you through how to photograph an ISS transit of the sun. And that was a really neat video that we did. And we had gone to a local park here in the Detroit area at Hines Drive. And basically the International Space Station going in front of the sun is about 1 to 2 second time period that it only takes to go past the sun. So you got to do a lot of planning, and we tell you how to do the planning, and we tell you what apps we used, and we give you a lot of insightful information so you can take pictures like what we show in that video. So check it out.
Well, what I thought I'd do, since we did, I assume everybody saw it, can see the North American nebula we got here. Right next to it is the Pelican Nebula, so I'm gonna find that and slew to it. Oh. Actually, that'll fit in the field of view a little bit better than the North American did. Actually, I may. Yeah, let's do that.
Yeah, I'm not going to be able to show anything out here. I'm getting clouded out.
Well, I suspect that then it's not going to be long before I'm in the same boat. So let's see if we can get this one done, and maybe that's as far as we're going to get tonight.
Yeah, I don't know if you're going to be able to get the Pleiades maybe after that, but it might be too close to the moon.
It's actually clear for me down here.
Yeah, down south or east of me, east and south, it's clear. But the west is, it's coming in from the west. I can barely make out Saturn, Jupiter still popping through the haze.
Oh, wow. Well, if you come down to the city where the light pollution burns off all that haze.
Yeah, the light pollution. Yeah. Yeah, I'm in one of those one streetlight towns. Yeah, and then damn car dealers. I got 3 car dealers on my corner. Oh, that's the bad part.
Why are we getting the? We're getting some trailing. I don't know what's happening here.
Got any cord wrap going?
I don't know. Without going out there, let me see what the next image looks like.
See what happens when you get those trailing stars like that. Something's causing the motors to bind, and it's not tracking the stars.
I may have been a little bit too hasty with the taking the image here.
Oh, you didn't give it a chance to settle down?
Yeah, that may have been. Let me come over. I want to get that one out of the. I want to get that first one out of here because it'll mess up the stack. All right. All right, let's start a new stack. Let's see how this works this time. See, it wants to make the thing.
Now, what program are you running there, Gordon?
It's called Easy Stack. It's a suite of software that was developed by this Dimont, and that's a nice thing about PixInsight. It's an open source type thing, so you can people can actually write script and write software and submit it in, and people can just start using it. And when people write good things, then the people who kind of run PixInsight will grab onto those really good things, and they'll incorporate them right into the base software. So a lot of the stuff that's comes into PixInsight is being developed by users.
So is this a plugin for PixInsight?
Well, yes, but it integrates itself right in as a script. I know you can see where it says script in here.
Oh, yeah. Mhm.
Okay. I've written scripts to do some of the, some easy things. I'm not an accomplished programmer, but some things that I want to automate. I'm going to kill this thing because it's not doing the color. So we'll go back and start it up again. So here's an easy processing suite. And there's in this suite, there's a easy deconvolution if you want to really start getting fancy with your processing. There's a denoise. There's a high dynamic range script. There's a soft stretch and a star reduction for reducing the size of stars. So this guy has written a series of packages that to automate some things. His noise reduction is actually his easy denoise actually does a pretty good job.
So how would you get that into PixInsight?
Let me get out of this thing. If you go into resources and updates and manage repositories, you can see here these are the PixInsight repositories, and when they issue new software, this is where they get posted to. And when something changes in there, PixInsight, when it starts up, goes out there and looks and then finds any updates. And this guy has created a repository on the Sky Pixels. And so anytime he makes an update to that software, it automatically gets updated and you get a notification and download the upchanges.
While you're doing that, I'm going to take a look for my PixInsights and see if I got to update that.
Yeah, I am going to go ahead and drop off, and I'll see you guys tomorrow night. But now that Gordon host, it will not disconnect you. As long as there is a host, it will keep going.
Okay, let me get this live stack going here again. Started the live stack and get these in here. And now I got to put the flat. See, this thing does a some calibration, and so I created a master flat, which is not a good one. That's why the thing's not looking so well. And I created a master dark, which is in my calibration, and it's this one here. And I got to tell it its color and then start watching forward. And there it goes. Now we got the color in there. This is not coming out as well as the other. I'm surprised. Let's see what happens when we get a few more frames in.
Oh, there's a lot of stars in there.
So here's the Pelican Nebula. So that's what we should be seeing. And it's kind of lost in here. This is not being pulled out very well. No, I don't know, maybe the clouds are coming in. I wouldn't be surprised what that image is starting to look like.
Yeah.
Tell you what, I'm gonna go stick my head outside and see what's going on. I'll be right back. Yeah, there's some high, thin clouds passing through that I think are messing, and they're right about where the North American Nebula and Pelican are. So I think that's why this is looking so mucky.
Okay, Gordon, I have the Pix Insights and I got the repository. Let me share my screen here for a
Yeah,
minute.
I'll get out.
Okay. Are you out?
Yep.
Okay. Now, share the screen. Okay. Now, I'm looking, this has the update, weighted batch processing script. You know what that is?
Yep. Okay,
What's
where
that?
are you? I didn't see where you went to when you did this.
Oh, I went to resources. Whoops. And then,
Yeah, close it down and start up because I don't recognize the screen. No, just close down that.
that one.
Yeah,
Okay.
no,
Okay, so I went to resources and then I went to updates.
oh, the one I was in is manage repositories.
Yeah, right here. Okay, let me. Okay.
Okay, so you got the 4 Pix Insight repositories, and when you open Pix Insight, every once in a while it'll come up and say you've got updates, right?
Yep.
And that's what it's doing is when you start Pix Insight up, it goes to those 4 directories and looks to see if there's any new or updated files there. And if there is, then it tells you you can update them. And so what I've done is I just added the one from that easy processing.
So how do I add that?
Well, you can just let me see if I can.
Well, here do I
won't
check
let me do anything while the script is running. Nothing takes over.
well, should I hit OK here and then get out?
I think what you can do a web search for easy processing, or when this thing is finished doing this Pelican Nebula, I can pull up the URL for the easy processing, and then you can copy it into that.
Check for updates. Let me do this.
So you're just doing manually what it does at the beginning of every when you first start the program up.
Okay, so I'm just going to hit select all and then apply.
They should have already be there. Oh, that's, huh.
Okay, now the repository. Oh, this is doing something else now.
Yeah, I'm looking at this Pelican. It's completed and there's just too much stuff up there. It's too hazy to pull that stuff in anymore. So I'm gonna pull a plug on this one.
Can you get the Pleiades? Is that up yet?
Let's go take a look.
Okay, I'm gonna stop sharing. All right, it's back to you.
Let's see. Pleiades is only 24 degrees up and 78 degrees. So that's probably behind my neighbor's house. So and at only 24 degrees up, it's not the best place to be. So, well, I think my thought is that we call it a night. I think the skies are starting to deteriorate, and we're just going to get mucked. But here, what I'll do is let me go to.
How about the moon? You got the moon? One last view of the moon for people that are still watching.
Let me do this. And I will copy this.
I got a pine tree right in the way of the moon from where I'm at.
And then chat. Okay. So I just put in the chat that repository. Can you see it? www.skypixels@hvb.
Hold on a minute. I gotta get their chat one. Yes, I got it.
Okay, so take that, including the backslash that's on the second line there, at least on mine is. And if you copy that into resources, manage repositories, and then add, and then paste that in there, it'll go there and download the suite.
You don't have permission to access this resource.
Huh. That's interesting. Well, then I'd go back and do a, they're called Easy, capital E, capital Z processing suite. And maybe just do a Google search on it. Maybe you got to go in and register with him first. It's been a year or so that I downloaded the thing. So the particulars I may not be remembering right anymore. Okay, Tim is saying he got a clear view of the moon. So let's see what we can. Yeah, I got a feeling it's going to be behind a building too. Let me go look through the window. I don't know if I'm going to be able to see it from here. I ought to be able to get at the moon. Okay, now we just got to see if I can take a short enough exposure. Okay, there's 1 second. That's way too much. There we go. Am I sharing it? It's there, right?
Yep, that's here. Yeah, that one's blown out. Is that the first one?
It's, you're seeing a blown out one, or?
Yeah. Oh, there's a better one.
Yeah. I wonder why it's so. Now, unfortunately, yeah, let's put this in.
Oh, that looks better. Yeah. Yeah, on YouTube, it didn't look as nice.
Well, I don't know why I want to try and make color out of it. There's not going to be any color there. Yeah, I don't know what's the, I'm just going to blow this up. But it's not going to get much better. That's a little bit too much, isn't it? That's ugly. Down.
What's the Pleiades? Is that M45?
Yeah.
The Pleiades should be just
It says 26
to the-
degrees. Let's try.
it's yeah, it's just to the left of the moon. It's almost the same elevation. Maybe a degree or two under. Now, for all you that are still listening, or watching, the Pleiades is called the Seven Sisters, and don't really know why it's called the Seven Sisters. We only really see 6 bright stars. And this is an open star cluster. It's basically containing middle-aged stars, but they're hot, so it makes them blue. So the brightest stars are really blue, and they have some nebulosity around them of a blue gas. So it's really something to see. It's a great binocular object to look at.
Why am I not getting anything? There we go. Let's bump this up a bit.
This is also a naked eye object that you can see. And you just look to the east sky on a dark night, not with the moon there, but usually on a dark night. And this kind of tells you that Orion's coming up. So this comes up first, and then Orion comes up after. It's a great fall object to view. It kind of looks almost like an arrow up in the sky.
Okay, and I'm going to go back out to the 30 seconds. And I'm going to back the ISO off to 800. I don't think with these we need that much. Okay, now will you go back to the script again?
Now, what script was that you are running?
I'm sorry?
What script is that you're running?
It's called Easy Stack.
Easy Stack, okay, that's it.
All right.
It's starting to come in.
Now let me go over here now. Start Easy Stack. Let me put the flat back in here again. Okay, but I'm not going to use that one I did before. And look at all that stuff. This clouds up there.
Yeah.
You can see how this whole right side is getting all blown out now.
That's reflection off the moon on the clouds.
Well, that's right. The moon is pretty close by too, isn't it?
Yep.
Yeah, this is not gonna. We're too close to the moon to. The Pleiades. Yeah, here's the moon, and here's the Pleiades. So that's too close. Okay, so if we put this on the moon, we put this on the Pleiades in the center, we're only 11 degrees away. One rule of thumb for imaging when the moon is up, you want to be 60 degrees away.
Oh, wow.
And we're
Yeah,
11.
Yeah.
That's too close. But let it go, and we'll see what it comes up with. You can see the stars, but we're not going to pull out any of the nebulosity that surrounds it.
Yeah, we probably won't see the blue color at all either.
Yeah, for those that are see all this blue, there's a bunch of nebulosity that surrounds all these stars, and so you get this almost like a hazy cloud that glows blue from the hot stars in the Pleiades. And if I've got it, my M45 has never been that great. Let me see if I can find a. There's an M45 from a couple of years ago with that, but you see, I overexposed and blew out the center of all of these.
That's a fantastic shot. Oh,
Yeah.
wow, that's from a long time ago.
Yeah, that's 1913 and excuse me, 2013, 1913, right? But you can see the stars are all blown. And if I redo it now, I would take a series of short exposures and blend them in to get rid of that washed out area in the center. You learn as you go. Yeah, I see somebody, Tim Day is talking about Subaru being the.
Oh, yeah.
Oh, for those who they're still online here that don't know, we call M45 the Pleiades or Pleiades, I don't know, seven sisters. In Japan, it's called Subaru. And if you look at a Subaru automobile and look at their logo on the front or rear, and that's what you're seeing is that star cluster. So the M45 star cluster becomes the logo for Subaru.
So what all is that script doing there then, Gordon?
I'm sorry?
What all is that script doing?
Okay, you can see the processing window on the side here. Okay, right now it's finishing up the last image. Okay, it just detected a new image got loaded into the directory. So it's waiting to make sure that the file gets totally loaded. And now it runs through and does the calibration on it. So it does subtracts the dark, does the flat, then it aligns. That's those numbers that were flying past here. Let's see if I can bring it back. It won't let me. Once the script is up, you won't let me do anything. But it takes, it took the first image and then it took when the second image came, it did an alignment and aligned the second image to the first and then stacked them, added them together. And when the third one comes along, it now aligns it to that first stack and then creates a new stack with the 3 images. So
And how many images
and
are
it'll
you
keep
taking
doing that as
total?
long as no images show up in the folder. So you can see now that we've done 13 files. I'm putting the cursor on top of it. When you'll see it when it goes by, here's the alignment. It's moving the thing about, I can't even read it. It moved the image about 5 pixels in one way and 2 pixels in the other to get them registered, and then adds them together and averages them to come up with the stack.
So do you end up losing the sides of the image?
Well,
Or
if there's
the
a lot of
edges?
movement, you'll start getting it, but we're not moving very far. It's from one to the other. I'm not seeing a whole lot of black showing up along the edges here. So the tracking is pretty good. So it's not, we're not losing much. Typically when you stack, you're always going to wind up with some edge artifacts from that stacking process. So one of the things you need to do in processing is you need to, after it's been stacked, you need to go in there and crop out the edges because there's always going to be junk there. So if you take off 3 or 4 rows of pixels, top and bottom, and some columns right and left, that's typically the outside you're not caring about much about anyway. So. Okay, I think that it stopped imaging here. Let me, yeah, it's finished. So I'm going to stop watching it. I'm going to exit this and continue. And the thing the stacked image is now sitting here on the screen. And if I do a stretch on it internally here, I probably get a little bit better looking than I did in that live stack. Still not great. Too close to the moon and some haze up on the top. So I think I'm ready to call it a night here. I don't think the skies are cooperating. So unless somebody's got some specific questions to ask or whatever, I think we'll call it a night and tune back in tomorrow night.
I don't see any more questions. I see Brian's leaving us, so I said goodnight to him, and I think, yeah, that's about it.
All right, folks, thank you for joining us. I hope we've been entertaining. And I think the plan is we'll be here again tomorrow night. What I was late because I had to get my gear running. What time did things start tonight? I assume it's the same for tomorrow.
Yeah, it was basically 6 o'clock. We started ours. Now Ani started on the GLAC site, so he was doing some solar observing.
Yeah. But
I don't know how the sky is going to be tomorrow, so we'll have to see. But if there's the skies are clear, we'll have somebody that's going to be doing some some solar viewing. I'll try to have my telescope going. I know when I tuned in at 6 o'clock, the sun was just starting to go down behind a tree, so I wasn't able to bring any white light images of the sun. But tomorrow, like I say, I'll try a little earlier, and hopefully we can get on and skies will be all right. I know they're talking a little bit of rain in the morning and then clearing for later in the day. So
That's what I saw too. Do we need to do anything for YouTube, or when we shut down this, it's going to shut down the YouTube?
I think that should be it.
All right.
Yeah, Brian, I'll try to have that Saturn image done for you for tomorrow. We'll see how that turns out. All right.
Okay,
Good night,
folks.
everybody.
Good night, all. Hope you have a pleasant evening, what's left of it.